whatever their experience on data science and the future scope of data science, which will help our student as well as help each and every one those are going to participate today. So I have also, because as a director of the School of Computer Engineering, so it is my responsibility to share with you because about the KIT, about the school, and the school has approximately 250 publications per year, and the funded projects there are 3 plus funded projects are there, and 40 plus books were published and edited by the faculty members. And there are 7 patents also applied, and we have published 17 patents this academic year. And coming to the workshop conference, the school is very active in that case. Every year, the school is organizing 3, 4 international conferences, industry symposium, student research symposium, innovative project contest, your techno vision, and number of workshops are the invited talks. And this time also we very successfully conducted our HR conclave, and this is the second conclave on data science. Also, the school also a knowledge partner with the foreign universities as far as the organizing different international conferences. And also our faculty members, one of the faculty also received $3,000 from South Korea for the consultancy project this academic year. And this time also we are going to organize, in addition to ICDCIT, also one of the most prestigious international conference, that is called ISEC, the 14th Innovations in Software Engineering Conference, in the month of February. The project also, school has applied a number of projects, and this time also the school applied in this academic, during this pandemic period, let me tell you, we have applied the first DST project, thanks to our Honorable Vice Chancellor, because of his support, because he is the main person or the backbone of my school. With his always, he has always mentor our faculty and students. With his support, we submitted the first project, and also technology innovation hubs. And there are many projects also applied by the faculty during this pandemic situation. And I wish that the convention, the conclave be a grand success. The outcome of this expo will definitely apply the minds of our young students to their future research as well as development work. And the only thing I would like to share with you is that this is the age of connectivity, and thanks to this online platform, where we are able to connect ourselves by sitting at home. Today, you see the people from different part of India as well as different part of the world. They're able to connect because of this virtual platform. It is a very happy moment for all of us, and we have to utilize this type of technological advantages, which was not there even if when I was a student. And at that time it was very tough to even if talk to different people. So things are changing very rapidly. I remember when we are learning the database management system, people are talking about data is a vital resource of any enterprise. We have to protect at any cost. Now there are so many development of database management system. Today, then we talk about data mining, data warehousing, then data science, data analytics. I mean, data is the data. Everywhere, wherever you go, you have to handle the data. And my advice to all the students, because it is many students they have joined, so you have to make your career. So I was just discussing with our Honorable Vice Chancellor and our registrar a couple of days back. So what is the views that whatever the laboratory components we have in the curriculum, excluding that also you have to develop expertise in some specialized domain area, maybe data analytics, maybe your artificial intelligence, maybe your deep learning or machine learning, that is called cognitive computing, or maybe on IoT. Fine. So there, or maybe in a high performance computing architecture. So there are different areas, or maybe in software engineering, there are many tools are there. So once you are joining specialized labs and doing some project or some work related to specialized type of lab, then you'll be sellable in the market, because the market needs, the entire world needs the skilled people. So in addition to your day-to-day learning about the degree program, you have to also develop expertise. I hope the school will provide whatever is required from the academic point of view. We are always with our first students, and we are feel always proud because of our students, because our students are very good. That's why we feel very fortunate. And students are doing wonderful for the outcomes at the end of their for academic career, and during also academic career. It is not only the academics, but also you talk about your extracurricular activities. Student, they are given a lot of glory. In fact, also just I would like to remind the student achievement, like you talk about Make India Conclave, you talk about the Make Odisha Conclave. all the credibility goes to the students. So I am very happy that today the large number of students, they have shown their interest, and despite it is a Sunday and every day they have a classes to 8 to 9 hours, they are busy. Despite of that, they have joined. It's a very, very good moment, and I'm very, very thankful to all the resource persons, because of the, even if it is a Sunday, they are giving time to all of us. So giving time is a very, very tough task in this competitive world. So I am very, very thankful to all the esteemed resource persons, those who have given their time, valuable time for us, for enter the data community groups. And again, so with a good thought, we pray to God, let this conclave outcome will give lot of opportunity to our students as well as all the researchers who would like to do research in data science. Thank you all.
For your earnest welcome address. Now I would like to welcome Mr. Indrashish Das, Product Analyst, High Radius Technologies, to say a few kind words about the Student Coordinated Data Science Group, School of Computer Engineering, KIT University.
Hey Sandeepan, just let me know when everyone gets to see my screen.
Okay now.
Okay.
It's
A
visible.
very good morning. A very good morning to all the dignitaries, our esteemed speakers, all our faculties, the data science group team, and all the attendees of the Digital Data Science Conclave 2020. So today I will be discussing the roadmap that our data science group has traversed all this time. So the data science group is a self-motivated group of students which started back in 2016 at School of Computer Engineering, KIT deemed to be university. And it started with Dr. Siddharth Rautare and Dr. Manjusha Pandey as our guides and mentors back then, who are still our mentors at present as well. We also had a team of amazing seniors who are now alumni, and the team included Sandeep Agarwal, Kashyap Barua, Sabyasachi Chakrabarti, and Harsh Mishra. And that is where they have always helped us grow the roots of data science and machine learning within the students. But everyone must be thinking, right, that where is data science group in 2020? So in 2020, we have grown to a group of 45 plus members and conducted 100 plus sessions and 300 plus hours of coaching and mentoring. And you can also see that these are some of our sessions that we conducted at School of Computer Engineering back then, when everything was normal and we were not having the pandemic going on. And also collated some memories in our previous workshops and some of our group photos as well. Also, we have published over 70 plus research papers and journals in several reputed national and international conferences, with 30 plus projects in the domain of data science and machine learning. And that is where, as very rightly said by Dr. Alfred Marshall, a very famous British economist, that human wants are unlimited. And that is where we expect to grow more and more. And I wish that data science group keeps on continuing the good work that it has always done. Also, I really feel happy to share the fact that we have received 800 plus registrations for Digital Data Science Conclave 2020, where this love and support has always kept us motivated all this time. So I really wish all the best to the esteemed speakers and the data science group team for Digital Data Science Conclave 2020. Thank you and have a great day ahead.
Thank you, Indrashish Bhaiya, for your sweet words. Now I would like to call Professor Gyan Ranjan Mohanty, Registrar, KIT deemed University, to address the digital conclave.
Yeah, thank you. Thank you, dear Sandeepan. A very good morning to all of you. Honorable Vice Chancellor, KIT University, Professor Hrusikesh Mohanty, esteemed Director, School of Computer Engineering, Professor Samresh Mishra, esteemed Dean, Professor Bhavani Prasad Mishra, esteemed Dean, Research, Professor Satpathy, esteemed distinguished speakers of today's Digital Data Science Conclave, our guest, Professor Atul Negi from University of Hyderabad, the esteemed speakers who are now present in this inaugural meeting, Ms. Bhavna Sena, our alumni who is now presently in Cummins, USA, Professor Arun Kumar Balkrishnan from Coimbatore, University of Coimbatore, Professor Rabinaran Shubudi from our School of Management, and Sri Ajitesh Shukla from High Radius, and the convener of today's program, Professor Manjusha and Professor Siddharth. Most respected all my colleagues, faculty members from School of Computer Engineering, and esteemed deans and directors from the other schools present in today's inaugural meeting, and esteemed participants and my dear students. It's my honor to be here in this virtual inauguration meeting for the Digital Data Science Conclave 2020 on the theme Role of Data Science Post-COVID, organized by the Data Science Group of School of Computer Engineering. I am happy to note that there are 14 keynote talks by renowned speakers from industry, from academia, and from the research groups. And also our alumni who were the part of this data science group during their study here, they are also our eminent speakers today. We feel proud that 7 of our alumni are our resource person today. On behalf of KIT University, an institution of eminence, I am privileged to welcome all the distinguished speakers and alumni speakers to this virtual session. My sincere gratitude to all of them for accepting our invitation to deliver their address on the theme role of data science post-COVID. Hope we'll meet in the premises of KIT University for some other occasion when the conditions are normal. I wish this webinar, this conclave, will serve as a platform to inspire our young researchers, our UG students, our PG students, PhD scholars to start their research work on data science and to be part of this data science group. I congratulate the team members of data science group for this noble initiation. Thanks for doing excellent job, as I have already now the video showing by Mr. Indrasis, our alumni. So seeing that how many sessions you have conducted and the workshops you have conducted, you are doing excellent job. It's very good. Nice to see your initiation. I also urge all my colleagues of School of Computer Engineering to create research group in the area they are working and include the interested faculty members and students from other schools for multidisciplinary research, which our Honorable Vice Chancellor is always asking us, telling us that do some multidisciplinary research and involve all the schools so that the faculty members from School of Law, or School of Humanities, or School of Applied Science also can work in this group. So, I can say, or I am sure, our faculty members of the School of Computer Engineering will definitely be inspired from the prolific speakers today's present and will follow up their research work. By seeing our alumni speakers, I hope they are juniors who are present today in this meeting or in this conclave who have registered, will definitely be motivated to join in their interested research group. Alumni are one of the pillars of the university. The growth of the alumni is the growth of the university and vice versa. My sincere thanks to all our alumni speakers for their involvement and their cooperations towards their alma mater. So COVID exposed the uncomfortable truth about model drift, where the accuracy of models suffered from the changes in time and data. Monitoring models to improve the resilience of AI solutions would therefore be a definite focus of the future. Having a well-defined and documented data science process would become mandatory in most organizations. Today, when the whole world is suffering from COVID-19 pandemic, we at KIT University envision to enrich education. Quality education and research is the hallmark of our university. Recently, our university was declared as the #1 self-financing institutions of the country for innovations by Atal ranking of for innovations and achievement. The core value of our university are bonded with the principles of kindness, compassion, empathy, and discipline. These are fully supported by our honorable founder, Professor Achyut Samanth's humanitarian philosophy and participation of key stakeholders. We know for the success of any webinar or any conclave, any conference, how much pain the organizers usually take. I, on behalf of the university, earnestly thank the organizers and the entire team of data science group. My sincere thanks to the student organizers, the students who are the team members of this data science group. With this, I wish the success of this digital conclave. Once again, I welcome all the esteemed speakers. My sincere thanks and best wishes to all the participants present in this conclave. Thank you all. Thank you.
Thank you, sir, for addressing the conclave. Now, I would like to call Professor Rishikesh Mohanty, Vice Chancellor, KIT Deemed University, to address the digital gathering.
Thank you, Mr. Sandeepan. So thanks for inviting me. Good morning to all of you on this digital platform. And my special regards to your director, Professor Samresh Mishra, the registrar, Professor Janranjan Mohanty, and the person of the day is Dr. Manjushri for hosting this wonderful webinar conference of the data science group. And my respect to Professor Subudhi, Senior Professor of Management, and mostly my colleague of English Network, who has time to be there. And also one or two of my students of English Network all of you here. And dear students, you were wonderful. I just had a look of English. I remember English. I have several times. And corridor, I had a chat with him. I think if he remembers, if he remembers that, I can recollect. I think the kind of a work the group has done is very commendable. And certainly, I hope this will be a seedling for to grow it much bigger and many more research groups to emulate. I have been telling that there are thousands of hands in the KIT having 30,000 students, and with thousands of hands they deliver the kind of the quantity and the quality of is, I think we need to harness this potential with all of you, and this is a model which shows that this is achievable. And I congratulate the school for doing it. And this the school of computer engineering is an amazing school. The kind of a volume they have. It itself is an university. I tell to the director that you are the vice chancellor. The kind of a volume the school manages, and it manages with such a precision, and at the same time it delivers the research output. I think it is amazing. This is I myself I just can imagine that and this is achieved because of this young uh, minds like you have given your hand. I could now see that how passionately you work in lab, and you are we are making, we are discussing that how many more labs, different thematic labs we can make in your school, so that more and more students will get attracted to more and more very special research groups. And computer science is a very young science, and that is why in this conference you see there are very one or two old people like me, or I don't know Professor Sugati if I tell him to old or not, but I am sure we see that there is 95 and 99% of the attendee in this conference they are quite young. So this is what the young science, it needs young mind, and and I think it is the school is on the right track to explore the excellence in this in the computer. So I also my special thanks to Miss Sina and all the alumni who could make it. I mean, I think Sunday is. I was telling to Dr. Siddharth, the Sunday is not the right day to have this stand up. Actually, Sunday I usually take off. This is the principle which I followed since 30 years. Sunday is my day, but still in Sunday you are here. I must I can see that how much passionate you are. I really appreciate it. I appreciate your kind of a attachment to your group, to your work, the passion in it, and I'm sure with this passion, you will have a long go in your career, and your career needs that. Your excellency somewhere score with with excellence, you need a passion, and this passion, I think this data science group has seen. I must congratulate all of you, and this is the spirit of the KIT University, and that's why in a very short time, this university has become a institute of eminence. I mean, to the this envy for many institutes of the contemporary institutes. And this is the spirit which the honorable founder of the university. I mean, you see that the spirit is you can't. There is no match for it. It is absolutely surging ahead. This is because he is passionate. He is passionate of doing something. And he does it and shows that it is doable. And this is what you have shown, that you have a passion, and I think publishing about 300 papers in 4 years. It's an amazing feat.
Kojak spoon deve.
Pardon me? So I wish that your passion will continue and you inspire the young, the followers, write down the years, and also I I must thank that all these distinguished speakers who are delivering today, and I think they will be much more inspiring, and wish that this spirit goes ahead for years to come. Thanks, Dr. Manjusha, for hosting this wonderful webinar, and all my distinguished colleagues who are here, and here in the Sunday also. I can see Dr. Bindu Angarwal, and I think Dr. Lipika, and many other the faculty, Dr. Mahendra, and Kunali, and many other faculty members are present here. I think I am really very happy to see that in Sunday you could afford some time from your family to be here and inspire the young minds. And if there are some other students from some other institutes, I welcome all of you to this webinar, and also I welcome you to visit the school once pandemic is over, and you will see that feel the energy the school always radiates. Wish you all the best. Have a great day. Thank you very much.
Thank you, sir, for enlightening us with your words. Now, I would like to call our mentor of Data Science Group, Dr. Manjusha Pandey, to give the vote of thanks.
Thank you, Sandeepan, for coordinating the session so nicely. Good morning, everyone. I'm Dr. Manjusha Pandey from School of Computer Engineering. I'm really honored to propose vote of thanks for this first ever Digital Data Science Conclave, which our group, Data Science Group, has planned. And that was planned on Sunday because we wanted to include many of our alumni who are actually free on Sundays. So I know it's really worthy for all of us to take out time on a Sunday, and I thank each and everyone present here in this August gathering for making it on this Sunday morning. To formally start my Thanksgiving, I'll first of all like to thank our honorable founder, sir, Professor Achyutananda Samanta, sir, for providing us such a world-class institute, which has provided us with so many brilliant young minds and provided us with such a intellectual gathering of professors, teachers, from whom we are also learning and we are helping our students to learn from. Along with a humanitarian background, he has developed two institutes, two world-class institutes, one which is a technical world-class institute, and the other one that is KIT University, and the other one which is a humanitarian world-class thing, which is our KISS University. Secondly, I really like to express my gratitude for our Honorable Vice Chancellor, sir, for kindly accepting our invitation on this Sunday, and also wishing us at DSG to grow within your guidance, sir. Thank you for following our thank you, and we'll be following your suggestion to include more and more young minds into this initiative called Data Science Group. We are really motivated by the encouraging words said by our registrar, sir, Professor Gyanaranjan Mohanty, sir. Thank you, sir. Thank you very much for emphasizing the usage of data science and data science processes in all the organizations as mandatory processes in the coming times. And this is what our conclave is also based on. Thank you, sir, for mentioning that and motivating us. I'd like to thank Professor Samresh Mishra, sir, Director, School of Computer Engineering, for such a warm welcome to all the resource persons as well as to all of us. I'll also like to express my thanks to all my faculty colleagues who have worked tirelessly throughout the last week for making this conclave a success and for making this conclave happen. I like to mention their name explicitly because they are the people who are behind all the show which we are seeing today. I'm really thankful to Mahendra Gaurisaria sir, Amiya Das sir, Bindu Agrawal ma'am, Krishna Chakravarti ma'am, Mamta Motwani ma'am, Madam Junali Zena, and Madam Lipika Devangana. I'm also thankful to Mr. Jayaprakash sir for his technical support. And last but not the least, I'm really thankful to all my student coordinators at Data Science Group who have been working since months for this Data Science conclave
पूजा
happen.
ये
I
देखो
also like to thank Mr. Jayaprakash for the technical support, for all the technical support he has provided. And I'll welcome as well as thank all the eminent speakers and our alumni speakers at this Data Science Conclave. Thank you all. Thank you for joining. And I hope that this Data Science Conclave will have a takeaway for all of you. Thank you very much.
Thank you, ma'am, for such a wonderful vote of thanks. With this, we come to an end of the inaugural session of Digital Data Science Conclave. And now I request Faculty Coordinator, Professor Junali Jena, to take over for the first technical session.
Thank you, Sandeepan. I wish a very good morning to the esteemed dignitaries, distinguished speakers, respected faculty members, my dear students, and to everyone present here. I am Junali Jasmine Jena, working as Assistant Professor in School of Computer Engineering, KIIT deemed to be University, and I, on behalf of Data Science Group, School of Computer Engineering, welcome you all to the Digital Data Science Conclave 2020. Data Science Group was first created in 2016 by a group of self-motivated students and alumni and mentored by the faculties of School of Computer Engineering. I feel extremely privileged for getting a chance to host the first 3 sessions of this remarkable event. There are few informations that I would like to convey to the participants. To submit your questions, a Google Form link will be provided in the chat box in the middle of every session, and another Google Form link for the attendance will be shared at the end of every session. Kindly ensure your participation by filling the attendance in the Google Form, following which certificates will be given. Without further delay, let us welcome our first speaker, Professor Dr. Hrishikesh Mohanty, Honorable Vice Chancellor KIIT deemed to be University. He is also serving as a professor in Central University of Hyderabad and has completed his PhD from IIT Kharagpur. He has profound interest in research areas like distributed computing, software engineering, business process re-engineering, and mobile computing. Today, he will share his expert opinion on the topic that is data mystics and sciences. So I request our Honorable Vice Chancellor, sir, to take over the discussion. Sir, please.
Thank you.
WhatsApp ग्रुप पे है मैं यहाँ
Thank you. Thank you, Ms. Junali. Thanks, Dr. Manjus and the group for giving this opportunity for delivering a talk, whether it is distinguished or not, that is you to say. But you know, I know that I have a risk of opening batsman, whether you make 0 or 100. So, but I don't want to take that challenge of opening batsman. I am sure other distinguished speakers will tell you something very much about the the subject. They are very actively working in the research and the practitioners and doing research. They will tell you about the particular problem and know how they solve it and what is the trend, all these things. I mean, I honestly, I should say that no, I am Not this is not the research area as such, but still I'll tell you some story. What probably this is the Sunday. I think it should go with a very light talk, and so what Dr. Junali introduced me, I think if somebody believes it just like that, and it is a myth. You, if somebody tells that, okay, I think this is usually told goody about, in a conference or in a somewhere, these kind of things, and this could be like that. So, and he or she tries to see that exactly what the was told is correct or not. They would like to verify it. I think that is where the science comes, and the science is verifiable, and that is why it is the truth. And the philosophy is somewhere, you would see that, what is there. If the Shakespeare tells that what is there in the name, and so what is there, all these introduction telling so many information about somebody, what is all about, and then you just remain unattached to all these the adjectives what they are told about, and that is why the philosophy about the data with somebody. So I will tell something like story like this. I think let us not spend some time here. But what is this myths? No, the information, I think data I'm telling about I think it's not only numeric, but it could be the symbolic and so how these myths are around this data. We live around, we live with it. We live with, see, when the child is born, then they say that the Satima, it makes your whole data. It creates all whole data, and your luck file is created, and and it is really locked. So this is what the data is created about a being. And in Odisha, there is a bony bird. I don't know how many of you know this bony bird, but you can take it as a parrot. Parrot. They say that if you see one parrot, then it is not good. If you see two, then it is good. Good day you have. So this is where the myth goes with the number. And of course, there is a Chitragupta, when the Brahma made the creation, and then and the creation beings were to burn and die, and then the Yamaraj told that I don't know who is to when, who is to die, and I can't how to bring them. I do not. What do I do? I do not have. I cannot do both the things together. So then Brahma created a child. That is the Chitragupta, and the Chitragupta keeps all these accounts. It keeps the whole data of the total creation. So this is the data is and it is, if it is Hindus believe that life is circular, and that's why the file is already always open. It is just goes on in a append mode. So this with the pluralistic belief, we have something 33 crores of God and 56 crores of lives, and and in you have in the Puri temple, you have the 56 types of prasad. This is what I know, types or the amount. 40 means it's a measure. So this is the word the prasad. So number goes with the God also, and with this monolithic belief system, it's like Islam and Christianity. So they have their belief. They believe that there's a God. So God, if you see that they are not not visible, nothing. So you said one, then Son of God is the Jesus. So this is the one. And now Adam and Eve, the creation started. No, this is the two. So how this data has gone with the belief system. The Islam believes the void. It's like any Sunyabad you have, like Raja Raman Rai, or here in Odisha you have Achitananda. All these, they're void. They're just this a data which is not interpretable. So this is what we have. So what is now the myths? Myth is the data is something like we have the belief system. All these myths is the celestial data. So 56 crore lives, 33 crores God. These are all celestial data. And now the data, everybody says that where is the data? Data is in cloud. So this is the myth goes with the data, and now this myth persists. So now that what we have seen is that the whole universe is like a turbo data generator. It creates the data. So you see a mythical Brahma, or the Chitragupta is the writer, or you see that the human mind, it thinks, you have some information you create. So this is what we have our the data generator, and what is that the science in it. So the science is in creating the data, and and deriving the information from a given data. So this is what the cosmic play. If you see what the mythical, the mythology says that this is a cosmic play. The computer scientist see is a data world, and you process the data, you predict, you infer, and you understand, get some information. So I will just present now one paradigm of this the data creation, and the kind of a data understanding, getting a semantics from the data. So you all know, computer science students, the entity relationship. This is I always admire this, this is a small concept, entity relationship, and it's such a beautiful one. Is a so little, so easy, but it's a profounding, its impact. And this is what is the research has to be there. It has to be simple, it has to be beautiful, and it should be impactful. And that is why the database systems, you see that how it is it is in the prime stage everywhere, in theory or in applications everywhere. So this is goes with the entity. So this is what, if you see, the whole world is an entity world, and and this is a huge framework of for the data generation. It's a turbo data generator. This is what is the world I view. So now is a simple example I give you is something something human. You see that human in 3 dimensions. This is what the human knows. It's a knowledge is the kind of a skill the person has. So what he knows, it's not that what is the only degree, and what is the resource the person has, and where the person is located. This is a small picture. I got it from while I was visiting last year the Baragada Dhanujatra. I saw that, imagine a person was making a sugar candy flower. The kid is watching to have it, to to see that how he is making it. It's a very beautifully, he was making that sugar candy flower and selling it. So I'm sorry, uh, this could be a little. So this is what the habitat where a person lives this is the entity relationship model. So you have a person, you have a resource, location, knowledge, and the kind of a requirements a person has. Person wants to achieve something. So the person, what he wants to achieve something, that is strategize. The person strategizes with the data available with him. So, no, kind of a resource the person has, where is the person located, and what the person knows about. So with that, person wants to see that something is achievable or not. That is what the inference it makes it. It makes a decision making to take the next step, what the person has to do in its life. So so this is what a model I just see it. And then from this model we generate a kind of a functions. It tells that a person needs for a person P, for an objective Q, it requires resource R. So this is what imagine that I have a function which will tell me. I will apply that if I want to achieve something. Suppose I want a good job in data science, then what the resource I needed. So this should give me a list of resource. So if this is similarly, if I want to do a get a good job in data science, then what kind of a knowledge I should have. Suppose imagine that I have a function for that, and so it gives me a list of the skills I need to have. This case transfer that. Similarly, to for the location, where should I study or where should I take the training so that my expertise in the data science is good. So this is what the functions I have. And with these functions, I create more and more information, more and more data. So this is what is something like having a knowledge, a person having a knowledge K, and and having a something a present Q, the objectives. Then of course he wants again to add some more objective. This is what the person is becomes much more aspiring to achieve more. I think there was internet was showing that there is much more to to gain in the life. That is what is modeled here. So this is what the generating it is the resource and the moving to a location. So person having the knowledge, then it knows that what it is achievable, what more it can achieve, what resource it can generate, and and where the which place it can go. Like Bhavani has gone to USA to make more money. So this is where this is Bhavana. I'm sorry, Bhavana has gone to USA to make money. That is what the location. You want to change the location. So this is what you can. This is I don't want to add. So this is having the resource, then having the location. So this one you will see that in in this uh, in this what this shows is that a person being in that the three-dimensional space, it creates the the different new points where it can traverse. So this gives a growth. So this gives a small model that how a person makes a decision having with these functions. It makes a decision to in its life or to achieve its goal. So this you will see that it is an infinite loop. You generate resource, then then it goes what location it should go, and with having a money you can travel to somewhere to earn more money, and you can generate also do and also do more money. And similarly you can also generate more and more knowledge. Also having the resource, you can take some new course or new training and generate knowledge. So this is something, once you have that, this is a choice, then this is an alert. It shows that, you have more and more ambition, you add this ambition of the life, it continues. Then if it is, ambition is, if it is not achievable, you say that, on failing to actualize the ambition, then you take a decision that, if it is not achievable at this location, then I must go to some other place. If it is, my knowledge is not enough, then I must acquire more knowledge, more training. No, if I want something, I need something to achieve my ambition, I need more resource. So this way it goes. This way it goes, and that the life is an infinite loop, and and with a infinite length of the queue you have. It's a queue. You process one objective, and you add more objective. This goes on. So this is a simple example. What I have given is that, this is a simple example I have given, that is with a, you can, this is a simple abstraction of a person. If I see that how a person makes a decision, and now it, it schedules its activities, then this model helps me. I can work in this model and refine this model. I can just make it personalized, and you can use it for you. This is this shows that, the data, this is for a person. If you take for an industry, it takes for a particular project, you takes for a railway station, you take for the airport, any the functional things you see that. I think we need to see that, we see to say that how the entity is generating the data, how it is creating the data, and the functions. What I have seen that, we need to understand that what are the functions, those can be applied on this data to infer either, to infer some objective, or to generate more and more data. So this is essentially, this is what is we do in, we do in the with the data. And what we do is, it's a science, because we, if with the data, we can trace it, that where from this data has been generated, and and what is, why this decision is taken. I can prove is that these are the functions applied to the data, and that is why this 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 decision has been taken. So because I can prove it, and and I can deduce, I can prove. That is why this is a science. Even if I predict it, it may be, this is more or less some percent true, but I can say that, how good is my prediction. So that is why it is a science. But let us see that, this is the new world. What is this new world, particularly when this corona has given it? The world is going to be the world of buts, the software buts. So the world is, the entity is no more the kind of no more kind of a person what we described in the previous example, but the world is going to be a software world, or you call it is a but world, and this but world will multiply the human being into end times. So if I will just sit here, and if I have some work in municipality, if you want to do some negotiation with somebody, or I have to brief my lawyer, anything. So I will create my software buts, and release it on the internet, and to do this business. So I now replicate into 5 times, n times. So this is what, a person is now, will in the but world, a human will become n times. It's a n times copied. I mean, you can have a variance of the human. So, and at the same time, they are mobile. you can find them, or you can say that no, omnipresent. You may find my interest in the railway station. You may find my interest with the lawyers. You can find my interest with in the bank, or you can find my interest with the doctor at the same time. So because that is what is my software buts have gone and now doing the work possibly simultaneously. So this is what they're mobile, they're omnipresent, and they're mission specific. They are doing a particular job for which the software, mobile software bot is created. So this is going to be the new world. What I keep telling about in many lectures, this will be a world in future, and this world is the is is the will generate more and more data, and this is what that's why our concentration, our interest is with the data. So now let us see that what are the different aspects of the data I can have. A person have is a person specific data. Then if the place to which the person is attached to, even if you are in Australia, but still, if you have gone from Angul, your data is also will be Angul specific. So this is the place has got a lot of variance with the data, and what is the agenda you have with you. So this is what the data is that way is created, and the time, and of course the postulations, the predictability of an entity, which also creates the data. So these are the different aspects of the data, and this is the data is created, whose data it is, and for whom this data is created, and what is the purpose with this data. So when data are created and data is data are collected, these are the questions one has to ask. So this is a very important when we generate the data. Then when we generate the data, of course, we'll have a syntax. What is the kind of a format the data can make it? And so having a set of data, what the structure you can make it, how you can join this data is like a jigsaw puzzle. We put the different pieces and we make a structure. And this is what in the digital world we need to bring out the structure hidden in the data. So this is what all these techniques what you have, you essentially find the structure, and particularly those who do this, the bioinformatics, the genetic data, they process it. They try to see that what is the structure this gene strand makes it. So this is the finding the structure and giving a meaning to this data. So just collecting the data is not enough. I think there must be a meaning to it. There must be a semantic to it, and you should be able to make a story about it. So this is what this is like investigating agencies. They collect the data, they join it together, and they see that they are composable or not. So these once they're composed, then they look for that Sushant Singh is murdered, or he is made a suicide. So that is what is the data, the story you would like to have from the data. So this is the now with all this common sense what I have told. I think you the computing professional, computing scientists, you do it, all these things. You cluster this data to see that what are the symmetry they have, how they go together. So what is the kind of a similarity they have, and you do the classifications, and then you conquer. You try to join them, and you use your artificial intelligence techniques, and you join them, and and inference. You make it. What is the kind of a inference you can make it? You can always map it. That what kind of a techniques I am trying to map it. I don't want to. You all. I have seen the students. You all are working with that. So this is a kind of a general framework I'm telling the way we need to think about, and and we need what are the different steps involved in processing the data, and what is science in. So this is very important. That there has to be a science in it. It is not that the deep neural network is there and the MATLAB has got a library. I just use it. So it is not like that. It is to understand is that why should I use this with a deep neural network? Why at what context? At what is the problem state where this is used? Why not I use the fuzzy logic? When I use the fuzzy logic, when I do use the genetics programming, genetic programming. So this is what is required. This decision making is required, or I use a couple of hybrid of techniques to make a decision. But to make a decision, the data science has got a major problem is that the you can just churn it and get something, and you just keep drawing the diagram and tell something. This is what is the this is what I would like to put a caution in the data science research is that there is must be a science of it, and this must be a this like most of the heuristics computations. I think they lack the probability. These deterministic deterministic algorithms, like they are very steady because they are the provable. You need the complexity. You can just do the simulation and prove it. But this is what is the kind of a natural intelligence or AI techniques is, particularly the deep neural network, has to worry about the provability of the system. I think some science, there are some work is now is going on towards that. When there is a lot of criticism about it, then the people have started thinking about, and there are certain works on that already has started been appearing, getting published. So, so this is what you can, if you want to make a metric of your data processing, probably you can make a matrix with the C's, what I am talking about here. And the last one is the concept, the data secrecy, data maintaining the secrecy of the data is very, very essential. So how, if your data processing, how much security it gives, that is also a kind of a metric you, to your the processing. So this is what I think for data science you have to be a very, very good in the mathematics, and but mostly this is the abstract mathematics, discrete mathematics. You need to have a very good expertise. Of course, that statistics. I think the spelling is wrong here. So, and the computing, the algorithm, making the algorithm and provable algorithms. This is what we need to to have. These are the drones of data. I say they are invincible. The trio. So the more if you are research in the data science, you must be a good in mathematics. Good in some, even expertise on the statistics, or you can expertise with the algorithms. This is what is required. No, it is not really to see that use the black box MATLAB, kind of a the black box, and and get some data processing and get some information. So the applications, of course, this is unbounded. You know, I just put it, to make it very interesting. Yeah, I just see you when you talk about the three worlds. It is complete universe. So this is what the epics say. So you have Swarga, Martya, Patal. So everywhere you can see that you have the applications of the data. So if you want to the up in the sky, if you were wondering that where is God, today morning I got a in the WhatsApp one a beautiful video. One of my colleague in applied science, I don't want to take the name. I think he sent me a beautiful video which gives a very deep sky, a new type of galaxy they have seen, which is again a cluster of a galaxy. And usually you don't see that kind of a formation. And when you see, particularly when you see in the early morning this kind of a video, you will wonder, what is this universe is. So if you are wondering about the, in the something like in the dark sky, in the dark night, if you are looking at the sky and wondering that where is God, I think you are right in the data science group. And you talk about the astronomy. And I know one of my one very young like you, I think he took a BTech in computer science. And and also another minor in physics. And he chose to do PhD in the astronomy. And he didn't go with this. He was studying in a very good institute, going for software job. He could have made a wonderful salary job, but he has chosen to the astronomy. And he did his PhD in the astronomy in Rochester. And now he's a independent scientist in McGill in Canada. So this is what the computer science. Though you may be computer science graduate, but I think your passion should not kind of a bounded with this computer science placement, this and that. I think you should see the big world, and where your excellence, you can show the excellence, and you rejoice the exploring the world, exploring the universe, exploring the knowledge. And this is where you're working with astronomy, the data science with the weather. And data science is there in the sky missions. The nation is taking up so many missions, in the exploring the sky. I think where the data science have a lot of role to play. You can opt for some job in the ISRO and be a part of it. And the Martya is now the COVID made world, where I think everything goes in the safe distance. I don't use the word social distance. I think this is not a good word. I think the word you should use is the safe distance. And with the safe distance, when you operate, and mostly you choose to operate in the cyber world. If I hope I am with the time. Okay, I should try to keep the time with me. Mm. So, you have a lot of digital footprints. And digital footprints in the social media, in the birth world, governance, banking, everywhere. There is a digital footprints, and you have lot of applications. I think in that way, the world is biased towards the computer science actually. So it is now today's is your world. So I think the more interesting when you look down, I think you look down. So is there rare earth? The rare earth is a material which is absolutely now required. And most of the rare earth is with China. And now everybody is getting deep into the underground and see that do they have rare earth? Of course, you have all other wealth, where this data processing is required to understand that, before digging, before making boring, to dig deep. We need to forecast, predict that what is the availability of the mineral, and of course the much wanted is that the electricity of life. We need a lot of the models, data models for the predictability of water in a particular places. So this is where to I think you all know this. I think so what is more important is that what kind of a questions you can ask while you as a data scientist. Who can give me required data? I think whom can I bank upon for data, and is that true? What is told the data is true? This is the very, I think that I will take the epic uh, incident of Mahabharat. War is going on, and then the Asustama is killed, and Guru he wants to know that whether he is killed or not. So is that true? Is that true? That is the question came to him, and so then then he then he thought whom I can bank upon, who will tell me the truth. So this is what is the he looked at the Yudhishthir. So Yudhishthir, that's what he thought he could bank upon him, and so so but he also showed that who can give me the required data. He went on asking those who are at the forefront on the war. He asked many people, and but then he showed that whom there are the variant information, and then he told whom I can bank upon. So, but the most important fourth one is the most important is that does it make money? So, Dr. Dunali, you can ping me if I am shooting the required the time slot.
Uh, yes, sir. We are means already the slot time is up. So, sir,
Okay,
I
so
request you to, sir, please wrap up quickly,
okay,
sir.
I will try to wind it up as early as possible. And I think the store is data. It is to be available in time whenever it is required, and so what is now the point is that the it does not go unnoticed in the digital world. Nothing goes unnoticed, and no, and it is nothing you have forgotten. And no, I know that this record this is also being recorded. So how how it is this is what is going to the new world where in the store use and again you store it. This is the kind of a sustainability of the data. So how does it do? So how does the Chitragupta does that? Chitragupta keeps the file from life to life, from one life to the other life. This is what is the research problem the data scientists have to do. And I will just skip the philosophy of the data, but I I don't want to take your more time, but I just want to say that you just see that beautifully. You say that from 0 to 10, you just see that for each, philosophically, you have the you can just map it from 0, which is the void, which many belief system thinks that everything is void. The physics also tells that it is the void, but the epics and all, they just the Shankaracharya told that Aham Brahma, that is the one. I think you can the Saptarshi, the seventh. So Shadari, Ripu, Panchabhuta, and all this. They see the data. The in old days, our saints, they were very much aware of this the data, and associating the dharma to the data. So dharma is that the data scientist has to follow this dharma is that the use the data only if it is what for it the data is created. So that is the dharma. And if you are using the data, then take the permission of the person for whom this data is meant for. And you don't make the clandestine business of the data. So that is what is the dharma. And the The other one is that we see that in shopping mall, our cell phones he takes it and then later he sells it. So this is what is the other one. This is not the and this is data river. This is the somebody is dead, then it's data to the river. You don't have to misuse that data. So this is what the data does it die. So I think the data has got. Does it have a immorality, and does it have lifetime? How long the data can be stored, and that's what is the joke part is that you're careful of charts and the talks. So this is what everything is remembered, and what chart you have made. Tomorrow the CBI or somebody should not call that. This is the chart. This is the data is available. So this is what is the how important the data is, and thank you very much. Uh, for this, I think thank you all. I think I don't want to take much time. I think I've talked.
Thank you, sir. The session was quite informative and it gave us a very different perception of data in today's world. Like, means it gave a very different perception in a very philosophical and historical way. And sir, you very nicely just related it to the modern day world. So thank you so much, sir. Um, I request all the participants to fill the Google form for the attendance purpose. Moving ahead to the next session, we have Professor Dr. Arun Kumar Balakrishnan to honor us with his presence. Professor Balakrishnan currently works at the Department of Computer Applications in Coimbatore Institute of Technology, and he is also the director and co-founder of Igwal Software, which focuses on developing machine learning solutions in challenging domains to continuously improve the performance of the software systems. He has eminent knowledge in areas like machine learning, deep learning, image processing, natural language processing, and predictive analytics. I welcome you, sir, to the Digital Data Science Conclave 2020, and would like to request you to throw some light on how artificial intelligence impacts health and education. Please, sir. Sir, I guess the screen is not visible, sir.
Junali madam, I am trying to contact you.
Yeah, okay, sir. Okay, sir. Um, in the meantime, sir, um, so I think Professor Balakrishnan is having some network issues, I guess.
We can wait 1 minute. Just I am contacting him.
Yes, yes, sir.
Madam, sir is asking to wait for some time. He's just connecting some net issues there.
Okay, okay, sir.
I think generally you must ping 5 minutes before to the next speaker so that
Sir, he was there in the actually meeting, but I think he has some bandwidth problems, some network issues, sir. So that's why he couldn't share the screen.
no, if you ping, you at least know that what is the
Yes, sir.
status, so
Yes,
that you
sir.
can reschedule some next speaker.
Yes,
That
sir.
will
Yes,
be
sir.
possible, so that there will be no
Yes, sir. Yes.
waiting.
Sir, with your due permission, sir, in the meantime, we can take up some questions actually from your session. Students has asked some questions to us.
Okay. You have you're
Thank you.
okay.
Thank
You
you so
can
much,
ask.
sir. Thank you. Um,
It is there
sir,
in chat box. Chat box. It is there or what?
sir, we have collected it in the Google form. They are with me, sir.
Okay. Okay.
So,
You are.
sir, the question as asked by Abhishek Raj. The question is, sir, as you addressed us a new world, that is world of bots, can you please guide us? What are the pros and cons of these worlds?
What are the pros and
Pros
cons?
and cons of this world.
Uh, okay. If you there is a both sides in everything that is the both sides you will find it, but the certainly there is something good is that you can do many mundane things by sending your buds instead of going yourself, and otherwise you waste a lot of time. Probably you can be much more creative, and or you can read a good novel, or you can write a good novel, and so instead of going and spending time in a very mundane work, that is the plus point of it. And the 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 negative part is that this you know uh, there will be a certainly the world will be something like I should see it's not a non-beings. I need not be the inhuman, but the world will be full of the non-beings, and there will be a kind of a parallel world where thousands, millions of the bots are swimming, and that is something a world in between. It is there. So there will be there could be war among the birds. It could happen also like that way. And there will be some bizarre situations. It may come up. So if you're if somebody is targeting, they may not know. There could be another governance itself for the software bots, those who are on the cyber world. So this will be certainly a new world, and of course there will be a complexity of life will be there, and that will be handled. But that is the way that things will go. I think we need to see that how technology can be tamed for the benefit. It is if you have read the novel, I think some of you might have read, but if you have not read, I read the novel. Long back it is written, the Frankenstein, the novel, which is the industrial revolution started, and that time the Frankenstein is written. I read, but I have forgotten the writer's, the novelist name. But that time also same apprehension must have been there. But the world has moved from the industry to cyber industry. So we have to think that way.
Yes, sir. Definitely, sir. Everything has its own merits and demerits, so we have to do a trade-off between the both. Um, Professor Balakrishnan, are you with us?
Yes, I am. Thank you for waiting for now.
Thank you, sir. Sir,
Yeah, I'm there with you now.
yeah,
Let,
yes, sir.
let me just check whether I'm unmuted. Yes, I'm unmuted only. I apologize for this delay in getting on,
It's
and
completely fine, sir.
we had some little bit of difficulty in something to Zoom. And thank you for waiting. Sorry for the net connection problem that we had.
Good
Thank you for
morning,
waiting.
everyone. Good morning.
Good morning, sir. How are you?
Fine. These people have dragged me on the Sunday here.
It's nice to see you and hear your combination of Indian mythology with computer science today. So that's always wonderful to see the Vedic influence on computer science today, or a perspective, I should say. I think my net connection is a little unstable today. This is one of the problems of COVID that I really haven't gone to my office to give this. I'm doing it from home. Anyway, let's see what the best that we can do. I'm sorry about that.
Just simply, if you can't share, you can talk.
Sir, you can share us the PPT also.
Yeah.
We will be displaying the PPT even, sir, if that would be okay with you.
Either way, so I can, so one, you can allow me to share the screen. No, I think I've already done a share screen.
Yes, yes, sir.
Yeah.
You have given the permission, sir. You are the co-host.
Okay, sure. I'll just share the screen now.
Yes, it is coming. Yes.
I hope you
Yes,
can
sir.
see my screen.
Yes,
Yes, sir.
yes, sir. Yes, sir.
Good, good. So what I wanted to talk about today, I hope we have a collection of students and professors, researchers, and industrialists with us. What I was looking at can be used to expand humanity's horizons. What I would like to say is something that has been on my mind for some time now, that there are people in this world who are challenged people. The fact that they're challenged is not in any way, should not delimit them. So people who have some difficulty in expressing their thoughts, can we use technology to remove that handicap, that obstacle, and allow them to come into mainstream? I hope you're able to hear me and you're able to see my screen.
Yes, yes.
So that's you're able to see me. Yeah. My, of course, before I even get into it, my thanks to Professor Mohanty and to Professor Siddharth for this opportunity to talk to all of you. It's very kind of you to think of me as one of the people who can be a speaker to Data Science Conclave. Thank you very much for that. So I'm talking about the expanding horizons is what I would like to talk about, using AI, using technology. AI in health, can we reach out to challenged people? Idea is that today we have situations where people who are visually challenged, we are able to actually help them using AI. I will run a small video now, and you share the screen and that also. Share my entire screen. Hope you can see the video that is being played back.
Sir, video is not showing. I think you have to share with video. When you are sharing, you have to share with video, kind of something like that.
Okay. You're not able to see that. What should I do? Sorry.
So when you are doing the sharing, you have to share with video. I think there's some option will be there. Share with video.
Okay, let me just share with video will be there. So share screen is there. And there's an advanced share, maybe that will content, no, not that.
So you can share the screen where the video is being played, and there is a checkbox at in the bottom left side, share computer sound, and optimize screen sharing from video clips. So there are
Yeah, I
two.
know that is big. Yeah.
Yes, sir. So if you check those two and then you share the video, I think it'll be visible, sir. So just try that once.
Yeah, thank you for the help. Yeah, but then I'm just seeing that this video screen is somehow not coming as an option to share. So I'm going to share the basic thing, and I can switch screens to that. Can you see the video screen now at least? Are you able to see it?
No, sir. You can see the PP, the
No. That's really disappointing. See how I can do it otherwise. Mini view. Well, I'm okay, a little bit disappointed by not being able to share the video.
So maybe the video is
Sharing,
from some site which doesn't allow Zoom to share it.
Beg your pardon? Come okay, this may be a video that doesn't allow Zoom to share it. Okay.
Yeah.
Must be that. Okay. There's an MP4 file. It should be possible to share, right? Please move this.
So is it downloaded in your computer?
Yes, in my system, yes.
Then it should allow.
Sir, we can see that later on. Otherwise, we can continue with the, I think, with the people.
Okay, I'll just continue with the talks. Okay, this may have been, so this is actually a spectacle that is being developed by a company in Israel, and that is actually being demonstrated also by Microsoft through their Cortana. So what this spectacles makes possible is that they have a camera in the specs. So where the face is directing it, the camera is able to capture that particular picture and in a live streaming manner, relay to the person what is there in front of this particular person. So the capacity, okay, camera is there, that's the electronics part. And that electronics has got minimized and has made this camera go into a spectacle, and that is the electronics part over there. But when this feed is coming in through this particular camera, the AI and the machine learning is able to identify objects in the particular scenario in front of this challenged person, convert that into words, and inform the person that this is what is there in front of you. So this video actually shows people being able to look at a cup of coffee. Blind people who are able to see a cup of coffee through the spectacles, reach out their hand, and there is a communication continuously about where the hand position is, and they're able to grasp the particular cup of coffee and take it to their mouth to drink the coffee. It is there in this particular video. Somehow I'm not able to do this presentation to you. And what is beautiful about this is how visually challenged people are being allowed to work as normal human beings along with us. This is the beauty. Let's see a little bit about the technology behind this. So the technology that comes behind this is one, we're doing an object of, you can see my slides, I hope. The object of face recognition is one part.
Arun sir, you can share the slide once again. You can share the slide once again because I think it is not visible properly, you can just again share the slide once.
I'll do that. I'll do it again. Visible now, I hope.
It's taking some time, it will come. I think due to network issue, it is being slow.
I'm very sorry about that. I think the problem is on my side or whatever.
Showing
On
that
Sunday, maybe my network guys are also. What if I mail this presentation to you and you can play it back from your point? Will that be better?
Yes, you can just mail me. I will just share by that. Yeah, it's, still it is hazy. You just mail me, sir. You mail me.
I'll do it right now. Okay, the video will not come in because I think there's 12 minutes. I'll put on a drive link and send it to you.
Yes, you just share the slide. I will share. Put that.
Yeah. I'm just doing that now. Siddharth sir, I've sent you the presentation.
Yes, sir. I'm just checking.
Yeah, I should have done this yesterday. I'm sorry about disturbing all of you, but I should have done all this yesterday and
not an issue, sir. No.
Got things prepared. My mistake.
Yeah, I wanted. I think it is visible to all. Junali madam?
Yes, sir. Yes, sir.
Arun Kumar sir, you are able to see? Arun Kumar sir?
Yeah, I'm also able to see.
Yeah.
So I'll just send the video also to you, Siddharth sir, and you can show me the video. I mean, or you can display that. Okay, or we just go ahead with this, and when the video has been uploaded in my Google Drive, I'll send you the link, and we'll come back and show it. Finally, also if required.
We can show.
Yeah. So this is the thing we're looking at, how artificial intelligence, machine learning can create the catchword today is level playing field. So let's give equal opportunity to people who are challenged. We're looking at how AI and ML can achieve that. Could you have the next slide, please, Siddharth sir? that is a video that, okay, so we'll go back to this. What's the technology that really allows this to happen? The previous slide, yeah, that's the correct one. What is the technology that allows this particular capability for challenged people to be working with us in a common manner? We have object recognition software today, we have face recognition software today, speech recognition, and speech synthesis. Most of this has come from the recent technology of AI being deep learning, which has been an extension of artificial neural networks. We won't spend too much of time discussing that in detail. I think we're all familiar with that. One of the things that has been happening for some years now, right from your digital cameras, is that the picture recognizes the face in the picture, also recognizes when the person is smiling and automatically clicks when the smile is happening. How is all this happening now? Look at a technology called, there is a particular model called the labeled faces in the wild, LFW here. They have been able to take multiple types of pictures and be able to train their system into identifying faces in a particular image. Shall we take the questions later? Deepshika has got a particular question, I think.
Yes,
Shall
sir.
we take it later or
Sir,
shall we
take it
end it
later,
right now?
sir. At the end of the session, we can take it, sir. Please
Later,
continue.
sure. Good, good, good. We'll do it that way. So this is able to identify where your face is. Next becomes recognizing the face. Again, technology for this. There were initial ideas where that we would be training with thousands of images of each person. We'll be training the application like a convolutional neural network. There's been a change today on what they call as minimal training sets, or what they say is one-shot deduction. The deep learning architecture that is doing that is called a Siamese net, SIAMESE, Siamese net. Idea is that you have two CNN architectures, feed this image and check with all the known people and see what is the closest similarity of this new image with the known people, thereby identify a particular person. We won't get into too much of detail in today's discussion. We'll take it in the questions if required. So that's it. Can we move on to the next question and the next slide? Sure. So we'll talk a little bit about how AI can impact education too. AI and education has been there for a large number of years now. It is very relevant today. Due to the COVID, our universities and colleges have been off limits for the students and faculty also. So this has been a case where faculty have been reaching out to students through an online media. A whole new thing of trying to do assessment through online is identifying where the faces are looking, is there any other voice in the room, all that is there. But I would like to talk about what I think can be a game changer. Once again, I'm saying that this is for the people who are a bit out of this net connection, for example, who may have to download and then play it back. Can we have a personalized tutor sitting in everybody's home? Sorry? Sure. We want a system that is adaptive to the student's requirement at a time that is convenient for the student. Can you move on to the next slide, please?
Sir, next
Could you move on to the next slide, please? Okay, this tells you the components of a intelligent tutoring system. On one side, we have a student model. One of the most important things that we try to do in this is model different student behaviors. So we try to identify how a student will actually behave, what are the different types of behavior the student will have. For each one of these behaviors, we have a corresponding teaching methodology or a pedagogy that comes into play. So we're trying to say we will not teach only in one particular way to everybody. Based on one student's preferences, abilities, and disabilities to in certain ways, we will modify the teaching to the student, suited to the best way to the student. We of course have a subject knowledge base. What are we trying to teach there? So that must be represented in such a way that we can answer questions of the students, generate problems for the students to be capable of adding on new components. We of course have a user interface, which will present the matter to the student, take questions from the student, and constantly be a way of enhancing the knowledge base too. Another component is the learning model. The learning model is using machine learning over there to enhance two major components of the internet tutoring system. One is the subject knowledge phase, where you can keep learning the new things that are happening in this subject area. And the second is the student model. This is again a very important thing because students are not the same in different parts of the world. An ability to adapt to each student at different locations is very important. And this is where the learning model comes into play and is able to adapt the student model to the location of application. Could we move on to the next screen, please? There are different types of student models. I've just given three here. The next slide will detail a little bit more on that. We call them the buggy model, the simulation model, and the learner model. Could we move on to the next slide, please? Okay, Alex. Yeah. Now the buggy model looks at behavior, meaning what errors can a student make while working on problems in the subject area. The classic one is actually for subtraction. Now in subtraction, initially you have the larger numbers on the top line and the smaller numbers on the bottom line. It's easy for you to subtract and get the result over there. Then you have a case where the number on the above line might be smaller than the number on the below line. In such a case, you have to borrow from the left-hand side. So at that time, you're taught borrowing. So at this time, the way the borrowing is taught, sometimes the teacher emphasizes it so much that the student does borrowing even when there is no need to borrow. So this is what the buggy model spoke about. What type of errors can the student commit over there? They sort of match these errors, and with the actual input from the student, they're able to say, this is the error that you're making as such. Buggy moved on to debuggy and a few more things. It again came to an end pass. We have better models than that. Could you move on to the next slide, please?
I think 8 slide last. It was the last one.
No, there are more. Oh, I'm sorry. Let me just send you the more better one then. I don't know why only 8 came in. There are more. I can only blame the net connection again, which sliced off the really. I really apologize for the trouble that
Not an issue, sir. Your voice is
Waiting
breaking
for
due
you
to some net problem, I think. Your voice is breaking. There's not an issue, sir.
and I think I've gone beyond my time, but would I have 2 minutes more? So that's
Yes.
what I will send you a mailing you the fresh document with probably all. That's what I've sent you the new mail. I hope you received it and you will be able to show it on the screen,
Yes, sir.
sir.
Just checking.
Maybe in this time we can take a few questions if somebody wants to raise them before we get the new mail and all that. We can do that, or we'll wait. Okay, I got a few chat. I'll just see if something is there. Not for me. The mail has come, so that's the.
Yes, sir.
Okay. Yeah, I'm sorry about how that went and then. Sure. So, like I was telling you, the buggy model describes errors that the student is making over there. Another type of a student model is what we call as a simulation model. This represents the process. This was built, for example, to describe how a ship will work to the Navy students in US. So there was every component of the ship was shown and how the various components interact with each other was being shown over there. Another type of student model that is similar to the buggy model is the MAL model. So we see that students sometimes do not get the correct rule to apply for a particular problem solving activity. It gets malformed in some way or the other, which is the malformations. The next model is the learner model, which instead of just looking at the behavior of the student, tries to map the learning activity of the student also. This is really was the research topic and still is continuing as a research topic in a way, being able to understand why the student is making a mistake there. One of the other techniques that was used during this time is called the on-pass model. It says that when a student is trying to solve a problem, they get stuck at some particular point. They've forgotten how to do it, or they find this is something that is new to them. So when they're stuck over there, they try some technique. What technique will they try? This is very interesting point actually, because this is in a way reflecting the student's personality. Some people are there who say, I don't know what to do, they give up. There are others who say, this problem is similar to problem that I learned in some other thing, let me try that technique and try it over here. There are others who will just conjure up a totally new technique themselves. So there could be people who give up, people who do analogy, people who do discovery. Techniques can change. This learner model was very interesting in that particular aspect. Could you move on to the next slide, please? So from pedagogy side, how can we teach now? Now there can be a descriptive way of presenting the matter. There could be examples being given to the student about what is the concept. There could be counter examples, what you call as negative examples, examples that don't work. There are certain cases where you need to present the concept through pictures or do a graphical presentation. There are other cases where solving problems in that particular domain is able to get the concept across to them. And there are other cases where there are experimentative ways of learning a particular concept. Rather than presenting a concept to them, it is taking a previous concept and going through a set of experiments to discover the enhanced concept or the new concept. So this is different ways of teaching. This is some examples of how one can teach in different methods. So these methodology are being linked to the students' noticed behavior or learning deficiencies and see how we can make those problems get better. When we try to solve the problems that the student is having from a learning perspective, you're then able to solve not only problems in that particular subject, we are able to change a learning personality for the student itself. This is really one of the aha points of intelligent tutoring systems over there. Could you move on to the next slide, please? We also spoke about how we can have a learning system learn matters in an intelligent tutoring system as such. One is the student model. We have discussed how the student model can be. So we can learn new buggy rules, new mal rules. We can learn about new processes that happen in a simulation case. We can learn and explain to the student new learning behavior. The student model is a very apt point where we can do a lot of learning happening in this. Learning can also happen about new enhancements that are happening in the world in the subject matter. It could be by, browsing the World Wide Web and getting in new things or being fed with actual subject matter. Learning can also happen about new ways to teach. If the current methodology is not working for a student, maybe the system itself can experiment with a new type of teaching, and if that is effective, add it to its repertoire of learning technologies. Could you move on to the next slide, please? Some of the examples of intelligent tutoring systems have been this Steamer, Buggy, Y, Cognitive Tutor. So Steamer was, like I said, was used to explain how a steamship could work. Buggy was applied in the subtraction module. Y was used to explain why rainfall would occur more in certain areas. And the cognitive tutor working with different domains in mathematics was able to model how the learning was happening. That is one of the first attempts at learning models. The subjects to which these have been applied are geography, electronic circuits, medical diagnosis. A lot of work has been happening in intelligent tutoring systems to help people program better. There have been mathematics applications and so on. Well, that sort of, I think, completes what I had to tell you people. I'd like to say that there has been a Gartner report which happened just before COVID happened, which spoke about how AI could be used in India. They identified about 30 different domains where AI was extremely relevant. When this report was published, COVID had just sort of come in, and they had just a footnote to add that due to COVID, all these 30 areas became all the more relevant. So I think AI and ML is very well poised to be a technology that can be modifying how India can shape up. It can make education really better, and once education can get better, it can have cascading effects on the whole world. It can also make health better. I believe that once health and education are taken care of and you provide enough food for people, well, we can see a big definite change in this world. Uh, we could probably see whether we'd like to run that particular video, or if there is no time, we can leave that to something you can see later.
Sir, we can later see because next speaker is ready, I think, sir.
Sure, I can share it with you now. I can share the link for you. And
Sir, you can share the link. We can share the link.
And we can show that at the end of the sessions.
Yes, sir.
Sure. I'll share the link to you now. I'll do that.
Thank you so much.
Thank you so much, sir. It was quite a knowledgeable session, and it really helped us in gaining some clarity about the technologies and models that are used for healthcare and the education. Due to shortage of time, participants can contact Professor Balakrishnan through the mail for their queries. We are sharing his mail ID in the chat box. Thank you so much, sir. So the next speaker in our panel is Mr. Ankit Kumar Sinha, who is currently working as a machine learning engineer at Mr. Cooper, which is a Texas-based company. I feel really proud in announcing that Mr. Sinha is an alumnus of KIT University and has completed his MS from University at Buffalo. in Newark, USA. His expertise areas include software development, machine learning, computer vision, reinforcement learning, and deep learning. I welcome Mr. Sinha to Digital Data Science Conclave 2020 and would request to give his insights on the topic, that is data science solutions for COVID-19. Mr. Ankit, are you here?
Hey, Jonali, thank you very much. Am I audible?
Yes, yes, yes.
Yes,
Ankit.
yes, you are there.
One more request, Mr. Sinha, please kindly wrap up the discussion within 20 minutes because we are really running late.
Yeah, sure, no issues.
Thank you.
Cool.
Ankit, please share your slide.
Yep, sure. Uh, can you give me 1 second? I believe I have to quit the session. I believe the Mac needs Zoom to give access.
Okay, okay, sir.
Okay.
No issue.
Or you can share the slide with us. I can show from here. You can just, yeah, it is there.
Yeah, it is there. I think he left and will join soon. Yes, no,
Oh,
no.
here.
Yes, 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 yes.
Can you see the
Yes,
slides
yes.
now?
Yes,
Yes,
yes.
Perfect. So I believe it's good morning for you guys. So good morning, everyone. I believe the introduction was already given, but still, I am already alumni of KT University. I am from the batch 2014 to 2018, and I'm currently a machine learning engineer at Mr. Cooper in Texas, Dallas. And today I will be talking about data science solutions for COVID-19. So I hope the slides are presenting.
yes, yes, yes. Absolutely fine. You can go on, Mr. Ankit.
Perfect. So let's go with the introduction about what exactly is the case right now. I believe we all know that data has been a key factor in any kind of health issue, right? People have been using it as a knowledge, experience of old medical cases to solve the present issues. From ancient times, the use of evidence experience literature have been taken into account for a treatment of any kind of disease. But now we have another form of data also, which is digital, which can be used in, with the expertise of experience and literature also. On that front, I believe we all know this creature, right? It's the elephant in the room. It's known as COVID-19. So yeah, for that, right now, we know there were many data available for COVID, not exactly COVID-19, but for COVID like SARS and MERS. And scientists have been collecting data for these and have started using data for understanding better the nature of COVID-19 itself. So how can we possibly solve or help humanity in this front? What are the solutions in place? I will be going through few solutions. It may be that it's not very relevant in many scenarios, but it helps definitely in one way or the other. I'm not covering all every basis, but yeah, I will be covering a few. And to make it a bit more interactive, uh, I think it's better if people start putting their own suggestions or something like that. So I will be putting up few questions. Nothing is right, nothing is wrong, relevant to the solution which I will be presenting, and people can bring up their opinion, thoughts, what they feel could be a solution for this and all. So coming up with first thing, right? What can be done with literature available for COVID? Literature as in the natural language data. We already know, right? For COVID, we have many different kinds of data. For SARS and MERS, people have been researching on it. They have a good amount of data. So what can we do? Anyone wants to have any suggestions? What can be done here? And if you are typing, please let me know.
I think, Ankit, you can proceed with the things. We will be taking up the queries and finally discussing at the end.
Okay, cool. So coming to the first solution, right? The first solution is a COVID-19 open research dataset challenge. It's basically present on Kaggle, and it was created by White House and many leading research groups like Allen Institute of AI, Microsoft Research, IBM. And it's made from the extensive data in the formal literature collection, which is machine readable. So uh, is the website visible, by the way?
Only the PPT is visible.
Can you guys see now?
Not yet.
Okay, I believe I can only share slides on Zoom.
Yes, yes, yes.
Sorry,
That's
it's
right.
my first time on Zoom, so I'm not pretty sure how it works
It's okay.
exactly.
It's okay. It's okay.
Yep. If you go on my slides, which I've shared, you will find a link to this Kaggle website. Here you can see that there are many questions on this challenge exactly, which needs to be answered. And if you go on the website, you will see there is 20 gigs of data set available. And to read that kind of literature and summarize it to answer the questions, it's very difficult for any researcher to do. So for those scenarios, this challenge was opened, and it's just completely open-ended. Anybody can try it out, and they can use data mining to answer these questions. The basic idea here is to answer medical research questions, which takes normal researchers to investigate and use data mining to find insights on the daily growing literature. And if you go to the website, you will see it keeps getting updated. It's currently at version 54, so you can understand how many versions have been updated. So this challenge has opened a new domain for data mining and data scientists to understand the COVID-19 and help people to invent something to fix it at least. Or I would say at least get some concrete results on it. The next is also a Kaggle thing, but it's more like a solution to COVID than to understand it, which is open vaccine challenge. I believe it's a bit late, but I believe the deadline is in 2 days. But yeah, it's a very interesting one. In here, there is a vaccine which can be synthesized using mRNA vaccine, and it's prominent right now. It might be one of these key solutions for COVID-19. In this challenge, you will see there is a Eterna community led by Riju Das from Stanford School of Medicine that has brought scientists and gamers to solve puzzles and invent medicine. I hope some of the audience might be a gamer in this. So it is an interesting puzzle gaming challenge. In this, the goal is to challenge players to solve scientific relevant problems like mRNA design through puzzle. So from mRNA, it's a very potential candidate for COVID-19 vaccine, but there is a very big downside. It has a tendency to degrade over time. And due to this, if this comes out as a vaccine, we can't actually distribute it to the whole world. It keeps degrading, and it's very difficult to transport from one end of the world to the other. So for that, this challenge comes into picture actually. So in this challenge, data scientists have been predicting the degradation rate at various locations along RNA sequence. And if you go to the website, you will find out what exactly has been happening. Any questions so far on this kind of challenges or how data science solutions are working this?
We are actually collecting the questions in the Google form. So once you complete, then we can start discussing the questions.
Perfect. I believe, yep, then I will skip this slide. Next solution is a very interesting one, which is a LUNAT Insight chest X-ray. Here, we all know right now the medical facilities are suffering from bombarding people about what exactly is happening, who is having COVID and who is not, how to handle so many patients, where to handle it. So doctors needs assistant in those scenarios also. So look what Lunit AI has done. It has developed a chest X-ray analysis system. The software provides assistant in interpretation of chest X-ray images when asymptomatic patients is admitted or even unwanted patients is available for COVID-19. Ideally, doctor takes hours to determine with PCR and other analysis to decide whether to move a patient in COVID ward or not. So basically, it's very difficult to say in a certain short period of time to determine if a patient should be admitted in COVID ward or not. With the AI assisted chest X-ray, in 5 minutes, doctor will get some kind of idea. Okay, there is a probability that the patient might be symptomatic to COVID-19, and this is done by deducting the 10 findings from chest X-ray images, including consolidation, nodules, pneumothorax, etc. Currently, this solution is being used in 10 countries like Italy and France. So it's a very interesting one, and you can take a demo of it on the website itself. I've attached the link in my Google presentation. You guys can go try it out. It's a very interesting one, and it's open source right now to have a demo. Now coming to the next, it's a pretty naive thing, but if you understand the scenario, you will get that right now the government is having going through a very difficult time, that people have a lot of questions, doubts, concerns, how to tackle so many questionnaires. People want to know the answers for very generic stuff also, which is available in the public, but they are not pretty sure that it's relevant or it's correct at the current moment. So for that becomes the next one, which is chatbot for COVID-19. It is developed by Clevy AI, and it actually targets the real-time updates from French government and WHO guidelines. And it answers the questions. It also assesses the situation and the symptoms based on the government policies to determine there might be chances of COVID-19 or not. It is currently used in the cities like Orleans to decentralize the distribution of accurate and verified information. And the verified information is very important actually. People don't exactly understand, and I believe it's very common in India specifically. There has been many solutions floating which are not even verified by the doctors itself. So for those scenarios, it's very relevant that the correct information has been given. So in this scenario, it might be a naive solution, but it's a very interesting one, and it will give the correct information on those scenarios. Now there are many more popular solutions other than these top ones, like a Blue Dot. It's a Canadian-based startup AI company which created an algorithm to predict the disease outbreak. It might not be relevant when it started, but right now, if we read it, it's very relevant to the current scenario. Blue Dot is nothing but it shifts through new reports in the 65 languages, along with airline data and an animal disease network to detect outbreaks and anticipate the dispersion of disease. And the most interesting part is it was the one of the first to raise the alarm about COVID-19. And it started working quite a while ago, but nobody was taking it seriously. But now, when we come back to current time, it's quite relevant. The next is also a very important factor. I believe everybody is familiar that COVID-19 doesn't affect each and every person similarly. Some even don't need any attention. They can even be cured without any special attention given. So there are many cases where the transmission goes unmissed. Nobody notices is nothing. So on that front, researchers from Chan Zuckerberg BioHub and AWS Diagnostic Development Initiative have built a model that can estimate the number of COVID-19 cases that go undetected. And it's very important to understand even for fixing this thing, because as we know, right, few people develop the immunity to dodge it. So for that scenario also, we have to first understand how was it manipulated, or how the mutation of the virus happened when it transmitted from one person to other. So for understanding the mutation of virus and how it spreads through population, to infer how many transmission has been missed, it's very important that these kind of models are taken into considerations. So with these, the solutions are over, but I believe it's very clear from the above solution that data science have been playing a vital role in COVID-19. This situation acted as a wake-up call for many researchers, and it opened a very big domain for research. And we already had the solutions in place, interestingly. And right now, it's getting implemented with the same algorithms which were taken into account for other use cases. So these enhancement has definitely helped for future pandemics and disaster prevention in a better way. But I firmly believe this is just the tip of the iceberg, and there is much more to explore on this when the data unfolds and we keep researching on this front. I believe I have wrapped it up quite soon. So if there is any questions, I can take it up right now.
That was an amazing presentation, Ankit, I must say. And we really got to know about some problem domains related to COVID-19, as well as some possible solutions to it also. So we have got some questions, Ankit. So first question is from Umesh Paliwal. His question is, what do you think AI or ML alone, or the integrated development of cloud computing, IoT, and AI ML will be more efficient for the solutions to COVID-19 problems?
Okay, so first of all, I believe it's going into quite a lot of domains. I, if I'm correct, then you mentioned AI, cloud, and IoT, all the three in one place. So
Yes.
to answer to this, right, it's beneficial in one way or the other. But the point is, including cloud is just a form of hosting it in real time scenarios. So it depends where you want to implement it. Coming into IoT, right? In few cases, if you have come across something like smartwatch, you will see it's not only a device which works. Sometimes the inbuilt intelligence, which is a model, that is AI, works. So it's very respective to what exact scenario you are trying to solve. But yes, if you talk about something like a Apple Watch, right, it uses all the three because it's needed in that scenario to understand, and it needs to monitor a real time also. So yes, in those scenarios, all the three are responsible, and it will provide a very good solution, but it depends case to case.
Okay. Thank you, Ankit. The next question we have from Ritvik Bose. The question is, as a data scientist, what is your opinion on the COVID-19 data shared by the Chinese government? Do you think the data is fairly credible and can be used in COVID-19 research? Also, what is the current state of COVID-19 data analysis, if any, available by the Indian data scientists?
It's quite political, so I won't comment from country to country.
Yeah.
I believe each and every country is giving out the best information they can, be it India, USA, or any other country. So still, these I, if I'm correct, one of the most important data are being handled by Musigma. They have one of the greatest data sets on this front for COVID, and they are trying to help, and they have collaborated with many of the researchers. So yes, the data sets available in India is quite relevant. And I believe I'm not quoting on the numbers. The numbers are again a political front. I won't comment on that front. But from the data for research perspective to solve the issue, I believe even be it India, they have been working very well. And there is a good amount of data which is getting curated to fix the issue.
Yes. So next question, probably this is the last one. From Sujesh Sankar Biswas, he is asking, how can we better implement data science solutions in social distancing projects?
Okay. So there is already a solution in place for this. If you guys just look for an object detection model for social data distancing, sorry, you will find there is already models in place, not in production or in real-time scenarios, but it's a video object detection model which predicts if the distance is safe or not. And it's very naive, but yeah, it works to some extent. And if it can be launched at a product which with some more features added to it, it's a very good solution with the current scenario.
Okay, so that's it, I think, for this session. Thank you so much, Ankit, for enriching us with such empirical knowledge. I request the participants to fill up the Google form for the attendance purpose. I must say this, the past three sessions were very knowledgeable and I really had a wonderful experience hosting this session. Thank you all. For the further proceedings, I request our next host, Mrs. Krishna Chakrabarti, to take over the event. Please, ma'am.
Okay, thanks a lot, Junali. And we had really experienced very enrichable sessions the last three sessions. A very good morning to all again. Myself, Krishna Chakrabarti, Associate Professor of School of Computer Engineering. Welcome all our delegates and all participants to Digital Data Science Conclave 2020, organized by Data Science Group, School of Computer Engineering, KIT deemed to be University. In this event, we know that we have 13 keynote speakers from industry and academia. Junali, is my voice coming clear? Just to check.
Yes, ma'am. Yes,
Absolutely, ma'am. Absolutely,
Okay.
ma'am.
Okay, thank you so much. So I'm profoundly elated to take this opportunity to introduce our next speaker of the day, Mr. Ajitesh Shukla. He's already with us. He is an IIT Kharagpur alumni with industry experience of 20 plus years at several reputed organizations. He is currently holding the post of Assistant Vice President in Data Science of HighRadius Technologies. He was awarded with the prestigious Star Entrepreneurship Award and has worked on a wide spectrum of technologies related to artificial intelligence. Now, I'd like to invite him to walk us through now how artificial intelligence will impact telehealth and telemedicine post-COVID-19. So, sir, welcome to our panel.
Thank you, madam.
I have only one information for the participant. As usual for the last sessions, you can put your questions for the speaker in the Google form being circulated in the chats, okay? So, Mr. Shukla, all the stage is yours. Please proceed.
Sure, madam. Thank you very much. Am I audible?
Yes, sir. Absolutely.
All right. And are you able to see my screen?
Yes, sir.
Fantastic. Thank you very much, madam. And first of all, I would like to thank Professor Siddharth for having me here, and also Indrashish for inviting me here. So yes, thank you very much. Before I start, I would just like to make a mention of my experience of some of the students from this institute. I have worked with them. I have been working with them for some years now in HighRadius, and they are part of my data science team. And I must tell that those who I have worked with, all of them are absolutely brilliant. They are very intelligent. They have been really doing some real good stuff in the field of machine learning. So yes, thank you to all of them to be part of my team and really delivering
real good thing for high radius. So thank you very much. All right. So now I'll go ahead and get started with the presentation. So today I'm going to speak about telehealth as well as telemedicine. So although I'm in the field of account receivables and I'm working in the company High Radius, which is basically in the field of account receivable, actually so to speak in fintech space. But I have made a selection of this because recently we have seen as part of this whole pandemic how people have been really worried about going ahead and visiting the doctors or hospitals and what is happening now. And it is also related to one of my research interests, which is actually called responsible AI. So I'll also be speaking about that, how it goes on, how this field is actually requiring that we all should do what is called as a responsible AI. So that's what I'll be speaking through. First of all, I'll just go and introduce myself. I'll introduce what's really the telehealth and telemedicine for those who are here. And then, I also will throw some light on how has healthcare changed after we have seen this pandemic. I will also be throwing some lights on some of the startups that we are seeing very, very recently. And then I'll talk about, the real thing, which is about what is AI into this field and what are some of the key challenges that is thrown to AI. So, and that will be mostly for all of us to think through, because this is out of my experience that I'll be speaking through. So here is what I am. I've passed out from IT Kharagpur in the year 99. I have around 21 years of experience in all fields, and since last 4 or 5 years, I've been in the field of AI and machine learning. I am currently working on AI/ML initiatives in High Radius. On my hobby part, I actually play instruments, guitar, harmonica. I also do a lot of paintings. And research interest-wise, I have been doing my own personal research in the field of what is called as responsible AI. So that's what I'll be speaking through, and how this really kind of mix with this whole thing called as the telehealth and the telemedicine. So let's go and look at what's really telehealth and the telemedicine. And I'll just go actually fast on this, not spend more than a minute or two on this, just for the benefit of all of us. So basically, when we are talking about the telehealth, telehealth is actually the large field. This is actually encompassing everything, including what is called as the telemedicine. And what we are talking in the telehealth is about the teleeducation, where remotely now there is a need to kind of train the staff. So, for example, in this time, in this pandemic time, when you have second tier and the third tier city, where you don't have that kind of staff who are that trained, you actually go and do the video training and things like that, and you also pass on the education materials such as video and all that could be used by them to train. So that's what we are called as the teleeducation. Then comes a large field, which we'll be also talking about into the next slide, which is actually telemedicine. And then we are talking about patient care services, where we are talking about data security, prescription management, and there's so many things which are comes under this patient care service. So there is actually much more to that, but I just kind of included these 3 points. Now we are going to talk about what exactly is called as the telemedicine. So when we talk about telemedicine, we have to talk about telemedicine in synchronous mode and telemedicine in asynchronous mode. And this is where AI would really fit in well. So when we are talking about telemedicine in synchronous mode, we are talking about the live discussion between the doctors and the healthcare staff with the patient. And that's why it is, since it is live, it is called asynchronous, because there is actually a request response happening right away. When we talk about telemedicine in asynchronous mode, we are talking about, hey, for example, we have actually got some kind of prescription. So you went ahead and had some kind of blood test, and then you have the report with you. You just go ahead and forward it to one of the telemedicine service. And what happens is, this is a data which is now stored somewhere, but there is something called AI engine, or some kind of rules engine. So AI as well as rules engine will now run on it and go and take the next steps. So this is where I'll talk about the robotic process automation, which will show up a little later in the slide. But we are talking about telemedicine asynchronous mode, and that's basically about I uploading my prescription, I uploading my details at some place, and from there on, a workflow is actually fired. And we also call workflow as a robotic process automation. It can also be spoken that way. So a workflow is filed, which actually takes this document, runs some kind of deep learning model prediction, and then based on that, it goes on to next step. So this is what is stored and forward. And then we are talking about the remote patient monitoring, where we are saying, hey, is there a possible? So this is where AI plus IoT comes into picture, which I'll be also talking a little in the next slide. So we are talking about, hey, if can I go and pass my pulse rate and the blood pressure and other things in the real time to some kind of remote service or some kind of remote portal, where then it again stores that data, and then it runs some AI engine, and then it goes and fires our workflow, and then it goes to next step. Am I audible? Hello?
Yes, Ajitesh.
All right.
Yes,
Sure.
sir.
So, all right. So now, so this is what I spoke about, so this was an introduction to telehealth as well as telemedicine. Now we'll go really looking into how the healthcare has changed in the pandemic, and how the telehealth and slash telemedicine has really picked up. So what has happened as a result of pandemic is internet usage has really increased. Everyone is now using internet for office, work from home, for education purpose, for entertainment, shopping, payments, everything. So as the healthcare. So we'll go and talk about that. And really, apart from increase in internet usage, what has happened is internet penetration is also getting into the second tier, third tier, and cities and the rural areas. Now that essentially means that you have large number of internet users than ever before. And then as a result of all that, what has happened is shopping of laptops, tablet, as well as mobile has really seen an exponential growth. So this is what has happened as a result of the pandemic. So now what has happened, basically now all of this at one side. Now let's see, are we, when actually now we are suffering from anything, just ask yourself, if you look at the hospital, what shows up in your mind? Is it not that, okay, I will, if I go into doctor, what if I'll have some infection? Now, at least to me, when I look at hospitals now, I do think, and if I have something, I do think, is there a possibility that I could call someone into my relation and ask for what could be the reason of this? If I'm having fever or whatever, I don't want to unnecessarily go into a hospital, because earlier days before pandemic, for small things also, just to kind of rule out, we used to go to doctors, we used to kind of visit hospital, but now it is not. And that is what is also shown as part of the statistics, which is, there has been a recent survey where people are now actually canceling all their appointments and they want to go online, or which means they either want to go by phone, by video, by email, talk to their doctors and understand what is it that they're suffering from. And of course, so if we are actually talking about about 80% of us, which we are looking to get some help online without us, at least at this time, needing to go to a hospital. So there has been a McKinsey survey recently, which says, it will just give you an idea of where we are seeing that this telehealth and telemedicine really going from here. Last year, there was just 11% use of the telehealth online usage. this year, just see what has happened. Just a matter of 8 months, 9 months, and we are looking at around 76 to 80% usage. So all of the surveys which are saying is, hey, there is a need of medicine, and you will see that many of the startups that we have, they are just going ahead and adding this element of, we also give the doctor consultation and everything, you know. So if you have ordered medicines online from 1md of PharmaEasy or Net Medicines, NetMeds and all, if you go and upload some kind of prescription, if they are not really meeting their compliance, they ask some of the doctors to call you. Now that's also a form of telemedicine. So now people would slowly be used to it. So what has happened is, now if you see, there are a lot of people, 80% of guys saying, we want to go online and talk to our doctors, at least for next some months to come. So how would we meet? So now this definitely is showing that there is a need to go ahead and ramp up our telemedicine service to the next level. So how would we go and do that? And this is where it comes. So I think we will only be able to do if we have a decent level of automation in place. And this automation, just, you know, one level of automation is a workflow based automation. You know, you go and find a workflow and it just finish it based on rules. You know, each step of the workflow, it acts as a rule. And then as each step of the workflow is executed, now there can be short-term, short workflows as well as long-term workflows, but then essentially they are totally dependent on the rules. But here we are talking about the telehealth and the telemedicine. So we are talking about some more level of intelligence, or else, you know, that I mean, basically, I'll just give an instance. So if I have uploaded a prescription, even without waiting for a doctor to say or someone to say that this prescription will need a specialist of a bone, you know, is there some kind of model runs in play which go and kind of classify the prescription as a one which needs a bone specialist? So there, you know, we need automation, but automation needs to be assisted with a technology like AI and RPA, which is also called a robotic process automation, which is kind of a next level to workflow automation. And, you know, to go and achieve all this, what we need is the cloud computing. Someone asked some time back about the cloud computing. Just the sheer need to support the whole need to expand based on the user demand, and you not having to need and set up the infrastructure on premise, you need something called as cloud. So when AI, RPA, and cloud combines, I think that will give a real boost to the adoption of telemedicine. And so, welcome to the healthcare digitization. Before pandemic, it was still like, okay, should we do it? Should we not do it? Should we do it after 1 year? Should we do it after 18 months? But now we are saying people are going and doing it. People are kind of ready to talk to people, talk to companies, talk to startups, which can help them go online. So now, so far we have seen the digital first approach to many fields, many kind of businesses, but healthcare also now will go into a space where there will be a need of digital first approach. We will need to have AI. Now AI is becoming a standard of care, because, you know, there will be elements of AI which will be put at several places. And with all this, we will need the cloud, RPA, big data, web, as well as mobile, which has been there for some time, to really work all of it to have the healthcare digitization in place. Now let's go and with all this, as I said, there are we have recently been seeing a lot of startups, a lot of funding into this space, and I just want to showcase a few of them. So Indian telemedicine startups, they have been there, which is like their names are Practo, Amfine, DocSap. All of these are there. But you know what has happened is after pandemic, they have really got a booster to the business. And now everyone is saying that they are building an AI platform which builds doctors and patients online. So as I told you some time back, synchronous telemedicine, where apart from asynchronous, they are talking about synchronous. So that's where it makes the full thing complete. Now there is also a range of startups which are working to make the SaaS platforms, because you have so many hospitals, you have so many small clinics where you actually have doctors sitting in there. Now those are the doctors which may not be able to build their platforms, right? So there is a need for a SaaS based platform which can go which basically is a white label platform which goes to small clinics or mid-sized hospital, large hospitals, get their data in, label the whole of the portal based on the clinic, mid-sized hospital, large hospital, and showcase to their patients that this is their platform, such that they could also go and serve those who are looking for the telemedicine services. We are also looking at really adoption of the deep learning for the disease detection. Now, whether you're talking about documents, whether you're talking about images, sounds, videos, we are running this deep learning models for all form of data. Basically, these are form of data. So we are running the deep learning models. We are actually training models. I'll also show you a little later. I mean, basically, when you get online and if you have cough problems, now basically something happens there. So it may so happen that doctors may ask you to cough to see whether it is a cold, whether it's a wet cough or dry cough, or it's kind of related with asthma also. So there are deep learning models which are also working for that. And as I also said that some time back, that AI plus IoT, there is a real good marriage which is going to happen between these two people, because the remote patient monitoring, which is also an integral part of asynchronous telemedicine, is going to be the key. That's going to be the need of the hour. So AI plus IoT will actually flourish due to that. How much time do I have? Oh, I have some time.
Yes.
All right.
Yes, sir.
All right. Okay. So now we are talking about some of the innovations. What are there? I have not listed many of them, but just to kind of give you an idea, what are some of those? So as I said, automation is the key now, because we are already seeing exponential growth. Now there is a difference between a workflow automation as well as robotic process automation. You know, when you say workflow automation, it could be completely invisible. Basically, as I uploaded my prescription, it goes and sit in some storage, and maybe, you know, just as you upload in that folder, there could be some kind of service which actually gets triggered. So I don't know if you people are aware of AWS Lambda kind of service, which as you upload the document, Lambda service actually fires off, and then it can actually start a workflow. But this workflow, which can be short-term or long-term workflow, can keep on running invisibly. But when we say about RPA also means that not only it runs invisibly, there could be a thing like it locks onto a site, it goes and fills the form like a robot, thinking that there is a human being filling it, and then it submits it, and then a workflow again starts. Then there comes again a need to enter something in UI. So it's actually like, you know, a human which is required to, whose presence is needed to run the workflow. Now, when we talk about that human, this is where the robot comes into picture, and that's why we call as a robotic process automation. So this will be needed because there are times when you upload the prescription and everything, there may be required to enter some value at some places on UI or something. So RPA would come very handy there. As previous speakers have also spoken, and Professor Shikesh Mohanty also spoken about the bots. You know, there is going to be bots in healthcare, and they are really going to be very helpful, because sometimes, you know, if I have actually gone and had a report of a kind of prescription with me, and I just want to talk to someone for a mere fees and want to say, hey, if I just want to showcase him my report. So upload a report and ask him, hey, do you think all is good? So what can happen internally is when I upload my report, it so happens that this upload gets into a storage. From the storage, you have some kind of Lambda or some kind of service files in, which invoke a deep learning model, which goes ahead and predict whether all is normal or not, and then it gives the answer to the bot, and then the bot tells, hey, all is okay. You actually don't need to go anywhere. So this is where, most of the time you don't really need the doctor to be there. It can just be some of the deep learning model which can do all the magic. So this is where, and then you also want some information about the medicine. For example, at this point, as I mentioned, second tier, third tier city, we just need to have people, there are some nurses, doctors asking for some of the questions. Now, there could be some of, or some healthcare staff, so there could be some of the bots which can answer some of those questions. So these are the usage of the bots. Now, there are various kind of AI ML applications now, which becomes really, really relevant in the field of telemedicine. And those of you who are working in any of this field, or who would really want to work something, they can go and select one of these and really get all the data and work on it. But there are various different applications, and all these are different form of data, documents, sounds, images, and videos. For example, when we're talking about documents, it could be as simple as I have the report with me, blood test report. I just upload it somewhere. It runs into some models. It can be either machine learning, simple models, logistic regression model, where you go and extract the data using OCR, run through logistic regression model, and it says whether you are suffering from a disease or not. If we actually look at the sound is very useful when we are talking about mental illness and mental disorder kind of thing, right? Because when you're speaking, the way actually the sound frequencies and all of it could really make a lot of difference. And then it could actually be fed into a deep learning model, which can say the state of your mental health. There are a lot of deep learning model research going on in the field of sound related stuff. For example, respiratory health. If you are sneezing, coughing, and things like that, I can run the deep learning models and say, okay, what is there a problem? Now we are talking about images. That's also a form of a data, and really a lot of research is going on in this. I mean predominantly in form of X-ray scans. We have seen for COVID-19, we have seen for heart disease, lung diseases. You go and name it. If there is a X-ray scan for anything, or if there is a CT scan, MRI scan, you can really use it to train the deep learning models, and go and say what is the likelihood or probability of a person suffering from a disease. I also found a very interesting thing, diagnosing heart disease through selfie. So, basically they say that when your skin color actually changes if you have a heart disease. And basically it's a Chinese university, one of them is doing this. Now, if you think through it, this can be one other thing where I go and take my selfie, I just upload it. So it's a kind of store and forward telemedicine, asynchronous form. So I just uploaded my selfie, and for my surprise, I actually received an SMS that, hey, looks like you would want to visit a heart doctor. Go ahead and send a message 5999 if you say yes. And when I send a message 599 yes, it just goes and trigger a workflow, which we call as either a workflow automation or a robotic process automation. So I would only say that AI cannot work in isolation inside of there. Are so many things that have to work. So that's what I was just telling you. Example, videos, neuroanalysis. One of it can be, actually doctors can ask you, can actually have pens in their hand and move the pen and ask you to see the pen, So the way they go and see you upfront, or they ask you to go and walk straight. And based on what you're walking, there can be a video capture, which will then, once it captured, it sends the data back. Again, the workflow automation gets fired. We can use deep learning models to go and can predict what is your state of mental health, or what is the state of your neuro health. So, there is so many things which are happening, and all of a sudden you will see that if you're doing some sort of research in this field, you are in the right place, and one of your researchers could really make a lot of difference. Few more slides and I'm done. So after all this, if you're seeing that, there are a lot of research innovations going on, but what is needed of it, AI, you cannot apply AI just like that. I mean, if people think that AI is about building model, I don't think it is only about that. So I would actually agree with Professor who spoke earlier about the data science process. I really have a thing to say here. When you're talking about healthcare, there is much more to be taken care for AI. So I'll just go and talk about it. So let's go and take a look at it. It's a long list. I mean, I can also put some more elements into it, but I just included only some of the important ones. Well, do you want augmented AI or autonomous AI? So when I say augmented AI, for example, if there is a deep learning model which has run on X-ray, and if it says the probability of whether a person is suffering from a disease or not. Now, do you want based on the likelihood, based on threshold? I mean, you can always go and set a threshold and say that if the probability is more than X 0.7, 0.8, go and say yes. Now, there can always be false positive and false negative. So do you want autonomous AI, which goes and says yes based on some threshold? Or do you want that, hey, I show it to a doctor and then have the doctor go and say whether it is some action needs to be taken care of that. That is an augmented AI. Basically, we are augmenting, we are helping the doctors to take the decision after doing the prediction from the deep learning model. So for some cases, autonomous AI will work. For some cases, augmented AI will work. But yeah, both of these are equally important. Second is when we are talking about health, explainability needs to be there. I'm saying in my current field in high radius, there are customers which are asking for if you're calling a deductions as valid or invalid, what is the reason you're calling? Now that is something for the field of finance, which is equally important. But when we talk about health, we are talking about a human being. So there a doctor will say, okay, if this is a prediction, tell me what are the features, tell me important 2-3 features, and how did you actually reach this decision? Third is ethical AI. When we talk about ethical AI, we talk about accountability of. So if a doctor makes a conclusion after looking at the prediction, and for heaven's sake, it actually, or very unfortunately, it comes out to be wrong, who will be held accountable? Whether it will be doctor, it will be AI, or it will be hospital. Now, these things need to be set up very appropriately. We are talking about epistemic risk, normative risk. Now, these are actually about at the baseline when there is a kind of, and when there is a prediction made, is this a right prediction or not? And that really depends upon monitoring aspect, retraining aspect of it. So these are some aspect of ethical AI. Third is AI governance. Now, some of the speakers have spoken in past beforehand. Is key in healthcare. At least it's key. Everywhere it's key, but in healthcare, test. I'll just give you an example. So one of the way to test is you have got the new data and you go and test your model with that. Another way to test is you have some experts in the field, and out of their experience, they go and enter some adversarial data and see if the model really does a good job. If not, then they include the data in the training and then you improve. So it's a kind of mix of automated way of testing and the manual way of testing. This is a field which is actually evolving. It's also my research interest, but that's what it is. Monitoring as well as retraining is key. Now, in the field of healthcare, data preparation and security is really important. So when we talk about the data preparation, let me take a look at time. Oh, I have some time. All right.
Yes, sir. Sir, sorry to interrupt you. Maybe it's just a time check. And we have questions coming on, especially on the data preparation. Can I ask, sir? Students have already posted this question.
Let me finish it. Just one more slide and then we'll go.
Okay. Sure.
All right. So we are talking about the data preparation now in the healthcare. It's key. When we're talking about data preparation, one of the key is how do you get the right kind of data, whether you go from you actually get from hospitals, from the diagnostic centers, and if you get from diagnostic centers, how you go and annotate it. So there are so many aspects of it. Then you have the aspects of the data security. There are multiple aspects of data security. One is there has to be a really controlled access to the data. Can I share the access to the data scientist, to a level of data scientist, or can I share this data to some other hospitals? So there's so many things to it. Now, then the next is compliance and regulation. So when we're talking about monitoring and retraining, now in software field, the compliance regulation mainly talks about the change control. And in software, you actually have deterministic requirements. But here, when there is a change in the data and you have to change the model and the underlying algorithm, how will you go and explain about it? So there has to be things to be put around that. And then this also is equally important, the cloud native design. So those who are interested in the field of cloud computing, we are not sure. We would like to have some data on-premise, some data in cloud, or multiple different clouds. So we need to think through some of the architecture and the design process, which basically takes care of all this issue. So how we are going to, and this all, basically, if you want to put under one umbrella, this is what is called as a responsible AI. So in the field of healthcare, in general, in the field of telemedicine, specifically, we need to, have faith in building model is just a very small part of all the things. I have actually listed eight other things, and that needs to be done in the right way. And there are actually many more, but just the 8 more important I've listed. They need to be done in the real right way. Otherwise, I don't see that we should expose this model for doing the health-related prediction for the end user. So this is what is also called a responsible AI. Some of you want to read it, you can just go and search responsible AI, Google. They actually have a list of it, but yeah, you will actually find some of it there, because here in healthcare, we need to be really responsible in form of how do we want to use AI. Thank you. Yes, ma'am.
Thank you so much, sir. It was very insightful and informative. And, just to mention a coincidence that since morning, because of some family emergency, I am just, going and using these apps for arranging appointment, a video consultancy, then an X-ray and everything. So it's really, the advancement happened in this field is enormous and really amazing to see that the seamless how this is working. Sir, if you allow, yeah. So just questions I'm, from the student that we have got. So the first one related to the data preparation that you have already mentioned as a challenge. This is regarding that the question says that a huge problem we often face when developing a machine learning model for the healthcare and medical use is a procurement of the medical data set, because we know that the high security it goes with. Okay. So related to our project, how we can address that issue, if you can just, highlight some points, sir.
See, I think at the base of it is the data security, and that is one, and that is more propelled by the compliances and regulations. So, basically, I don't know if you have been following, some of the recent news about SSR, and how whether he was mentally ill or not is being said so loosely by this doctor, by that doctor. I think they are actually not authorized to do that. So that's just one example. So I think if you ask me, yes, data, as I mentioned, data preparation is definitely one of the key challenge, because for some countries you don't have this compliance in place also. So if you can use it loosely, store anywhere and everywhere, share with anyone and everyone, and finally, if there's an end user who goes and sue you for making use of his data, that's going to be really difficult. So I think the idea is, if you have the data security practices in place, if you can showcase to those guys who are going to share with you the data how you're going to store the data, who are going to have access to the data. I mean, if it is a set of data scientists, how you're going to make sure that only the important part of the data which is used for modeling is shown. If all these are shown, I think this will, to an extent, definitely help it. Also, you need to showcase the technology that you're going to use to make sure the data is secured. So for me, there are enough tech which can be used to do the data cleansing. But the aspect is, can you go and confirm, or can you go and take the others in your faith that you're going to have the data secure? That's going to be key.
Okay, thank you, sir. So just for the time constraint, maybe we can take up only one more question, as our next speaker, Professor Ravi Narayan, is already there. Okay, so another question is that regarding the responsible AI in health and medicine. Okay, so when we talk about that, the responsible artificial intelligence, what are the different ways to tackle predictive errors, such as false negatives, etc., as a measure for explainable AI, and how should they be addressed?
I think this is a field which is still evolving. I mean, basically, I would say not only false negative, but some of the use cases, you can also have the false positives equally. So, you know, people could say, I could either, what kind of metrics that you use is also very, very important. But yeah, more importantly, to have explainability put in, there's always going to be trade-offs. Now, you can have explainability at a different level. You know, one, you can have it at a low level, or at each record level, where you can say, if this is a prediction, what went in to say that this person is suffering from a disease or not. There is actually another level of explainability which comes at an aggregate level. So this is so I have in the last 1 month, I have got this much of the prediction, out of which this much was, this is my accuracy, this is my precision, this is my record. So if we are talking about explainability aspect, we need to take multiple different metrics into the picture. We also need to make sure, because you know, once you want to go at the prediction level, you will actually have a trade-off in terms of what kind of algorithm that you can use. Not all algorithms, for example, neural networks, right? Deep learning networks, it may be difficult to achieve explainability at a prediction level. So you will have to really make a selection of algorithm if you want to get the explainability at a prediction level. So yes, there are different ways of handling it, and we'll have to make right selection of metrics, right selection of algorithms to handle this scenario.
Thank you so much again, sir. Thanks for giving your insightful thought, and the way that the medical science is advancing with the help of computer science. And I think our participants have been really, inspired and motivated to look at the future scope of the AI, which is very, very important in the healthcare region. So we just hope that this train continues even after post-COVID, because this is really helping the patients, especially at the whole old age, who are not able to go and, wait for hours in the hospital premises. So thanks again, sir.
Sure, my pleasure.
Thank you,
Thank
sir.
you.
So,
Thanks.
So when on the post-COVID, sir, we'll definitely like to meet you in person.
Sure, sure. My pleasure.
Yeah. So, just a request to the participants, quickly fill up your attendance, please. Okay. That is given in the Google form sent in the chat box. Please check. Okay, so it's just we are running a little bit late, and it is the time for our next speaker. So our professor is already there. I have already welcomed. So again, welcoming everyone to our digital data science conclave, and our next speaker, I feel really honored to have with us Professor Ravi Narayan Subudhi. With over 32 years of teaching experience at the university level, he has been honored with Senior Research Fellowship Award of CSIR, Government of India, for his doctoral research. He is an active member of many reputed international academic societies like American Society of Engineering Management, ISARC, IFORS, ORSI, ISA, and ICAS, which is the Institute of Government of Asian Scholars. Today, Professor Subudhi will be sharing his valuable insights on how COVID lockdown has induced digital consumption and digital escapism. So, sir, a very good morning to you again. So please enlighten us, sir. We all are eagerly waiting to hear from you on this very important topic for today. Please start, sir.
Thank you so much, ma'am, for nice introduction. Hope I am audible and my screen is visible, Krishna madam.
Yes, sir, absolutely.
Good afternoon. At the outset, I must thank the organizers, more particularly my best friend, Professor Siddharth, and his best staff, Manjusha ma'am, and the entire team for giving me this chance. I don't know whether I am worthy of it or not. Let me try my bit. Let me share here for the benefit of my student friends, those who are outnumbering the other delegates. This is actually based on my funded project research result and mostly based on the primary data. But as we are supposed to discuss something on the post-COVID scenario, I have followed few latest documents of international report that I will be showcasing and analyzing also. So as the theme here is what data science can do, and particularly as a management scholar, I'm looking at the application side, how it has done wonders and how possibly we can make it more application oriented so that general masses can benefit actually. So today, my topic would be certainly on the digital consumption pattern and how the future looks, particularly after the COVID lockdown. So this is a brief intro and the plan of my presentation. As you all know, this unprecedented pandemic, which has given us a very critical experience, and most of us have suffered like anything, and it has forced us to operate from our four walls, and we have done almost all activity on digital platform. Now here is a learning from the difficult time of COVID, that it has shown us how the time could be different and how we can really survive by adopting different ways also. Now here, the difference in our preferred way of functioning will be just trying to understand how we, in the process, have changed the consumption pattern, both by scale and also by diversity. We'll be looking to particularly what we have been doing here in India and particularly Eastern India more particularly. Now we have to analyze, discuss here, as the central theme of the conclave here is, even after the COVID, is it going to continue the same way? And have we learned what has been the consumption pattern and what has been the diversity implications during this pandemic? Can you just make some like strategies so that we can take benefit out of this learning? We shall discuss using both secondary data and primary data, what I was just suggesting, which will be based on my own funded research project, how it has impacted our society and also socio-economic culture also. I'll be using three latest reports which released only last month. One is BCG, as we know that, Boston Consulting Group report, and second one is International Monetary Fund report and McKinsey report. Three latest report which got released only last month. Will be using what they have to say. I think they are globally known as experts in that field, and we'll be certainly looking at what they have to say for us. Now we'll start from a brief statistics, how we started early. As early as February 2019, this is the statistics. As you can see, around 3.5 billion active social media users were there globally. And as you can see, the last two figures I'm just highlighting here, as mostly the common user used through mobile. And as far as the data suggests, we have got over 3.2 billion penetration, which is around 42%. Now, what we should review here, before the 2019 scenario, we had giants like Google, Microsoft, who actually ruled this in computing world. And next year, 2019, as we got the mobile computing, the use of mobiles, not only globally in India, thanks to the geo revolution in India also, the mobile computing increased 3 times. And then we came to face the unprecedented COVID pandemic, and some lesser known softwares like Zoom, Google Meet, and others became very, very popular. And as we are now using Zoom platform here, and it is very popular for the online teaching also. Now, some lesser known software became hot favorite of the users. Now, if you see particularly the lockdown data consumption, particularly for India, the data shows as published by Telecom Ministry of India, during the last 4 months, the internet increased by 17%, and the total per day on an average consumption was 308 petabytes. Now, if you see the state-wise diversity, the data shows, as we all know, people consume more on streaming content and they logged on to work from home. Data demand from residences rose very much as compared to the commercial areas, because many companies, offices, they permitted working from home, and the executives started working from residences. And particularly, as you know, Maharashtra had earlier high concentration, but some states like Bihar, those who were in the lower rung, there the data consumption increased very fast. It was more than 12% as against 8% for Maharashtra. We'll be going into the detail state-wise. Now let me try to tell something about my own project. This is something like a ICSR Impress funded project. And by coincidence, when we started this project just to study the digital consumption pattern and diversity, and also the escapism concept. And it started from January, and after 2 months, the pandemic happened and there was complete shutdown. Then we thought of adding few parameters into our questionnaire, how during the pandemic, the consumption pattern changed. I'll not be taking much time, and for your information, let me share, Professor Siddharth will perhaps be publishing my paper, where in detail this primary data result is being analyzed in my full paper. And here I'll be just be very, very brief, and some of the salient features I'll be just touching upon. To start with the secondary data, this is what we had when we started the project. As we can guess, the top users used Facebook, YouTube, WhatsApp, and Facebook Messenger in that order. When we started, TikTok was not banned, and this data is secondary data as we got from ministry. Now, this is something about the primary data. Let me tell you that we surveyed all leading towns of Odisha on random sample basis, and also 2 cities each from Andhra Pradesh and West Bengal. And the total sample size was 1450. The net corrected, valid, filled-in questionnaires that we finally got was 1450. Now, as we see, as we have the simple graphical analysis, as you can see, we first wanted to study how they got connected. What is the mode of connection? And mostly, as you can see, it was through personal mobile, and it was almost 96% of the respondent told they use from the mobile. And let me clarify here, those percentages are not to be added because a person who is using mobile is also using laptop. So that 96% and 42% should not be added, and it's not exclusive. And next we asked why they used and what they used in the internet. As you can see, the most preferred and most common use was for communication, maybe like WhatsApp or email and the messenger kind of thing, and for entertainment. And out of my respondents, 1450, 95% used for communication, 91% used for entertainment, and the rest is as given. Then we asked, as most of us use a daily data pack, maybe like 2 GB, 3 GB, 1 GB kind of thing, whether they exceeded daily data limit or not. And the first 2 columns is like they sometime used, sometime exceeded, and the majority they have not exceeded. So around 40% of my respondent had exceeded that daily data pack limit. And this is something like interesting what we next asked. We first asked a very candid, straightforward question. They are aware of the available of adult content in the internet. They immediately agreed, yes, there is abundance of adult content. And the next immediate question was, which we analyzed, whether they felt this is going to disturb our social fabric, whether this is going to disturb our family relation if your seniors or family members come to know. And as you can see, the first one is strongly agreed, and it is agreed. So majority of them, they felt that yes, it may perhaps disturb our social fabric if adult contents are not controlled. Next, I'll just like be brief, and we had so many other interesting parameters that we studied. I'm not using all. First, one of the things that we checked also whether the mobile net was on entire night, and whether they felt like even dead at night, they whether they had an urge of checking the net through mobile at late at night. As you can see, some of the younger people, they did use even late at night also. So this is the pattern which we got from our primary survey, and this is based on my sample size of 1450, which was like conducted all over Odisha and all major towns. You name a big town of Odisha, and we sent our investigators. It was a funded research project, and we covered around 50 to 100 per town. Next, I'll be referring, as I suggested, a few interesting and very, very important reports which published only last month. First, the Boston Consulting Group report, and
Sir, your
sorry, I think I got.
no, sir,
Sorry,
you are connected.
I got.
Share the slide once again, sir. You are connected. Just share the slide once again, sir.
Is it visible now, Krishna madam? Can you help me?
Not yet, sir. Yes, it is.
Are you sure?
It is. Yes, sir. Yes, sir. It is now again.
Okay. Thank you. Thank you. Sorry, actually, because of bad weather, it is raining heavily outside. And
Oh, no,
maybe like,
yeah, we all know these
so
are.
sorry, actually.
No, sir, nothing, please.
So what I was just telling, I'll be referring to very important reports, one by Boston Consulting Group, another by McKinsey. And this is very relevant for today's topic. And they actually studied in detail what could be the post-COVID situation globally. I'll be just citing a few results from them, but I'll be showing few statistics close home. The pictures I'll be showing in the next 4-5 slides of my own. This is what like I had taken just after Phony. I think those who are staying this area in and around KIT campus, this is from Patia Square actually, after the Phony kind of thing. So like when we are not having power, including inside the KIT, I think we resorted to these handmade things. And what I just like highlighting here, as we know that globally we have lost over 10 lakh souls and 1 lakh from India. I am pretty sure most of you may be knowing 1 or 2 names out of those 1 lakh, those who lost their life to COVID. I can name at least 10 known persons in my contact list who really passed away due to this COVID. And pray God, we have survived and we have joined Professor Siddharth's conclave today. And if we have survived and we are thriving, we must understand that this is not the end of the day, end of the tunnel, or end of the world. And we have to think what we should do in future. This was like the picture I wanted to say. And what I would borrow from BCG report, that the containment policies which were aimed at controlling it, it has actually changed how we work and what we consume. And history shows that such changes always, though temporary, the crisis can fundamentally reshape our beliefs and behaviors. I will give you an example borrowing from BCG report. Say, for example, 9/11 disaster. We had new policies promulgated. And after 9/11 disaster, as we can recall, strict aviation security policies implemented. And if you again remember Second World War, and we can take some examples like this, and lot of women, able women joined workforce, and we started thinking new ways of working altogether, and it has changed our belief altogether. Okay, and women worked in almost every field after Second World War, and even the other virus like SRIs, and we resorted to e-commerce in a very big way. And I'll be showing another report from GG report. It is visible to my student friends, as you can see very clearly, what happened during the pandemic 4 months. And many things, this is actually a report based on US. As you know that US citizens are luxury-friendly citizens, and what happening there, the travel and away from home entertainment, it's down, the business is down. And what we are now thinking of the business is only the essentials like groceries, pharmacies, and online purchase like the whole food. And this was like the pandemic has happened. And very interesting report. All should please look at what International Monetary Fund report is going to tell. What we really know. This is something like the report titled "The Promise of FinTech." As you all know, the technology for financial applications, and what we are getting it. Now we'll be addressing the young data scientist, student friend, those who are listening to me. And those who are attending conclaves like this, whatever we are going to find through our research, through our publications, now what is the implication? How far it can reach? Is it going to the masses? My technology, whether it will be inclusive of all? Now, there is a very interesting concept in my management discipline is called financial inclusion. How many people are included in this service? Suppose, for example, mobile computing. How many Indians, poor Indians, illiterate Indians can use smartphones? And maybe like some of you, those who are very keen reading newspapers, when the pandemic started, Odisha government took many proactive steps of giving like rations and some money to all BPL families. And you may not believe, and they were not included in this fintech. They could not be given money online. And if you can believe me, primary school teachers were asked to move with cash and to reach their families. So such is the step that it is something like a learning for us that we need to include many people, those stakeholders who really need benefit. And when you're talking of like direct benefit transfer, it is not reaching to the real poor people because they are not included. That is called financial inclusion policy. Now we have learned that here. Now please see, here is a study of over a dozen of countries. Please have a look carefully here. The green dots, black dots, and purple dots. As you can please read what is given at the note at the end. Green dots indicate examples of the country with higher female having access or inclusion. As you can see, purple dots are in high number and it is for the male. That means, say for example, there is an ATM. How many women beneficiary in India are having access or use of ATMs? How many poor ladies of rural India can really encash, withdraw money from the ATMs? So this is what we have to really think of. How do we really reach to those persons, those who are not included? That is a real challenge, which we call it financial inclusion. So here is a huge challenge for the data scientists, how to make it not only simple, but also very user-friendly, so that it can be used even by most illiterate rural old women. So this is a message from my side, putting IMF report that how to include the destitutes, the poorest of the poor women in India. And as you can see, most of the financial transaction is done by male and not by female, except few countries where there is something like gender equality. So this is something, a lesson we almost learn. And here is something like a diagram. I will not be taking much time here. Now, the fintech solutions or apps can be further improved. What I will be repeating here, it should be most user-friendly so that even the illiterate people can use. It could be for domestic payment. It could be for remittances to the families. It could be for small savings. It could be for insurances. Say, for example, we have got hotel insurance Yojana. But how many women are included in that? So all these things, we have got a huge challenge. I would request my professor colleagues and also young data science student friends to look into the huge potential what we can do, deliver in this particular area. Now I'll be just taking a few pictures. As I told you that these are pictures I took only last week for this conclave. And this is something like a North Bhubaneswar, those who have seen some shops here which got closed during the COVID kind of thing. This picture I have taken from Chandrasekharpur area of Bhubaneswar, North Bhubaneswar, with the permission of that person, like who was having a tandoori shop here, and it got closed for 5-6 months. You can imagine the couple of persons, those who are engaged here, what they will be doing. And they fought back and they started a shop like this, and it was sent to this particular shop. Now, what we are discussing here is there could be huge business uncertainties during these calamities, and we have to fight it like this, and we have to be innovative, and we have to find our own bread and butter. And this is something like this was closed and this was open, and this is near Tanishq, in front of Tanishq, Chandrasekhar, one can see. And it's not only the small enterprises, it can also go to the biggies like Reliance kind of thing. Now, when you are like fighting for survival, you need to like operate kind of thing. As you can see, the new additions in the shops like this. Okay, so this is something like a new additional requirement or a necessity for each shop nowadays. So this is something like we need to find for the solution what we have. Here, just to say what could be the acute business uncertainty is about the print media. Those who were avid reader of newspapers every day, every morning, they might have themselves stopped getting the printed newspaper because of the fear of COVID. And you can imagine what is the colossal loss of the huge newspaper industry. I think around 15,000 different newspapers printing crores of newsprints every day is stopped. And even today also, though it is economy is opened up and the circulation is almost 50%, it has nosedived. If the circulation is nosedived, and you can imagine that the advertisement will also be hit. If the advertisement will be hit and the revenue will be hit, and they have to think what could be done, and they will be trying to earn revenue from the e-newspaper only. So we have to find for the solution. Now here, I'll be taking example from our own industry, that is education industry. Sorry for using my picture, like these are the happier days, which like we had one-to-one close classes here. We know the warmth that we had when you were interacting one-to-one inside the class. But when there is a compulsion, there is no way out, but you should not lose heart. Maybe like this is the new normal and this is the new class. Again, one of my class in MBA this semester, I can say, and you can see the faces here. So initially, though, there was like some like resistance or apprehension. As you can see, the beaming faces of my MBA student of MBA first year, semester 1, I think it is like it being accepted as a new normal. And post-COVID, though this may disappear gradually, but I think we have to learn, be careful here. And maybe there will be some precaution so that we can learn from this crisis here. This is something like I just wanted few examples to tell, and some of the caution kind of thing that could be like in this digital platform-based business, there could be some deceiving examples. I found this example only yesterday in my Facebook. I thought of sharing here. I don't know whether this particular picture is already seen by some of my student friends, those who are listening to me. This is what one travel agency advertised. And when the customer joined, actually the ship was like this. And you can see where it was. From the background, you can only guess. And this is what he posted in the Facebook. And this could be some of the gray areas. We need to see like how the customer could be protected, and we need to think also for consumer awareness and safety, like this particular example. Now I'll be concluding this through this particular slide, and what we have discussed, referring 3 interesting reports and my own survey on digital consumption. And I have given how though our state took the lead of doing some innovative things in crisis management, particularly crisis like COVID, crisis like cyclone. Odisha case was praised world over. But as I suggested, even over 20% of the beneficiaries could not be given money online. So this is the digital divide. When we're talking of digital consumption, we need to think of the digital divide, like educational divide, like economic divide, have and have nots. And digital divide is the new challenge for the data scientist. Those who have access to digital computing those who do not have access to smartphone or digital computing. That is the divide we call digital divide. Still, there is a huge gap. And though government wanted to give instantly online money transfer, they could not do it during last 3-4 months. And taking these examples, what we have suggested, we can sum up that there is a huge need of deploying and developing adequate IT infrastructure. This can support the development and use of various digital platforms in public sector to accelerate the service delivery, what we just suggested now as an example. And for this should also be supplemented by nationally thinking of developing some content. Say, for example, here I can give you on individual basis, on private effort like Baiju. We have got some digital contents or some private parties they develop, but we do not have sufficient at national level from government side digital content. What could be, say, for example, syllabus, academic course content for all degree level engineering courses. We don't have, and the teachers struggle. We don't have any common acceptable content. So we need to have particularly e-education, e-health are the two of the challenging area where we need to develop at the national level some digital content and services. Next, not only the development of IT infrastructure or digital content, and the users should be trained, skilling up and reskilling the semi-trained workforce. We need to do that, and particularly the government sector. As you can guess, say for example, I can thank my KIT student, those who are listening to me. KIT took a lead in conducting online exam as a leader in the country. As you might have, Supreme Court ruled that there cannot be degree without exam, and many government universities are struggling because they are not having trained teachers to conduct the online exam. Even today, I should not name universities even from Odisha, and there's something like a very bad example how they're conducting online. It's not online, but they're calling it online exam, and you must have heard how they are doing it. So now, government sector, even also the government doctor, government hospitals, they are not suitably trained to use this e-health or e-education, and particularly from government sector, there is a huge need of skilling up or reskilling the workforce. And coming to my area of management and economy, as you may please excuse me, whether life or livelihood, there is a huge debate. Should we continue the lockdown, continue the shutdown, or we should open up? Unless we open up, the economy will dry. We cannot really feed our people. So we have to open up despite this huge pandemic crisis. So now we have to have economic strategies, and in particular the local context, and use of data science, particularly what Mr. Ajita was suggesting. We need to also think of realigning digital economic strategies. I think this I may skip, but two more points I would suggest, that there is a huge scope for real-time customer service so that the human contact is minimized, like say delivery through drone and many things can be happening kind of thing. Say lot of business process re-engineering is required so that the human contact or the intermediaries are avoided, and we need to look into that. And it's a huge scope and challenge for the data scientists. And this will be last my suggestion, and particularly the education sector, and particularly young university like ours. And we need to have a lot of e-resources for the varying needs of different students of different schools. And it could be engineering, it could be management, it could be degree college, and we don't have much e-resources. As some of you must be having young kids in your family, those who are doing online classes, particularly in the primary school, and you must be filling the vacuum that we don't have e-content for school education. Luckily for higher education, for engineering and post-graduation, we have something e-resources and we can manage. You can imagine the unimaginable pain of the school-going kids, those who are into online education, particularly in the government sector. So this is all from my side, and if any question, I would try to address.
Thank you, Professor. Thanks much for a much engaging and a deep-rooted presentation, sir. Your presentation was, I myself do not know personally, but I must say that you must be a very dynamic person by seeing your slide and presenting the real problem. Like, it was really an eye-opener in the field of digital data consumption and the pattern of the consumption. As you have mentioned, sir, that digital inclusion is a key area if we really would like to draw a progress roadmap for our country. So basically, it would be for the education, or it could be for the digital financial inheritance that you have mentioned. How can we reach out to the lowest economic strata? It was really, something that we need to be awake of. And how can we reach out to the rural areas to give them this benefit? Thank you so much, sir. Now,
thank you so much.
A couple of questions actually came from the students. So, sir, please, for you. So, as you have mentioned, the digital consumption and the change in pattern, what do you think the most important change in this world, in this digital world, has come into effect post-lockdown? And digital transaction security, how has it changed and helped people? So just for example, maybe that one of your initial slides, you have mentioned that between Jan to March 2020, it was the communication, which is 95% of the data that you have found out as a result. So have you found that from the March, or so any updates, or do you have that the change of pattern in the category of the data post-lockdown?
Okay, I can cite example from my own house, own family. And as Krishna ma'am has rightly suggested that it is mostly communication and entertainment, which actually we resorted when we were confined to the four walls, particularly managing the young kids in the family. And I got my son and daughter-in-law at Bangalore. Those who wanted to come, but we are advising each other not to come, and maybe like every alternate day we video chat. So this is how we keep connected. So like earlier, it was not the need or the necessity. Maybe I feel that should be like a common with all families across the globe. And maybe like we keep on inquiring how things are around. So for example, Bangalore, it is really alarming, and now at Bhubaneswar, it is also very as a hotspot. They are all concerned. So naturally, when we are in touch, so the communication, IT-based communication is of great help. And my family also has a rural route. My own mother, old mother, stays in a rural village where though there is mobile connectivity, my old mother cannot use smartphone. Say, for example, I wanted her to have sufficient cash. She cannot go to ATM. She cannot use because all her ATMs are with me. She's a pensioner, but she cannot go to the bank kind of thing. So here is a huge challenge. What I do, I operate her ATM, but I don't wish I should operate always. So like we need to like, here is something like a difficult area. I think my mother represents the rural area. And maybe like she's lucky that she's having bank account, she's partially into financially included lady, but there are many more ladies, particularly destitutes, those who need money. Government like say Madhu Babu Pension Yojana. I don't know whether the young friends know this kind of thing, We have got state government schemes, lot of schemes, and you don't know how the old women line up in the panchayat office and why they should line up when we have got technology. So this is what like something we need to do very seriously. So this is what like it has to go to the beneficiary. And the young brains, I must request my data scientists, young brains, please look into the beyond city or cosmopolitan town. Please think of the stakeholders who are living in the rural India. It's a huge India. It's a huge database. And we need to think of them. And they are not in this digital platform. This is what my short comment would be, Krishna.
Yeah, thank you, sir. It's really important for us to think, because definitely, if we think, then only that can reach to themselves, like the advanced technologies, if we can use. Thank you so much, sir. So just that we are on time, so that we can finish this session. Thank you very much, sir. We loved your presentation and all the pictures, because I live very nearby and our institution is also near the location that all the pictures are taken. So most of the locations that are known to us. We really enjoyed.
Thank you. Thank you.
Yeah.
Thank you so much, Samaresh sir, Siddharth sir, Manjusha ma'am. Thank you for giving chance.
Thank you so much.
Thank you so much. Thank you.
Okay. So we really hope to meet you someday in person, sir. So I'm moving to the next session. I am welcoming Professor Mamta Motwani to take us for the further session for the panel. So, Madam.
Yeah, Krishna ma'am, thank you so much.
Thank you so much.
So good afternoon, everyone. Myself, Mamta Motwani, Assistant Professor, School of Computer Engineering. As faculty host for this session, I welcome you all to the Digital Data Science Conclave organized by Data Science Group, School of Computer Engineering, KIT deemed to be university. This conclave has 13 eminent speakers from the industry, academia, and research groups. So I would like to check if I'm audible to you all clearly.
Yes, ma'am.
Okay, thank you so much for that, sir. Now, I feel very exhilarated and honored to welcome Mr. Biswajit Nayak, sir, to this conclave. He's a seasoned business leader with more than 20 years of experience. Currently, he's working as Director of Grid Analytics India Private Limited, which is purely an analytic product marketing company. He has a rich exposure to the international work environment, culture, and diverse management styles. Some of his specializations are advanced analytics, data mining, and predictive analytics. Today, he'll be sharing with us his expert opinion on the topic COVID-19, a data science and AMP, visual analysis and review. Now, before I invite Mr. Biswajit Nayak to proceed with his talks, I would remind all the attendees to fill in the Google form provided in the Zoom chat in case you have any questions regarding the talk. Now, please may I welcome Biswajit Nayak, sir.
Hello, can you hear me all?
Yes, sir.
Okay, thank you. Thank you for your response. Can you view my screen?
Yes, sir.
Thank you. Thank you very much. Before getting started, let me introduce myself. Myself, Biswajit Nayak. My designation is I'm the Director of Advanced Analytics and Data Science for a company called Grid Analytics India Private Limited. However, my role with the Grid Analytics India Private Limited, I play a role of a translator. What does it mean? I'm privileged to meet people from the diverse background, like from the commercial world, from the academician, researchers, so on and so forth.
I receive their problem statement. I have a group of data scientists and statisticians to support me, and we convert those business or the research problem into a data science or data analytics problem. I would like to express my gratitude to Data Science Group, School of Computer Engineering, Kalinga Institute of Industrial Technology, deemed to be University, Institute of Eminence, Bhubaneswar, Odisha, for having me on this occasion of Digital Data Science Conclave 2020. What I have defined the agenda for my sessions, I will have an overview of the data science, how the data science can play a key differentiator for this pandemic also, your COVID-19. Then we'll see a real methodology or the workflow, how we can apply science to data and how we can complete and win with the predictive model management life cycle. Then convention, followed by the questions. Yeah, what you can view in your screen, this is the world we are living in. This is what's happening in every minute of the every day in context to the data, right? 2 million searches are happening every minute of every day, 72 hours of the video being uploaded, so and so forth. And this is what's happening in every seconds in the internet, right? You can see 4,86,111 WhatsApp message being communicated, 20,88,887 mail being exchanged, so and so forth. What is the purpose of these displaying of these two slides? We all agree in one thing: we are living in a very, very data intensive world. This is what we have to deal with, right? And even it becomes more importantly or the increasingly important for the data analyst or the data science enthusiast, which brings an enormous opportunity for all of us in this data intensive world. In order to seize the opportunity, in order to take the maximum of this opportunity, we need to build or we need to develop the skill set to dealing with the volume of the data what we experienced in the last two slides. We need to deal with velocity or the speed of the data, again what we experienced in the last two slides. We need to deal with the variety of the data or the diversity of the data. We experienced from the eminent speaker, like you need to deal with the structured data, you need to deal with the unstructured data, you need to deal with the semi-structured data, you need to deal with your images, so and so forth. So I should have the skill set in order to deal with this diversity of the data. Then we have the veracity or the continuity of the data. As a data science, whenever we are building an architecture in order to support this predictive model management life cycle, we need to ensure there should be a continuous workflow from data to this predictive model production. So there not be any kind of the interruption in between, right? So we need to ensure the architecture should support the veracity of the data. So these are the need to have. This is not nice or this is not luxury. If I wanted to become a good data scientist or a rock star data scientist, I need to have these minimum skill set to deal with these 4 B's of data in order to get a victory on data science. We have been hearing that data science, if not around the 5 years down the line, it has been a darling for everyone, right? It has been darling for the researcher. It has been darling for the commercial world, right? Why it has become so, it is in the center stage. What are the reason of the data science has taken the center stage? Data science is the conversion of statistics. Data science is a convergence of pattern recognition. Data science is a convergence of neurocomputing. Data science also a convergence of the visualization, storytelling. I could hear the story from Honorable Vice Chancellor to like, in order to become a good data scientist, you need to build a very strong story to present your project or your research paper, irrespective of the field. You could be a researcher. So data science also include visualization. Data science includes machine learning. Data science includes artificial intelligence. Data science includes data mining. Since I have been around 20 years in this field, I know data science is nothing but what I experience personally. It's a rebranding of data mining, right? So basically, smarter people in the planet, they create the wealth for us. They create the opportunity for us. So they have rebranded this data mining into a more broader opportunity base called data science. And so these are the skill set for the data science enthusiast. You need to have, right? It's slightly more, but what I say to add a funny element, आधा से भी ये ज्यादा है, लेकिन आधा से भी काम नहीं चलेगा. In order to become a rock star data scientist, you need to have the skill set that is demanded in the market. But whatsoever we do, whatsoever activities we do in the space of data science or in the space of the machine learning, in the space of statistical data analysis, in the space of business analytics, so and so forth, broadly we carry out the 4 type of analytics. Because data science is a part of this broadly data analytics. So what the activities we carry out? The activities we carry out, the descriptive analytics, right? Descriptive analytics means we describe the characteristics and the nature of the data we are dealing with. We apply the various statistical indices, maybe the mean, median, mode, or largely like you can say like the measure of location, measure of dispersion, measure of shape, graphs, so and so forth, measure of thickness. So this is what we do in the descriptive statistics in order to get a sense of the description of the data or the characteristics of the data. Then moving up, we have something called diagnostic analytics, right? Diagnostic analytics, like today, like we are dealing with this, one of the most difficult time of the century is the pandemic, the COVID-19, right? And suppose I take the history of this time, the 6 months, every day there is a change of the goalpost in terms of what are the causes, what are the variable which plays an important role for a patient will be positive or the negative, right? So somebody like say that it's maybe like you have a high fever, or you may have a dry cough, or you may have a tiredness. So we need to understand the root cause or the key parameter which is influencing our COVID-19 status, called the diagnostic analytics. Then moving up, we have something called predictive analytics. Once we gather the data, we need to build a model. We hear some of the modeling technique like logistic regression, neural network. We heard something about the deep learning, so and so forth. The basic purpose of all these the algorithm to build a predictive analytics or the predictive model in order to predict whether, on basis of the input parameter I do have in hand, whether the patient will be the positive or the negative, what we have been doing. Then moving up, right? So again, we experienced during the 6 months, there is the course of treatment has been evolving. It has been changing, right? So even in absence of a prescribed medicine, we are not sure which of the medicine is going to work out. So as a doctor or as a medical practitioner, we need to prescribe something in order to change the status from negative to positive, right? So that is known as the prescriptive analytics. I will see, I have a small model for you. If I could show you, if the time permits, how really this the framework works. And another thing which has come up now, called cognitive analytics, but this is in a very nascent stage in India, right? So I'm not getting into that, but hopefully like that will be coming. Another type of analytics called the 5 type of the analytics. But again, like whenever you undertake any of the projects, what do you see in the left hand side? This is what we have been doing analysis in the past, right? We have been doing the analysis in the past, data acquisition, data preparation, application of analytical algorithm, report generation and dissemination. But there is a new framework. Once the data mining came, there is a new framework has come called CRISP framework, which stands for the Cross Industry Standard Process for Data Mining, right? So suppose you follow this framework, your chances of completing and winning with your projects in your hand much more higher compared to going the directionless. And it's one of the standard projects for the data mining. So what the workflow describe? The workflow describe you the business understanding, that is for me, like from the commercial world, or those who are the researcher or the academic world, it could be your research goal or defining your research problem. Then we have something called your data understanding. Data understanding means, data understanding means what type of their data, what is the characteristic of the data I have to gather in order to support my projects, right? Then comes to the data preparation. Again, the data preparation, for some time I was part of this session, so I could hear what is the importance of the data preparation. You go to any of the source, either you are a data scientist, either you are a data analyst, either you are a business analyst, it does not make any difference. All the consumer of this analytics, they spend in between the consumer of analytics, they spend in between 80 to 90% of their time. They spend 80 to 90% of their time for your this 80 to 90% of their time in the data preparation. Fine.
So sorry to interrupt you, but your screen share has
Yeah,
stopped.
I am also struggling a little bit on this. I do not know whether there is a change, means there is the control with the host, or I do not know. I have
No,
been also,
so you just try once again, it will be fine.
but I will try.
So try to share your screen once again, it will be fine, sir.
Okay, is it good now? You can.
Yes,
Yes,
sir.
sir. Yes, sir.
Again. Yeah, but the picture is overlapping with my screen. If the controller can do a little change, that will be great. I cannot view my right hand of my screen. It is superimposing.
So if you try to move that, it will move. That particular part, if you try to move,
Okay, let me
is it
see
work?
what extent I can manage. Right. So again, the data preparation, or if you have a control, suppose you can see the view of the screen, you can take all the pictures into the top. That will be a great setting. If we can make the changes,
So
you can
that is
take.
already done. Maybe at your end, you will have to do that change. So it's already done this side.
Okay.
So if you drag that particular part and bring it to the upper side, then it will work. So try that
Okay,
one.
fine. Thank you. I could, right. Thank you. Thank you very much. Yeah.
Thank
So
you,
where
sir.
we were, like, either I do a data science project, either I do a business analytics project, either I do a statistical, all the consumer of the analytics, they consume in between 80 to 90% of their time for the data preparation. And we deal with the numerous challenge like outliers, right? Data redundancy, right? Which are the important variables, so and so forth, missing values, so and so forth. So we spend in between 80 to 90% of our time in the data preparation. Then moving forward, we have something called modeling. Modeling means this is the algorithm or this is the modeling technique we apply. We could hear something like logistic regression, neural network, multiple regression, machine learning, support vector machines, so and so forth. Then we come to the evaluation. Once we apply the modeling algorithm, we have to evaluate the model. Some of the evaluation technique I could see in the chat box, the app score, right? We have the confusion matrix. Suppose I do have a classification problem in hand. I do have confusion matrix. I do have gain and leap chart. I do have ROC curve, so and so forth, right? Once I completed this 5 step, then I do have something called deployment. Deployment means once I receive the new data set, I can deploy this model in order to have a prediction for the new data set, or I need to have a scoring. So this is what the CRIPS is all about. So let's get started, right? Let's get started how we can complete. We have been hearing since a long time. We have not seen anything practically. Now we see something practically, how really it works out. Fine. Let me get into a data set. Yeah, so for this purpose of the practical, I am using a tool called Statistica, right? Many of you may have heard, many of you may not have heard, but you can go back and check. The Statistica is a data science tool, and which happens to be one of the leader in the data science. And we have been in the leadership position, or we have been in the legacy of leadership year after year. And this is the 3rd year in a row, right? We have been leader. Just I can give you, like, suppose I place MATLAB in the data science, right? So MATLAB becomes a challenger and Statistica becomes a leader. So you can understand. So whatsoever you have been talking since morning, every algorithm you get here, starting from your conventional statistic like logistic regression or multiple regression to the advanced algorithm like neural network, machine learning, so on and so forth. So where I was, now we are going to deal a problem for this COVID-19, the pandemic. I have some of the data, but you can construct your project. I will tell you. You can view the data, right?
So for us, the presentation is visible.
Presentation is visible.
Yes, sir. So maybe you have just shared the presentation and not the entire screen. So when you are switching, that particular tab is not visible.
Okay, okay. Could you see now? Could you see my the screen now?
So not yet, sir.
Sir, you kindly share again. Once again, you share the screen.
Yeah, that I'm trying. Can you see the screen now?
Yes, sir.
Yes, sir.
Okay. Okay. So here, what you see on your screen, this is a data set, right? And what the data set describe about, the data set consists of 463 observation. If because here I'm getting a disruption in my top of the screen, but if you can view, there is a 463 observation, or the rows are here, and we have 17 number of columns, or what we say the variables, or you can say the input parameters, or you can say the descriptors, right? And out of this 17 number of the columns, one column we have the coronary heart disease. You can construct a situation in the coronary heart disease. You can place the COVID-19 status, right? And the COVID-19 status, you can place it present or absent, or maybe the positive or the negative, labeled with the positive or the negative, right? And what we have, these input parameters, the 16 input parameter: blood pressure level new, systolic blood pressure, tobacco intake. There you can place it, building a case for the COVID. You can put like the fever in the blood pressure level, you can put fever, you can put dry cough, you can put tiredness in the column, and you can label it, or you can put a number. Suppose I have the fever, you can put 97, 98, 102, or you can label with like this: high, medium, low, so on and so forth, right? So I do have a 16 parameters, the COVID parameters, and I have the outcome variables or the target variable called COVID-19 status, and I have labeled the response variable with the positive and the negative. Fine. Now, out of the 16, just in a quick second, I need to identify which one plays an important role for these here coronary heart disease or this COVID-19, right? I wanted to identify through the diagnostic analytics. So in the data mining, the statistic offers features. It's a very popular features, nothing new, but this is a popular features known as the feature selections or it is known as the predictor screening, right? Feature selection is a very, what do you say, the common terminology in the data mining or the data science community. So what is the purpose of the feature selection? The purpose of the feature selection is the diagnostic analytics. It's one of the approach of diagnostic analytics. I wanted to identify out of the 16 parameters, which parameters contributes most to my status of the heart disease. I went there, choose the PZ selections.
Anushka?
Hello.
Yes, ma'am.
Yeah. No, I thought nothing was audible, so I was just cross-checking. Okay.
Okay, let me set it. Maybe some uh, uh, may I request, can you just give me 2 minutes? Just I wanted to log out and log in again.
Sure, sir.
Just give me 2 minutes.
Yeah, sure, sir.
Thank you for your patience and understanding.
So your audio is not connected.
Viswajit sir?
So your audio is not connected.
Maybe the headphone he's using is not connected.
Also, you can try the on the left side corner, the mute option. On top, there is a small arrow. You can just try that and click whatever microphone you are using. Just press that and check once. So you go to mute and then there is an arrow on top. You press that. Huh.
Yeah, now it's connecting.
Unmute, unmute.
Unmute, sir?
Hello, can you hear me?
Yes, yes, sir.
Okay, thank you very much. Thank you for your patience and understanding. Can you view my screen now?
So not
No,
yet.
sir.
Maybe it is.
You have to again share. You have to again share.
Sir, have you shared it again?
Here I'm getting a this thing host disable participant screen sharing. I'm getting a message on my screen host.
Yeah, I will request technical team to look into this.
Host.
I can see.
You can.
Siddharth sir.
Now please check. Please check, Viswajit. Please check.
Sir, please check now.
Okay. Now, can you view my screen? I have already shared the screen.
So you'll have to try now. It will be visible now.
Okay. Can you see my screen now?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Thank you. Thank you very much. So where we were, we had a challenge in hand. Out of the 16, we wanted to identify which parameter contributes most to the status of the heart disease in this case, but it could be a COVID-19 or anything depending on your problem definition. So I went to here. I have something called feature selections. I go to the feature selection. As usual, Statistica, the first one is a no-code software. It's a drag and drop approach, but for the coder or for the programmer, they can write the programming also using Statistica Visual Basic or maybe C#, or they can write the program in R, Python, Spark, Scala, any of your language of your choice, depending on your skill set. So here, I have a problem in hand. I have to identify, or I wanted to perform the diagnostic analytics. So I choose the variables, right? Coronary heart disease was my target. It could be COVID-19 or the rest of your independent or the input variable. I go ahead with this selection, right? So, okay. Here I wanted to display all. So I had 16 input variable. So I will have a quick visualization, right? So I got output. I do a little configuration for the same. I go to the scale values. I put off, or I say, okay, here it is. What I can see out of the 16, the input I had for the status of heart disease, I see the age or the age disease, the age was contributing most to the status of the heart disease. They're followed by the tobacco intake, the tobacco consumption, right? So and so forth. Now, the reviewer asks me, what is the evidence you have? On what basis you claim your age was contributing most to your status of the heart disease? let's expand a little more output here on the basis of the chi-square and on the basis of the p-value, right? I am claiming that this age was contributing most to the status of the heart disease, followed by the tobacco intake level. Fine. So this is the way we apply the diagnostic analytics. We have a multiple way for that. This is not only the exhaustive one, or this is not the only one, but this is one of the most quickest for the diagnostic analytics. We have something like, you must have heard something like principal component analysis, reduce the dimension of the data. You must have heard like the industrial, they apply something called your Pareto chart, root cause analysis. They apply the fishbone chart. So there are multiple techniques are there, but the purpose, I wanted to see which of the variables plays an important role. So now we are done with our diagnostic analytics. Now I wanted to get on into my predictive analytics. So what my data scientists did, they build an interface. They build an interface or the UI like this. I am not a doctor, neither by education, unlike you, many of you are doctors, but I am not a doctor, neither I am by profession. I am not a qualified MBBS also, but through the power of the data science, I will become a doctor, and I promise you, I will make all of you as a doctor, so you can predict. Someone comes, a new patient now is coming to me. A new patient is coming to me, right? With the data set like this, tobacco intake 12 kg, new patient means we had a historical data for the 463 number of patients. I am receiving a new patient. The number of the patient is 464. I do have the input only, or the health parameters. I do not have the output, whether the patient will have the heart disease, the status will be present or absent. I wanted to predict. I am not a doctor. I am a data scientist. I have built a model. I have created a user interface. Let me check it out. So I got this check status. You can see on your screen, right hand side, you can see on your screen, so showing something called heart disease present. Can you please someone respond from the audience or the host? You can see on the screen, right hand side, the heart disease present, red, which has been highlighted in the red.
No, sir. Sorry to, we can't see that, sir.
What you can see on the screen?
Sir, it is blank actually, sir, with some only the menu which is appearing on the top of the workbook.
No, you see the coronary heart disease? Is screen a form kind of thing?
Yes, so the form, the workbook, Statistica workbook is visible, and it is on tab data mining, and nothing else is visible.
So the workbook label says Statistica workbook 1.
No. What I have done, I had could you please respond someone? Can you see my screen now?
Yes, sir. So to be sure, are you using Visual Studios right now?
Yeah, I am using Visual Studio right now.
Yes, sir, that's visible, sir.
Visible, right?
Yes, sir.
just prompt me. You can see my screen, right? The Visual Studio's the screen.
Yes, sir.
Yes, sir, it is visible.
Yeah, you can see this my screen now.
Yes, sir, we can see the screen.
Okay, wonderful. Okay, fine. So you can see the screen in the tobacco intake level 12, stress type behavior at 49, so and so forth.
No, sir, I can see just some windows.
Blank screen, blank.
Blank screen here, sir, with 3-4 windows which are arranged, like Team Explorer, Error List, and Autos. And the main screen is main window is blank, sir.
Not an issue, sir. Not an issue.
No. It's a very important. So what I was trying to do. What I was trying to do basically, we had built an interface called prediction of the heart disease, right? So once you receive the 464, now can you see?
No, sir. Not an issue, sir.
Yeah, fine. So the 464 patient I am receiving. So just in the form, I have configured something called sample data. So I just click the sample data. The form will be filled according to the parameter, tobacco intake, stress type behavior, so and so forth. Right now, I will check the status. In that parameter, the 464, it is showing the heart disease is present. Right, so that is the third level. So I need not to be a doctor, but I can tell, and in the below of that form I get something in the result output, the probability of the absent, the probability, what we say, the confidence probability of the negative result is the 0.22, right, and the probability of the positive is the 0.78. And we had applied an algorithm called classification regression trees. Since we had a classification problem in hand, we had applied the classification regression trees. What is the basis of our using the classification regression trees? We apply all the possible model, starting from your logistic regression to the neural network, to the random forest, to your support vector machine. We have a very unique approach in Statistica called data miner recipe. So in one go, you can apply all the possible classification algorithm. We applied all the possible classification algorithm, and on the basis of the evaluation, like your confusion metric, ROC curve, gain and leap chart, we found that the classification and regression trees is giving me more better accuracy compared to the other model, right? Then
Excuse me, sir.
Yeah.
Sorry to interrupt, but I'm afraid to say we have strict time constraints.
Yeah. So how much time? No, I understand. No problem. Right. So we are done with the predictive analytics. Then moving up, we go to prescriptive analytics. So this form allows me to simulate. As we did in the diagnostic analytics, the tobacco intake was contributing most. So here in my screen, the tobacco intake parameter is showing 12. So the patient, who is a new one, 464, is consuming 12 cigarettes per day. Let's assume, right? For the COVID-19, you assume a situation, let's say his fever is very high. So I will play around. I will simulate to change the status. Suppose here, I will change the tobacco intake to the 0. My status will change from positive, heart disease present, to the absent. So I can recommend to the patient, you need to quit the tobacco, so and so forth. for COVID-19 also, suppose we have a predictive model in hand, the data science model, we can very well predict, we can very well prescribe the patient what they should do, right? So this is the part of my part of the presentation, and if you have any queries, you please place me. So I will try to answer if possible online, but I don't think then we can take it offline. I'm trying to, yeah.
Sure, sir. Thank you so much, sir, for this enriching and informative talk. And I'm sure everyone must have gained a new perspective and also realized the crucial role data analytics can play in this time of crisis like this COVID pandemic. And I'm sure more students will be inclined to take up this area for research and their career, and more with your assurance that we can develop doctor-like skills with this, as you said in your talk, sir. We'll be more inclined. Thank you so much, sir. And sir, due to time, we have some queries. We'll be forwarding it to you, sir. But for the time constraint, I would like to go with the next speaker, sir. Thank you so much, sir, again.
Thank you very much for the DSG team, and I pray and hope for each of you have stay blessed and stay safe. Thank you very much. Signing off for now.
Thank you, sir. It was so nice to have you with us. Now, it gives me and my university immense pride and pleasure to introduce our next speaker. She is a KIT alumni who has studied in IT branch of School of Computer Engineering. She completed her master's from Indiana University, Bloomington, and is now working as a data scientist at Cummins Incorporation. She is currently working in the field of data analytics, visualization, and Oracle DBA. With this, I would like to welcome Ms. Bhavna Sinha to the Digital Data Science Conclave organized by Data Science Group of School of Computer Engineering, KIT deemed to be University. And I request her to share her very valuable insights on her topic, role of data science in an automotive industry.
Thank you so much, ma'am. And hi, good afternoon, everyone. It's good to come back as an alma mater and connect with you all. So I know you all must be waiting for the break. It's been a long session, but it's 4:40 a.m. here. If I can do it, you can do it. Okay, half an hour and here we go. Okay, I'll keep it short. So let me know if you're able to see my screen. Okay.
Yes, it's getting loaded.
Are you able to see my screen?
Yes, Anna, we can see.
Okay. So today I'll be talking about data science in automotive industry, and my talk would be focused on, to the students there who are looking for opportunities or who want to join the automotive industry. Agenda for today is I'll talk a little bit about myself, data science in automotive industry, what are the skills required, and if you have any question and answer. So yeah, this is my career path. I did my bachelor's in IT from KIT University. You can see the 2016 batch over here. Let me just pointer option. Okay. 2016 batch here. Then I went on and worked with Ericsson for around 2 years as an Oracle DBA. I wanted to switch my career into data science. So I pursued my master's in data science from IU. And after that, I joined as an intern with Cummins and got a full-time from them. And currently, I'm working in the advanced analytics team with Cummins as a data scientist. So let's talk about why do we need data science in the automotive industry in the first place? I mean, why is it important? Why do we need it? As you all know that data science helps large organization drive actionable insights from all kinds of data and to make a difference. And the automotive industry, automotive sector is nothing if it is not competitive. Machine learning and data science are the new frontier that are enabling organization to discover and harness hidden values in their operation and to create new opportunities for the growth. The industry, the automotive industry, continue to face a dynamic set of challenges. And if the company want to stand out from the crowd and differentiate themselves from their competitor, they need the help of data science and data scientists to help them take right decision. The automobile is being transformed by technologies such as artificial intelligence, big data analysis. We have like every 5 seconds of data coming in, and data science allow all these data to be merged in a machine readable format. And if done right, the results are impressive. Data science can help to deliver a better product, help in retaining the customer. We can increase the sales. In the next slide, I'm going to outline some of the major opportunities in the automotive industry to benefit from data science to help drive greater profitability, market share, and risk avoidance. When I joined Cummins, I was with the background with IT. I knew nothing about mechanical engineering, and I was wondering, okay, what am I doing here, and what I'm gonna do with the machines. But let's talk about the various areas we have in the automotive industry. First is the supply chain. Throughout the supply chain, analytical models are used to identify demand levels from different marketing strategies, sales price, location, and many other data points. We can use predictive analytics that dictates the inventory levels needed at different facilities. If you're a data scientist, we can constantly test different scenarios to ensure that we have ideal inventories and improve brand reputation while minimizing unnecessary holding cost. We can create an optimization model that help to guide the exact flow of inventory from manufacturer to distribution centers and ultimately to customer facing storefronts. Machine learning can helps parts and vehicle manufacturers and the logistic partner to be more efficient and profitable while enhancing customer service and brand reputation. Manufacturing and the product development, these two go hand in hand. Whenever an issue arises at any point in the product life cycle, right? Whether it's something found early in the manufacturing process or an issue affecting multiple vehicles in the field, we need to determine what is the exact cause and see how we can resolve it. The brand reputation and possibly consumer safety are at stake. So if you want your product to be, outshine, sorry, someone is asking something. Okay. If you want the product and if you want the product to outshine and to deliver the best product, you need to make sure that whatever you're supplying to the customer is up to the mark. There can be failure happen at the later stage of life, And that's where the role of data scientists come for the root cause analysis for those failure, so that in future the products we develop, right, are free of those failures. Secondly, I would like to talk about the distribution. We have a team here at Cummins called Demand Analytics. So what does it do? If we need to outperform our competitors, we need to act ahead of them. We can use forecasting to know about the inventories at different locations and see if there can be a demand for any products. Why this is necessary? So that we don't overproduce or have the shortage of the part, because in both the cases, it will hurt the company financially. For example, if we have a demand for 1,000 products and we have produced like 2,000 products, right? Those 1,000 products, the extra 1,000 products are going to be a waste. It won't be utilized. And that will be affecting the company revenue. Similarly, if we have a demand for 1,000 products and we only have like 500 products and you're not able to fulfill that margin, it will look bad on your brand name. So it's necessary that we know exactly how much demand is there in each of the location. So we have to be spot on in planning our distribution of products to various locations. Forecasting tools and predictive analysis are basically actively combating to mitigate those risks for product details, for product recalls, sorry. Lastly, the customer sales. To succeed in any business, whatever it is, we need to understand our customers very well. It applies same to the automotive industry as well. You can do everything right, but everything goes to waste if you're not able to sell your products to the customer. So to succeed, automakers need to fully understand customer needs and behaviors in order to develop a single view of the customer. Thereby, like we can building compelling and differentiated offers throughout the sales cycle. Secondly, customer retention is important. And for that comes the role of understanding and influencing customer experience through the life cycle and journey, and not just the purchasing phase. It's not that once the customer has purchased the products from you, you are done. It's not like that. You need to make sure that the customer is loyal to you. You need to make sure that the customer is with your company throughout the life cycle. And we can use data science here, which can help in customer retention. We can use data science to target new customer and also maintaining the loyalty of the existing customers. We can see like which of the customer are hibernating or which of the customer whose frequency have reduced. We can go to them, hey, is there something we can offer to you, right? So these are the sectors in automotive industry where we can use data science. Marketing. By knowing about our customers, we can help to improve the marketing strategy and recommend better products to the customer. It's similar to the Amazon. When you go to Amazon, right, you buy something, you add something to your cart, and it shows you similar products which you can buy, right? It's same with the automotive industry. I'll talk about one of the projects I'm currently working on. Cummins sell filters. So for the engine, we have filters. We sell filters to our customers. So one of the projects which I'm working is upsell and cross-sell. What does the upsell and cross-sell mean? Upsell is selling expensive product to the customer, upgraded ones, and cross-sell is selling the similar products to the customers. If I know my customer has this type of application, ABC kind of application, and I know that this kind of filters go into that application, right? Then I see what are the other products, similar products that can go into that application, and I can check if the customer is buying that product from us or not, and we can recommend it to them. Where does the upsell come? If we can check if we have any upgraded part for that particular product. If it is there, then recommend to the customer the upgraded version rather than the simple version. This is how the company make revenues, and these are some of the areas where data science come in. Next comes the aftermarket. The automotive aftermarket is the part of the automotive sector which deals with the replacement of vehicle parts when vehicle is no longer used under warranty from the original manufacturer. So not all companies currently involved in the automotive aftermarket sector store their data. And while others may periodically collect data, they are yet to discover the hidden value and financial benefit within the data that big data analytics and statistical analysis can provide. From these type of data set, it is possible to gain insight into buying habit preferences, return rates, and product attributes. We can know about the trend and patterns derived from the invoice transaction, which can be used to inform the industry better. For example, about when specific vehicle parts are bought, and therefore which we can know which part to keep in stock at what time of the year. For example, in winter, we might be requiring some of the parts, right? And in summer, there are like some other parts required. So it's better that we have all those inventory, right, beforehand, so that when customer asks for us in the winter, okay, we require this part, we already have that, instead of having a shortage of that and customer going to other competitors. So these are the different areas of automotive industry where you can use data science. Like when I joined Cummins, I was like, okay, where I'm going to use data science. But trust me, there are a lot of opportunities that are present in automotive industry where you can use the skills, data science skills. Pretty much everyone has talked about this tools which are required for data scientists. Whichever field you go, you must have a business understanding or domain understanding, right? Whatever you are doing, whatever field you are, try to understand what is the business behind it, right? You must have statistics and linear algebra knowledge. It's required. You can have knowledge about R or Python. I prefer Python though. Big data skills and data visualization skills, machine learning and deep learning. So we talk a lot about machine learning, this algorithm, that algorithm, right? Make sure whenever you study any of the algorithm, be it linear regression, logistic, random forest, whatever, they are like plenty. Make sure to understand the basic concept. Why do we need that algorithm? When do we need that algorithm, right? What is the right problem statement to use those algorithms? And I'm talking with respect to the interview questions as well, which you might the interviewer can ask you, right? We have like a lot of algorithm, but when to use it, why we are using it, you should know that. And you can only know when you know the basics and of each and every algorithm. Okay, let me talk about the skills required for data scientists. It is true, like with the help of AI and machine learning and all the big data technology we have, we will not be able to handle these data revelation without the help of AI and machine learning. But still, the most important element in driving insight out of data And what makes data scientists irreplaceable is a human factor. The key to turn data into insight lies in what we can do and machines cannot. Curiosity. We all have access to Google, right? With the billions of data points in Google. But it's your curiosity that determines what you're gonna learn. What would you search? What would you filter? And how do you discover what is relevant to you? Empathy. It's the key to connect with others and to understand what other people needs. As a data scientist, it's important in whichever field you're working, right? You need to understand what exactly is the need. Why are you working in this field? What is the problem statement? Be imaginative, creativity. It's the key to invent and articulate solution to solve problems. Communication. It's the key to persuade, to influence, and to create change. And at the center of them all is the curiosity, because it is the curiosity for emotion that drives empathy. It is the curiosity for ideas that drives imagination, and it is the curiosity for solutions that drives creativity. And it is the curiosity for influencing that drives communication. The most important skill of a data scientist is to ask the right question to data. The curiosity of a data scientist to ask the right question, to iterate, to understand those human issues, to imagine the possibilities, to create and articulate solutions, to convey message and insights with the right visuals, make them actionable. Those are the key elements that basically turn data into something meaningful. You can do all the AI and machine learning, right? But if you're not able to communicate and tell your story, everything is waste. It is a set of skills that no artificial intelligence can match yet. Remember one thing, a fool with a tool is still a fool. Data science is not only about technology. You need to be curious. Data science needs curious brain of an artist to make a difference. That's it for me. Is there any questions I can answer? And I hope you guys have some takeaways from this presentation.
Yes, surely. Thank you, Bhavna, so much for inspiring all of us, and especially your juniors who look up to you. And I'm sure you have motivated all the attendees here towards pursuing the career in this field. And I'll also remind all the attendees to fill the attendance form. And yes, so I think also it's the break, lunch break time here.
Okay.
So I'll be sharing the questions, or Siddhartha will be sharing the questions with you. And I remind all the attendees to join back by 2:55 post-lunch for post-lunch sessions.
Okay.
And it was so nice hearing from you, Bhavna.
Thank you, ma'am. Thank you so
Thank
much,
you so
ma'am.
much.
Yeah.
Thanks a lot, Bhavna. Thanks.
And good luck to you also, Bhavna, for all your
Yes.
future endeavors.
Thank you so much. I wish to see you guys on campus once this
I
post.
have a request, Bhavna, to you.
Yes, sir.
Your juniors are very much looking towards you for data science, and also they are also very much interested for the MS and all. So I will suggest if they will be reaching to you, some of the students, so please guide them also how they can go for masters and all. If possible, in future we can conduct one session also regarding how the students can prepare MS.
That would be great, sir. I mean, instead of replying to each and everyone individually, I can have one sessions with them and I can guide them what are the materials and what are the steps for the MS.
Yeah, that will be great.
That
So
would be
in
great.
future also we'll be disturbing you like this, and you have to be there.
That's totally. I'm happy to help. And if any one of you have any question related to this field or applying, how you should apply for a job in a data science and what are the skills required, please feel free to connect to me on LinkedIn and I can guide you through that. Okay.
Thanks a lot.
Yeah. Thank you. That's it.
Thanks again,
I
Donna.
guess I'll go and sleep. It's 5 o'clock here. Thank you.
Okay.
Yeah. Thank you. Bye, guys. Have a good day. And bye. Bye.
Okay.
Bye.
So, ma'am, we can close the session.
Yes, so we'll formally close this session here. And I thank you everyone involved in this session for all their support, particularly students who have been very actively involved in all the back end and front end issues which we have been facing. Thank you so much. You're really working hard.
So we'll be joining by 2:55 for the next
Right,
session.
sir.
I know the time is short, but as it's our event, so we have to be there on time. So we hope that all will be joining by 2:55 so that we can continue the same manner the way we have done the first lot. Thanks all. Okay, ma'am.
Okay, thank you, sir. Thank you, everyone.
PPT. I just want to inform that the attendance link will be shared and the question answer links will be shared in the chat.
Is my screen visible?
Yes, Manish.
Good afternoon, everyone. And I know that you are just back from the lunch break, so maybe feeling a little bit sleepy. So this talk that I'm going to deliver here, I will try to give a sort of glimpse like how when we have the COVID-19 data is, or why COVID-19 is a different scenario than rest of the pandemics, and how we can use the data to analyze different verticals, not just the medical vertical, as well as the different impacts that different impact that COVID has created in social, economical, as well as other factors. We will have just a walkthrough of that, as well as we'll also see how we can proceed, how we should proceed with the large volume of data that we have gathered. So just to begin, to introduce myself, ma'am has already said so much thing. I'm really humble and excited. So I'm Manish. I work as the solution manager at Heritage Technologies at Bhubaneswar office. I've been working with Heritage for past 3 years. And Ajitesh, I have been working under him and learned a lot of him. He just had a wonderful talk some time back. And this is my second stint with DSG. I also was part of the during KidFest. We had one session on how to use the machine learning for how a newbie can start with it. So to set this, and I will just give a background. Then the areas of analysis, like where we should look at, what sort of areas we can focus on. Then if we identify, then how to approach that. And after that, we'll also look at some of the challenges that is pertinent with not just with the COVID-19 or anything, but in typical data science or data analytics domain. And at the end, we'll conclude with the Q&A. So just to give a context, I guess for last 6 to 8 months, every one of us have been searching on the Google, okay, what's the COVID-19 case in Odisha, COVID-19 case in your respective states, in the India or in different parts of the world. So, and you may be finding some sort of analytics like that. Okay, WHO has this report. You may also get some report in the very first phase of Google. So if we have this sort of report available this time, what we can infer out of it, how we should use it? Because COVID-19, unlike other pandemics, and many speaker before has also mentioned that like any other pandemic that has happened before, COVID-19 has happened at a time where the AI is kind of revolutionizing the whole IT as well as all the sectors. Unlike other pandemics, during this COVID-19, we have large volume of data which can be fed by different big data architecture and all. So if we have this, and there are a lot of organizations, be it Johns Hopkins University, World Health Organization, as well as then recognized institutions like McKinsey, Gartner, they are collecting a lot of data. So if you have all this, how we can utilize. So I will just take all of you back to your school days. So during your school time, you must have this subject called history, and many of you must not have liked it. It's boring. I have to go to 400 BC or 200 AD when I'm in already in 20th century or 21st century. But every time your history teacher must be motivating you, okay, why we read history? Because it helps us to make a better decision in the future. So that time it must have seemed irrelevant, but when you must have started working, when you have started working on the data science or data analytics based project, you say, okay, I need the historical data. I need your past data. And all of a sudden history has become so much important for all the data scientists or the upcoming data scientists, because we need the data for that. Similarly, when this COVID-19 happened, the whole world had seen pandemics like the Spanish flu and all those in the previous years. And we had a fair bit of estimate, okay, how it could go, what will happen, what can not happen, what would be the peak of the cases and all. And based on that, there were some projections and everything, but most of the projections did not appear or did not happen what it was supposed to. And the reason is because the demographic and the setups, everything. When I say setup, it means how the world is functioning right now is very, very different how it was functioning 100 years before. The technology, how it has revolutionized, what kind of industry revolution has happened in past 100 years. And that is not just limited to the European countries. It has happened to every part of the world almost. The whole setup has changed. And then this pandemic happened. And we reacted rather than we proactively taking the decisions. We mostly reacted. And that's why in almost all the countries, in majority of the countries where we are seeing right now, be it India or Brazil, the situation is kind of, we cannot say it's a good situation at least. So if that's the situation and we have a hell lot of data with us on the Kaggle, on different platforms, on different, with different institutions, government websites, because this has happened at an age where AI is ripe. Everyone is talking about AI, everyone is talking about analytics. So what we can do? So just to, as a data scientist, Bhavna was mentioning sometime back, as a data scientist, you have to understand the domain. You have to understand how, what's the actual cause, what's the problem you are solving. So as a data scientist, it's a word science, it's an experiment. Data science is not just if we are trying to fit some ML model, there is already algorithm available, libraries are available. No. It's you are taking up a problem, you have some hypothesis, you're thinking of some solution, and you want to solve that problem. And why you are data scientist? Because you are conducting the experiment with a lot of data. You want to get insights out of it. So the area of analysis we have, if we have to just take the very first thing, what would be the most important? The most important would be the person's life. So what we can do, what if the similar sort of situation happen, let's say 5 years down the line? Can you find out where the cluster of vulnerables? That it can be the one parameter. So you must have seen in the multiple reports that people with the preconditions, people with diabetes, people with the chronic respiratory problems, hypertension, cardiac issues, where the death rates have been maximum. The graph that I have put on the right side is just one of the graphs. It was calculated some 1 month, 1.5 months back by WHO, from the WHO data, like when people, the number of cases reported out of which the people died, what's the percentage, how it is contributing. So the people with cardiovascular disease are the most risky people. So this is just an example. But if the similar situation arrives, let's say in the month of February, if we would know, okay, so if any respiratory disease comes, these people could be the most at risk. We can take the proactive action rather than reactive to it. What could be the maximum number of cases when we could reach the peak? And based on that, rather than taking the decision on the rough estimates, we can take as a data scientist, when we have so much of data, we can take the decisions based on the data, and that decision would have more substance than rather, okay, this may work, this may not work, that's my intuition. Here, your intuition is the data you have at your hand. And at the same time, there are so much advanced scan reports and everything we have with us, be it the chest scans, the symptoms. Let's say we have 100,000 people tested, 20,000 people had the symptom of, let's say they are having some sort of sneezing, fever. That sort of analysis, considering the other factors where what were the pre-health conditions, the age, gender, whatever it is. If we can use that, we can at least segregate a good amount of, we cannot say that it would be 100% perfect, but very significantly we can impact this death rate and all, in the sense that we would be able to find who are the most vulnerable group. And can we have some better care system, better medical attention, or better the segregation? Can we put some more different sort of rule for social distancing, or as Sarah already mentioned, it's more of a safe distancing? Can you put those rules and separate those sort of person from the community so that they are not at risk? So this is the fact that everyone is focusing, the whole medical community is focusing. Apart from that, as a budding data scientist or as a person who is working in this domain, where we can also focus at these socioeconomic scenarios. So the right graph, I'm just, this is just one of the example, is the usage of electricity usage. From Jan, you can see the electricity usage of different countries. It went back to the usage pattern of a Sunday. How on a Sunday, the electric usage was looking, it went back to that pattern, because the government has put lockdowns and industries were closed, shut down, like that. So why I'm giving this a specific example. So if we look at this whole COVID scenario, our focus would be, okay, let's work on finding some solution for, okay, so some automated AI-based solution for scan reports, suggesting medicine and all. But there are n number of things happening beyond that also, which is not generally coming to our attention, because right now our focus is, okay, the people are dying. Yes, that's the most important part, the people's life. But these data points are also equally important, because the first example that I have put here, online transaction pattern. So if you have observed yourself that you actually hesitate to give somebody money in cash, you actually, if you are good with handling the technology using the Paytm or the credit cards, better you would say, okay, I will do a phone pay, I will do a Google Pay, I will do a card transaction. Because one first reason is you are remotely ordering most of the stuff. And the second reason is you subconsciously or unconsciously, you must be thinking of, okay, there should be minimum touch points with any person external to your family bubble, I can say, because bubble is the most famous term these days because of IPL. So the online transaction pattern, how it has been, is it really surging? If yes, why I should do why this should be an area of analysis? It should be an area of analysis because there are n number of companies working in this domain. If a certain situation happens and if I am not ready with the infrastructure to handle a certain flow, I would rather react. There may be n number of chances for transactional fraud. And I'm just citing one example. I got a call that, sir, you will be getting 2,000 rupees in some, you won some lottery or something. That call used to be, okay, send me through the bank account or something like that. But this time they said, I have sent you a link on PhonePe. Click on that, then it will ask for your bank account. Whichever account you will select, the money will be transferred to that. But that process was exactly same when you pay to Big Bazaar or something. They send you a pay request. So there is a different sort of fraud that is supposed to happen. If we have this data, we can do a predictive analysis. Okay, how this would surge and can be ready before, as a company like Paytm or PhonePe or Google Pay, can we be ready before? Second is supply chain dynamics. The whole world has seen that their over dependence on one country for the supply chain has hit them hard. So again, this is not just about one country, but rather it's more on, okay, if I am focused on what are my way of handling the transportations and everything. Let's say everything was dependent on the cargo shipment or through, let's say, through the airways or something, then yeah, that's a problem. There can be a potential problem in the future. Can we look at how the supply chain dynamics changed, and can we plan if something for the future based on the data? Expenditure behavior has also changed drastically. There are two kind of product that you actually buy. The one which is necessity for you, and another one which is luxury. So with this COVID hitting, and every one of us know that how the GDP of whole world crashed except one country. There was one of the factor that played is we did not spend much because people lost job. They actually did not need, because if you are not going outside, you may not think of, okay, I will have this sort of, I will buy n number of or clothes or something like this, because you are not going outside. Maybe you can also look at yourself, and your pattern on of the shopping must have changed. So, and the companies are now banking on the revenge shopping. The revenge shopping is, okay, once the malls are open, I will go back and buy everything because I have not bought anything. So that's a short-term surge in their shopping. So we can look at those data points, how it has happened, and how a company which is in the luxury domain can work at that. Mental health status, again, one of the most important factor that has been the talking point among the human resource department of all the corporates. Because 1mg.com has reported their mental health consultancy has increased by 90% in the post-COVID or during the COVID-19. And again, if that's a situation, if I'm an organization who is working, let's say, on Practo or something like that, can we have a better preparation beforehand if similar sort of situation occurs, and can we prepare ourselves for the same? Have more number of experts with us, better process automation with us. What Ajit has mentioned, that if we have a proper workflow of the automation with the AI and RPA, this process surge in the demand can be easily met. One more important factor has been the marketing strategies. The company used to have a lot of in-field marketing. You must have seen people standing on, people putting a lot of banners, standing on the roads, meeting in person, happening, a lot of conferences were happening in person. But in the recent 6 months, the whole world, who is the CEOs, the chief marketing officers of the corporates are rethinking their strategy. Their social media posting, social media hiring, the expert requirement in the social media domain has increased tremendously. So these are, I'm just highlighting some of the areas or the socioeconomic scenario that has changed. And since we have the data this time with different organizations, and they are running a number of simulations on top of that, we can use this data, look at the pattern, look at the behavior, the people, how people are interacting with different factors outside. And this right side graph is just a simple example, how the electricity usage changed. India is now looking, India actually has all its oil barrels filled where they used to store the petroleum. Now it is looking for USA in storing the petroleum there. So these are the scenarios that were unprecedented, because, and we could not do a much prediction because we did not know in the past how this kind of pandemic would turn out in a world where the population is 7 billion, in excess of 7 billion. Population of countries like India is in excess of 1.2 or 1.3 billion. since there is data with us, there would be, as a data scientist or as a person interested in the data science domain, look at those data points, go through them and have a different sort of analysis. There could be predictive analysis, there could be descriptive analysis on top of that. So if we have these areas of analysis, how should I approach it? Because I know, okay, these are the some of the areas where we can go deeper and understand how it has happened. What GDP factors actually led on to a GDP contraction of 23%, or on an average world has expecting to contract by 25%. So what were those factors, how those factors played, how the industries were behaving? So how will you approach it if you have this situation, or you are a person who are thinking of, okay, there is a lot of data, how I should look at this? The approach would be, it's again, we say data science, so the approach has to be scientific. You cannot work on all the stuff at the same time. So based on my experience, my guidance would be identify the area of impact. In which area you want to work, maybe the medical stuff, or maybe the other factors that I have just mentioned. And what's your problem statement? What do you want to, and then identify the problem statement. What do you want to get out of it? The example can be, okay, I want to come up with a predictive usage of electricity during this, if a similar sort of situation or lockdown comes. The domestic usage increased, because if I can just give us a simple example, since every one of us are working from the home, our laptop and everything is on, AC is on for almost 24 hours or 16 hours a day. But when we used to go to office, we used to be at office for 10 hours, 8 hours. And at least for those times, the usage of electricity would be on the lower side. Once you have identified the area of impact and problem statement, now, I have mentioned some time back that data is the most important thing to analyze. So where to get the data? So there can be, okay, should I get the data from, let's say, something I don't know, so some organization I don't know, or should I get the data where the sources are reliable? The sources can be WHO, the government websites, Johns Hopkins University, or the institutions like that, or the recognized agencies like Gartner, McKinsey, BCG, the firms where those analytics reports are accepted worldwide. Once you have that, you know the area of impact, you know what kind of problem statement you want to solve. Start your analysis with a hypothesis and a lot of question, because as a data scientist, the very first trait that you have to acquire is be curious. Ask the question up to any detail till the last point where there is no more discussion beyond that. So once you are, so ask questions, because if you are very sure about the data, then only you can start your analysis with an objective. Okay, I want to solve this. Okay, once you are clear, okay, your analysis and everything, you want to know, okay, I want to solve this problem, I have the data, how you should approach it, then there can be a number of methods to solve a problem statement. But since it's an experiment, you have to experiment, and then you have to judge, okay, which experiments are successful, which experiments are failure, because in data science there is nothing like hit and trial. If you are working with the concept of hit and trial, then that's not a science, that's just a random experiment you are conducting without knowing what's the reason of it. For examples can be, okay, I want to predict the total number of dead cases at the end of the pandemic. You can have time series based forecasting. You can go with the concept of delta T argument.
Sorry to interrupt you, but we have just 5 more minutes.
Sure, ma'am. I will just, this is the last slide, I will conclude.
Okay. Actually, some questions also students wanted to ask.
Sure.
So, yeah, we'll quickly take 1 or 2 questions as you
Sure.
Yeah.
So there can be a number of approaches. So, and once you have performed your experiments, validate your findings. And as a data scientist, since we say, okay, we are going to solve this problem with a suggestive solution, So we must first validate how our outcomes are, and then we can suggest some preemptive action. The preemptive action means the actions that you take to nullify some of the future incidents. So you must be, I guess, if you are from computer science department, you must have seen the concept of preemptive scheduling. Then there is, you must have seen in the, okay, India did a preemptive action against China. So it's a more of an proactive actions that you take. The challenges are pretty similar that you can see in any data related work. That is, your data can be incorrect, your data can be insufficient. There can be a privacy factor that can actually hamper you, or you cannot share data, or you cannot get data. And two of the factors, or one of the factors I have mentioned at the bottom, is explainability of the model. So whenever you are proposing a solution to someone, there must be a question, okay, you are saying this is happening, you are saying this is a black box, but why should I believe you? So if you're working on the data science project, your focus must be on, if I'm able to build something, am I able to explain that? If I'm doing a black magic, or if I'm saying because when you are going to see a magic show, you always try to find out, okay, what the magician is doing. So that would be one of the challenges, but definitely the challenges are the ones where we find the solution and we discover something new. And if I have to say the conclusion of this presentation, or what I want to say is, if we have so much of data and we are in the age where AI is ripe, we should be proactive with that rather than being reactive towards it, rather than taking reactive actions. So use the data science approaches, the algorithms, the tools available around you, and utilize them to build the proactive solution, the proactive measures, rather than reacting to a similar sort of situations which happens in the future. If we do that, then it means we are the fools because we did not learn from the past. So that's it from my side.
Thank you, Manish. That was really informative, and I think that would provide a base for our students, current students, to know how to proceed if they want to take up any data science project. One of the questions which I'll be taking is, it says that the data sets mostly we work with in this COVID-19 scenario is derived from the government data, actually, the data that is provided by government. But in some cases, we find that the data sets are not complete, or the reporting technique that has been used by different governments from different countries is different. So what all critical considerations should be taken into account when we are dealing with such type of a scenario? We are taking data from different government websites who have taken the data with different mechanisms or different methodologies, so that the more accurate data interpretation can be done.
Yeah. So one thing is very interesting, like when you work on any data science stuff in some training or something, so you will have very ideal scenario. Everything looks good, fair, all the columns, everything very homogeneous. But once you get into the real data science stuff, the first thing is how we prepare the data. And the question is very good question, because the agencies, how they conduct survey, how they store the data, that's different. So one important factor that comes into the play is whenever you are getting data from a country, so the concept is called the normalization. The normalization comes in a way, let's say if I'm getting data from India and if I'm getting data from USA, I'm taking a very simple example. Let's say data in India is coming from per capita income as some rupees, and data that the USA is sharing with me is per capita income with some dollar. The very first thing, that's a very naive example, and first thing that we do, okay, convert them on similar scale. Similar sort of stuff, when we start gathering the data for, let's say, this COVID-19, the data would be there would be different scales, the per million. If we look at the data, for example, the death rate per million, even if the people die in India is the same number in the US, but per million count would be different. That would be where our understanding of the domain, okay, what I'm trying to solve, that will play the role. More we understand our domain, more we will be able to come up with the techniques which will actually normalize the data, different data points or sources of data points. And that's why it's extremely important that if you want to do some sort of data science related work on any domain, understand that first completely. Because if I know, okay, the data coming from US and data coming from India, if they are giving me per million figure, then first thing that I have to do is scale them on the similar scale. Or the source or the columns are different, what are the key factors that we need to do? It cannot be a blind merging of the data sets and work on that. So my suggestion would be understand the domain, the purpose for which we are solving, and from there, which of the attributes from the data that is required for us, are they on the similar scale or not? Are they representing same set of similar sort of sample or not? For example, if I'm looking at data for animals in COVID from one country and humans from COVID from another country, then that's of no use because we are going to solve nothing out of it.
Okay, thank you, Manish. I think that that would be doing for the student who has asked the question, and that was really a nice question, and the answer lies in the data preparation. Thank you for the nice session, and I think your juniors will be really motivated to work on real life challenges with all the COVID data that is available to them. Thank you again. Next, I'd like to welcome Shubham Kumar. It is really, I mean, it seems like it has been yesterday when I was just auditioning Shubham for Freshers Party. And today he is among our eminent speakers list. I mean, it is really nice for me. I remember that day when I was auditioning you, Shubham, in OAT of Campus 15. I do remember that day I am reminding, and really feel honored to welcome you. So for the audience, Shubham Kumar he is a KIT alumnus and is presently working as business technology analyst at Deloitte US India Consulting. He is having an interest in research, and he has also worked as research intern with the Center of International Mobility, that is CIMO, Government of Finland in Helsinki. And currently, he would be giving his talk, his deliberation on the title Healthcare Analytics and Advent to Mitigate the Risks and Impacts of the Current Pandemic. So welcome you, Shubham, and looking forward to listen from you, and feeling proud that you have traveled from that day to today when I heard you for the first time in OAT.
Thank you, ma'am. Am I audible?
Yeah, you're audible.
Okay. Just trying to share my screen. And let's see if it works.
Yes, your screen is visible.
Okay. Right. Just sorry, I'm having like a lot of screens open over here. So just in order to be on the same page, the healthcare analytics sheet, like the presentation is open, right?
Yes, that's open.
Okay, perfect. So to start with, thank you, ma'am, for the introduction. I am invariably nostalgic to be introduced by Manjusha, ma'am, in a data science conference, since it was my job back in the days. And because I was the one who was hosting innumerable conferences and seminars, I'm so happy to hear that you remember that day when you auditioned me the first time, and there has been, I think there's been no looking back. Before starting, I want to thank the administration and the faculty members of KIIT, especially Dr. Siddharth Swarup Raudre, who was also my tutor mentor back in college. Thank you, sir, for giving me this pristine opportunity to present my views on such august platform.
Most welcome.
Thank you, sir. So good evening, everyone. My name is Shubham Kumar. I'm a proud alumnus of KIIT and currently working in US India Consulting Division of Deloitte. I am close to completing 3 years in the firm, and I've primarily worked in US healthcare and insurance sector, providing a lot of functional and technical solutions, a majority of which use analytics and cognitive as an explication tool. Apart from this, I've also led a team to work on a solution of US retirement plans. So primarily my domain of operation is United States. And here I am going to talk about healthcare analytics and advent to mitigate the risk and impact of pandemic. First thing first, healthcare analytics is a broad term for a specific facet of analytics which sweeps in a wide sash of healthcare industry, providing macro and micro level insights on patient data, risk scoring for chronic disease, hospital management, optimizing cost, expediting diagnosis, and so on. Now, this is something which I wish to explain and endorse as an advent to mitigate the risks and impacts of this pandemic. To start with, there's no contents. I would want to say that I would keep this talk very informal, and there's just a lineament which I have done, which is like an outsketch of what I'm going to talk about, which contains healthcare information system, a brief history, because I want the students over here to ask the question why rather than how. I think how is something which anyone can Google and see like a lot of solutions, but we need to be sure upon why are we doing this. The intent has to be right before we do anything. Then we talk about Obamacare, which is a landmark and a base for healthcare analytics as we see it in the current approach. Also, we would be covering big data, a platform to innovate, use of data for analytics, managing healthcare and patient outcomes, a sample healthcare business suit model, basically an architectural diagram, and healthcare analytics and this pandemic. So to start with, let's talk about healthcare domain. Now, making itself as the prime fascia of the human development, the healthcare domain is certainly one of the largest and most prominent industries around the globe. This industry goes in tandem with the survival of lifestyle and living quality of the modern humans, and hence reflect a direct reverberation to people living in different continents, countries, or cities. If one has to define it, healthcare is the diagnosis, cure, and prevention of any mental or physical impairment, such as an injury, disease, or illness. It is performed, crafted, and delivered by trained practitioners who could be present in different domains across medicine, psychology, psychotherapy, and a lot of other professions or domains as well, some of which contain dentistry, nursing, pharmacy, allied health, and other healthcare providers. This industry is responsible for end-to-end steering of the medical procedure, which ensures the current treatment of patients. This sector has been present in one or the other form since ancient times, to be very precise, since Neanderthal times, and today it's the fastest growing sector in the world. The delivery of this sector depends on how the internal segregated group of professionals function and align together. The healthcare industry also interacts with different domains to provide augmented and optimized services. And to start with, we want to look at its journey throughout the late 20th century with special emphasis on healthcare information system. And before we do that, I have a fun fact for everyone. So if we have to talk about how this whole healthcare information system and healthcare analytics arose, back in 640 BC, we had a certain or a similar sort of an arrangement, which was called case records, which was basically looking for the earliest trait of healthcare information system and to demonstrate natural cause of illness. It requires openness and honesty in terms of people who were suffering from these ailments and people who were supposedly treating it. And also it was evident by frequent death, but that was humans' first attempt at making a structured kind of an environment for healthcare as a profession. Now we want to look forward to the journey of this whole healthcare analytics sector and healthcare information sector as well. And we'll be taking the United States of America as the prime model. And we want to just look at the journey, how this whole healthcare sector has arisen at the place we are today. Also, on a parallel note, we would also be looking at how information system started its journey, and together it's called healthcare analytics, and how there's a role of big data which is there somewhere on the middle. So to find the roots of the information technology, we need to travel to good old 60s, where Medicare and Medicaid program gave a platform rather than a purpose to the healthcare information system to grow. Now, Medicare is a federal program that provides healthcare coverage if you're above 65 or under 65 or have a disability, no matter what your income. Medicaid is a state and a federal program that provides health coverage if you have a very low income. And these were the two programs because of which the whole concept of the state of information technology arose in this sector. Back in the time, we had mainframe computers, which I don't think this time had like an active coding environment, but later it became COBOL. Data was centralized process. There were few vendor developed products, and the administrative and financial systems were all handled by these large mainframe computers. The data processing was on mainframe computers, and it was developed and maintained in-house. Now we have seen that mainframes were the dominant platform to store and process data. If we look forward, what happened in the next decade? In 1970s, mainframe gave rise to mini computers, like mini computers came into picture. And data was still stored on mainframe-based databases such as DB2 and IMS. Also, one particular thing which has to be understood over here is the turnkey system, which is a computer system that has been customized for a particular application. Now, the term derives from the idea that user can just turn a key and the system is ready to go. Turnkey system include all the hardware and software necessary for particular application. And in 1970s, it started coming into picture as for this healthcare industry. Coming on to 1980s, a revolution took place in the form of DRGs. So DRGs revolutionized the information and processing in the healthcare sector, and they were first implanted nationwide by the Healthcare Financing Administration, called SCFA. That's still prevalent as of now. And it helped to control cost for patient services billed to Medicare. HMSA first began using DRGs when the preferred provider plan was developed in 1989 and gradually implemented DRGs for other HMSA plan. Now, in order to understand what are these DRGs, so a diagnostic related group is a system to classify hospital cases in one of the original 467 groups. The system was developed in anticipation of convincing the Congress to use it for reimbursement, to replace cost-based reimbursement that has been already used at that point of time. DRGs has been used in the US since then to determine how much Medicare pays the hospital for each product. And since patients within each category are clinically similar and are expected to use the same level of hospital resources. Talking about the software structure, it functions on application of a grouper. A grouper is a software program assigned, which is designated to assign to DRG classification. Hence, DRGs are assigned by a grouper program based on international classification of disease by diagnosis, procedures, age, sex, discharge status, and the presence of complications or comorbidities. Here we find the initial trait of what we call as a healthcare data segregation and analytics. Also, if we have to look at 1980s, increased use of PCs were there. The data processing was decentralized and the billing system was used. These are like some of the prevalent practices of 1980s. Coming to 1990s, there's only one point, or let's say one particular abbreviation which actually is required in understanding whatever's written on this in this particular sheet, that is EMR, called electronic medical record. It began as an idea of recording patient information in an electronic form instead of a paper. And the first EMR was developed in 1972. And it was welcomed as a major advancement in healthcare and medical practice. Due to the high cost, this EMR wasn't as widely used as anticipated and was primarily utilized by government hospitals. But later, as we know it, this EMR has become the backbone of healthcare analytics. Now in 1990, where the cost of hardware drops, we have a proliferation of internet, we have World Wide Web, and the healthcare organization have started taking the advantage of internet. The computers were becoming more affordable and became more common as the internet emerged. And the Institute of Medicine projected that by the year 2000, every physician in the United States office should use computers and improve patient care. Now we are slowly progressing towards the journey of healthcare information system through 90s. And if we have to look at the whole 2000s, a lot of reforms took place, and which paved the way, which paved the way for the requirement exacting the meaningful data, which further led to the Tiger Initiative. If I have to just summarize these two slides, I would just say that a lot of policies were taken into place, and they wanted a heavy investment towards healthcare analytics and healthcare information system. Also, we had large amount of data which we didn't know what to do with it, and it was difficult to extract meaningful information. Hence the focus on analytics started. Also, the resurgence of mainframe computers to handle enterprise-wide application is there. There's one more fact which I want to present over here, that till now, despite the fact that we have so many advanced databases, a majority of United States PHI, which is healthcare data, still resides on DB2 and IMS, which is databases of the whole mainframe system. And till today, there have been innumerable projects amounting to billions of dollars, whose job is to just get the data out of those particular databases and process it. So this is a challenge which we are facing till today. Now 2000s came, like along with 2000s came the Tiger project. And to me personally, that was a landmark. I think that was the place where we took a jump and where we decided that, okay, informatics and technologies are the way ahead. Because talking about the Tiger initiative, the technology informatics guidelines education reform, it worked to advance the integration of health informatics by enabling the use of informatics and technology to improve patient care while fostering a learning health system. Founded in 2004, the Tiger initiative emerged as a grassroots effort to allow clinics and consumers to make better use of informatics tools, principles, theories, and practices by interweaving these technologies into practice, education, and research for the better sake of outcomes, patient safety, and cost reduction. Theoretically, I would say this moment is the birthplace of healthcare analytics, modern healthcare analytics as we know it. And at that point of time, we had a 10-year vision, which was looking perfect, but we all know how it went down all the way. So moving forward, 2009-10 was also a very revolutionary year if we have to talk about the reforms which happened, particularly in terms of healthcare IT funding, because the Affordable Care Act, formerly known as the Patient Protection and Affordable Care Act, and commonly known as Obamacare, it was signed and was taken into practice, which is a United States federal enacted law by the 111th United States Congress, and was signed into law by then President Barack Obama on March 23, 2010. Why this is important? Because the various provisions in this particular law presented or allowed a flow of the surplus fundings of information technology domain in the healthcare sector, which resulted in the structured storing of clinical and medical data. Now, what happened in the next decade is something which we are invariably aware of. The last decade has witnessed a massive digital growth and has engendered something we call it as big data. Now, I do not need to come here and define what big data is, but if I have to just delineate what big data in healthcare means, then I would say it would refer to the abundant health data amassed from numerous sources, including electronic health records, which are EHRs, medical imaging, genomic sequencing, payer records, pharmaceutical research, wearable and medical devices. These are just to name a few. Now, three characteristics distinguish it from extraordinary high volume. Three characteristics distinguish it from the traditional electronic media and human health data, which is used for decision making. Now, these characteristics are that these data are available in extraordinary volume. The name says that. It moves at a high velocity and spans the healthcare industry's massive digital universe. And because of it, it derives its name from many sources, and it's highly variable in structure and nature. Now, this is known as the 3 V's of big data in healthcare industry, to be precise. Okay, so now we know that we have got a huge amount of data. Now the question is what to do with it. With the diversity in format, type, and context, it is till now difficult to merge the big healthcare data into conventional databases, as I explained, because of the presence of DB2 and IMS, which are sort of old databases. Now it makes it enormously challenging to process And it's also hard for industry leaders to harness its significant promise to transform the industry. Despite these humongous challenges, several new technological improvements are allowing healthcare big data to be converted to useful, actionable information. Coming over here, we want to see the use of data and how convergence as an entity plays a huge role over here. To start with, once we have all the data, the next step involves converging it into the first, converging it, and in the first diagram, as we can see, it compares this process with the parts of a plan. Before talking about anything, I want to explain convergence is the coming together of two different entities, as we all know. And in context of computing and technology, it's the integration of two or more different technologies in a single device or system. Just to take a good example would be the convergence of communication and imaging technologies on a mobile device, which is designed to make calls and take pictures. Two completely unrelated technologies, but it converge on a single device. And also, I want to go personal over here and take an example of a special section of people in Deloitte who are working towards providing a convergence solution. Now, one of our prime divisions called Analytics and Cognitive in Deloitte is working on the convergence of healthcare trends. The convergence of four powerful trends is transforming the traditional US healthcare market, creating opportunities for innovation in four major areas. The convergence of powerful trends, new technologies, the demand for value, a growing healthcare economy, and a government as an influencer is transforming the traditional US healthcare market. While this convergence is creating substantial change for healthcare stakeholders, it's also creating opportunities for innovation in four major areas, which are everywhere care, that is shifting the spectrum of care from hospitals to lower cost sites, wellness and preventive care, which is shifting disease management from reactiveness to preventive measures, personalized care, shifting offering from mass generalization to mass customization and precision, something which is required right now. Like whatever solutions we have is something which is mass generalized, and what we require is something which should be mass customized. Also, aging, chronic, and end of life care, that is something which is very much important. And to survive and grow in this changing healthcare landscape, all of these, like a lot of these organizations are considering developing innovative strategies that we can capitalize for this emerging opportunities. I won't dive deeper over it, but if you're interested in this specific topic, you can check out Doblin, which is DOBLIN. That's a leader of global innovation and a part of Deloitte Consulting LLP. And it provides a framework, 10 types of innovation, which details the building blocks of innovation that organizations should consider implementing, particularly in this domain, if we have to talk about use of data for the converging purposes. Going forward, if we use all of these technologies correctly, then we can use the clinical data and other healthcare data to fulfill all of these goals, which are diagnostics, preventive medicine, precision medicine, medical research, reduction of adverse medication effects, cost reduction, and population health. How it would happen? We have to check over here. We have to use the analytics in an optimum way, which can be considered, let's say, a proper amalgamation of clinical outcomes and operational outcomes. Also, talking about patient outcomes, the entire person's health continuum has to be segregated into 6 different sectors known as the wellness. Well is like the wellness as in general, researching, preparing, evaluating, recovering, and maintaining. Talking about the mechanism of influence, we have to use behavioral insights, collaborative interactions, self-management tools.
Sorry to interrupt, Shubham.
Yes,
Can you just wrap up in 5 minutes? I mean, we are short of time.
Okay, ma'am. I'll try. Then I'll jump on to the cool stuff, which people would definitely enjoy.
Yeah.
So I want to talk about the architectural diagram of a sample business suite And over here, basically, there are 4 different parts of this whole architectural diagram. And to start with, there's another fun fact about this RS claims. Now, what RS claims means, it's one of the data sources. You can see it's the second data source. It's nothing but a medical prescription. And the symbol RX is usually said to stand for the Latin word receipt, which means to take. It's customary part of the superscription, which is the heading of a prescription. Now, quickly talking about the 4 different layers of data analytics for business transformation in this particular sector. It would be business context and planning, analytics modeling, data, technology. Talking about the raw data, which would come from all of these data sources as mentioned. The next layer would be the enterprise data model, which is very important over here. As we can see, it's divided into 2 different parts called insight layer and data access layer. Now, this enterprise data model is an integrated view of the data produced and consumed across an entire organization. It incorporates appropriate industry perspective. Now, an EDM represents a single integration definition of data unbiased of any system or application. Next, we have the analytics modeling layer, which is the key element in data analytics required to understand the business data to make accurate database predictions to be precise, and to extract valuable insights for making the correct business decisions. If we use all of these correctly, and if we incorporate an intelligence version of a healthcare business suite, we'll be able to successfully predict, convert, empower, and navigate a whole channel, a whole system, which will contain not only the patients, but also hospital management as a whole sector. So I have the last 3 slides, which actually talks about outbreaks. I actually wanted to keep it as blank because I believe that despite the fact we can talk about it like the whole day or even a week, we won't be able to understand what these are with the current amount of data which we have. But if we just have to delineate it or define it, a pandemic can be delineated as, let's say, as a widespread general case of global outbreak of an infectious ailment, which can have multifaceted effect on one or more essential aspect of human survival. They are capable of causing sudden and imminent disruption across innumerable fields, such as healthcare, economics, politics, and so on. And this impact usually lasts for years, and recovery takes an extra amount of physical and psychological resources. Basically, there are 4 sorts of outbreaks which I wanted to discuss. Now I'll take all at once. If I have to just summarize this whole sheet, we started this century with one particular outbreak, which was SARS. And in this case, a huge setback was received in form of delaying reporting, which directly contradicts the whole purpose of having a goal of being prepared. Now, this specific example led to a lot of policies which were formed. And I would say we gained a very small success in form of influenza, like in form of this combating this pandemic for 2009 influenza. And the world achieved a very short-lived success. But all of this success were exposed, like these slits were exposed when many such outbreaks of similar nature were kind of encountered in 2014, which are basically the Ebola epidemic. And today, what we are encountering, we call it as COVID-19. Talking about the key to mitigate these pandemic, we have to use the electronic medical record, but how? In order to be prepared and to be ready for the next pandemic, the risks, impacts, and mitigation has to be defined. A separate listicle has to be maintained for knowledge and for technological gaps, which would help mankind to be prepared and equipped, both physically and psychology, to combat an outbreak. Here, analytics plays a very crucial role. According to the diagram, the electronic medical record, or the EMR, is something which will actually help us to get the pattern correct in form of one particular outbreak which is still there, and also it will help us predict an imminent danger. Now, the current records have helped us segregating the type of risk involved, which can be broadly classified into 2 categories, which are called spark and spread. So the first category denotes the instantaneous risk at time when an outbreak comes into existence. That's called the spark stage. And the second stage denotes the risk where the outbreak tries to unfurl and outspread, thus taking the form of an epidemic or in worst case, pandemic. Slide 6, which is like the second last slide, is basically about why personalized evidence-based medicine is required. To give it in one line, the population is not uniform and they do not have equal access to healthcare and exposure to virons. We had a common myth last decade, and it was exalted till the year 2020 that Central and West Africa are at a high instantaneous risk and they do not possess a steady amount of preparedness if compared to the rest of the world. Now, this myth was debunked by the advent of the novel coronavirus, also known as COVID-19, when the outbreak started from oriental region of China and spread across occidental Europe before engulfing the entire globe. In such an unpredictable scenario, medical science would have to take the aid of probabilistic modeling and analytic tool to gauge the risk involved and to evaluate the estimate and potential tramen of pandemic and provide appropriate medications. Also, exceedance probability curve are one such utilitarian piece of mechanism which has the capability to amalgamate the probability of a threat and its corresponding economic loss. Just taking one example of such potential threat, influenza till today has the capability to be a pandemic which can cause 6 million deaths worldwide. It was observed with the help of EP analysis that in a given year, the probability of the previous mentioned scenario would come as 1%, which is huge. So talking about all this pandemic and outbreaks, I would say the worst is still there to be faced. This is the last slide where I would talk about preventing impacts. And is the point of care too late? Now, the healthcare analytics domain can also help in laying down the potential impact which a pandemic might cause in a stipulated period of time to make a balance between health status and spending. Like we can see there are two lines which are health status and spending, and how they kind of converge at early clinical symptoms and how they are basically laid out if we have to look at low risk, at risk, or high risk. So it is observed in an outbreak that a huge, like in outbreak in the range of pandemic, that it can cause colossal and outstretched growth, both in mobility and mortality. Mobility and mortality. It has also been observed that in lower and lower income countries, this kind of outbreak can have excessive mortality impacts. There are a number of verticals and channels through which a pandemic can cause economic turbulence, which includes short and long-term setbacks. The short-term setbacks usually caused due to fiscal shock in market received during the spark period. Remember I talked about spark and spread period. So the long-term setbacks are a result of damage to the perennial economic growth during the spread phase beyond that. Talking about the psychological impacts, a pandemic may induce behavioral changes which can lead to widespread panic and agitation. They're widely interconnected as the long-term setback on the economic market. Now, this fear can result into a state of reluctance towards investment and purchase. In certain specific countries, a pandemic can also give rise to political contortions, which can result in mob violence, mass clashes, and a state of constant tension between citizens and the government, and no point for guessing which that country would be. Now, in the view of all these medical, social, economic, psychological, and political impacts, healthcare analytics can actually play a vital role as the study and the chieftain combat mechanism by helping us with the personalized evidence to enable proactive decisions. And through all of the previous slide information, we are well aware that an efficient way of implementing healthcare analytics on this sector is to combine predictive analysis, data visualization tool, and business suite to get valuable information that can both deliver actionable insights to support decisions, as well as to reduce variations to optimize utilization and successfully prevent fatal impacts. For my concluding remark, I just want to state that in order to devise a more potent approach to prepare for the next pandemic, the clinical data has to be improved, which would provide a more granulated information to augment treatment effectiveness and success rate. Confirmatory data analytics combined with predictive modeling can be used to furnish unexpected gaps in terms of getting the required clinical data, which is vital for success of this approach. Thank you everyone for being such a wonderful listeners. So is there any question?
Thank you, Shubham. That was really very exceeded 5 minutes, because of which we are not able to take questions. But I'll ask the student coordinator to send all the questions to you so that you can get back to our young minds, and you can answer them back and bring for you your project also. And
yes,
it was really informative, and I think that is need of the hour also, which you have emphasized. And I hope many of our students would be listening this and would be again planning their project space. Thank you once again. With this, it was really proud to host. And now I'll give the stage to a set of speakers. Thank you, Shubham, and thank you, Manish.
Thank you.
Ashit, for nice coordination. Bindu ma'am, please.
Okay, ma'am. Thank you, Manjusa ma'am. So I would like to welcome you all to the Digital Data Science Conclave organized by the Data Science Group from our School of Computer Engineering, KIT DU. And now I would like to welcome our alumnus Sabyasachi Chakravarti, a very special guest from South Korea. He is the CTO of Terence AI, Busan, South Korea, research scholar from Inje University, Republic of South Korea, and this KIT DU. Alumnus has over 25 publications with research in areas including deep learning, machine learning, biosignal processing, and brain-computer interface. He is a detail-oriented and results-driven data science professional, executing data-driven decisions for solving critical problems in the fintech and healthcare domain. Today, he will give a talk on computer vision-based diagnosis of COVID-19 from chest X-rays and health passport for the personalized risk assessment of individuals. Without taking any more time, I would like to welcome Mr. Sabyasachi. Sabyasachi, is over to you.
Oh, thanks, Bindu ma'am, for such an awesome introduction, honestly. And Manjusha ma'am and Siddharth sir, always I'm really thankful for giving me the opportunity to speak in this conclave. It's so nice to see everyone out here and my friends and everyone like Shubham, Manish, and everyone. It's so cool to see everyone, really. So I will just keep okay. All participants, just a sec. Okay. Just a second. Can everyone see my screen?
Yes, it's coming.
Yeah. Awesome. So I will keep my presentation very fast. It would be really fast, and I would like to do more discussions what we did during this COVID-19 outbreak that happened in South Korea, and also how the team of CV19 volunteers, we worked for the Kuwait government. So normally, as everyone knows, that South Korea was one of the first country, it was the second country after China, which was actually hit by COVID-19, and it actually started on February 20th, 2020, the massive spread of coronavirus. And I would still remember that Siddharth sir and Manjusha ma'am, they called me hey, how are you? Are you doing good and stuff? So yeah. So the thing is, there was a massive spread of coronavirus in South Korea on February 20th. And at that point of time, there wasn't many like researches that came out regarding regarding coronavirus. And like, we were very much scared about that situation. And so obviously the number of cases that happened in South Korea was like around 402 average cases per day, but it was like too much for us because like we were the second country which was hit by coronavirus. And also like the population is very small out here. It's like a 50 million population. So for 50 million population, 402 cases are like too much. And also there were like travel bans and like elevated quarantine for all the people who were traveling from South Korea and coming into South Korea and everything. Now, how the Korean Center of Disease Control started working in this field. So the first thing, they devised a social distancing protocol, like from stage 1 to stage 4. And what are like for stage 1, you cannot be with you cannot be in a place where there are like 50 or more people. Stage 2 was like 20 people. Stage 3 was like 10, and then 5 people or more. And also like there were other protocols inside each social distancing protocol, but it's like too much for me to discuss right now. Also, a buzzword was created in Korea. So it was not created in Korea. It was like in 1930s or 1940s. It was like started in England, which was known as untact, which was like non-contact. So that was like devised in Korea, and everywhere, like from social media, and like at every point you can see only one word, that was untact. And also the Korean government devised a 3T protocol, which was known as testing, tracing, and treatment. So like we would test people. So the thing was, we would test people, then we would trace what was happening, like where that person went, at which shop he went, which location he went, what was the car, or which taxi he rode, and all those kind of informations were captured. And after that, the treatment was initiated for each and every patient. So the best part was, it started on February 20th with like 400, 500 cases, and the maximum reached around 1,000 cases a day. And within a month, March 15th, like I still remember the date, March 15th, the numbers were in 1 digits. It was single digit numbers, like 2 people, 1 people a day. So now right now, again, the second wave started out here, and it started from 15th August. And the initiatives which was taken in the first wave has been taken again. And right now the numbers are in double digits, and everyone is waiting for the second defeat of coronavirus out here. So what is the reason that this country, like I understand the model that South Korea followed cannot be implemented in country like United States or India, or like countries with a population of where the population is exceeding 1 billion, like that. It's not possible to adopt such models in this big countries. But what was the reason that actually made South Korea defeat coronavirus 2 times? The thing was data. So what South Korea did, so initially South Koreans started building the RT-PCR test kits, as I remember. And right now, like in India also, we are using RT-PCR and rapid test kits so that it can be, like the testing has increased in India, obviously. And the company that is working, or like which is developing RT-PCR test kits and rapid test kits in India, the leading company is SD Biosensor Private Limited, which is a Korean company, honestly. And it has also imparted its technology to other companies based out at Pune and stuff. So now let me come back again to the data part. So what happened for each individual once confirmed with coronavirus, all the tracing happened. And the tracing was actually made public by retracting the personal information of the patient so that the patient cannot be identified based on the public data that was released. Also, what the hospitals did was that they took a lot of data. They gathered a lot of data about a patient. Like, let's say you are detected with coronavirus using an RT-PCR test kit or a rapid test kit, but that was not done. The government was collecting chest X-rays, CT X-rays, and also biosignal data like heart rate variability, resting heart rate, respiration, and all those kind of things. So this kind of information, or this amount of data that was calculated from the individuals, gave a huge leap to this country in solving or stopping this coronavirus thing. Now, the best part about this government out here, so it's as I'm working in South Korea, so I really like the government and how the government works out here. That's my only thing. And the best part, what the government did, the government tried to work with startups. So now, as those data, so a huge amount of data was being collected by the government at that point of time, the startups or the small and medium business enterprises did not have access to such huge amount of or such a humongous amount of data, right? So what the government did, the government gave out data vouchers. Government gave out data vouchers. So now startups, like when I was working there in Terrence, we actually won a data voucher. So the data voucher was for chest X-rays. So we can get as much as chest X-rays of coronavirus infected people. Like we can get like whatever amount we want. We can get those data, and those data was signed by the Korean government. Now also, so as we got the data, we were very much interested that let's make some kind of CV solution which can make the testing very fast. So what we did, and also our business dev team also connected with some of the guys in Italy, which was also where the numbers were also growing, Italy, and also in US, and also in Singapore and Malaysia and Indonesia, Singapore, Malaysia, and Indonesia. So our BD teams actually worked and got more data from there. So at the end, like we had around 13,385 chest X-rays, all posterior anterior chest X-rays, like from the frontal side. And we developed a platform known as COVXR. So COVXR was an AI-based computer vision platform where the detection of COVID-19 from chest X-rays could be done. And also we were performing some kind of localization of the aneurysms based on activation maps, semantic segmentation, and bounding boxes, and whatever it is. And the best part of the system was the results we received were in like 20 to 30 seconds. You can understand whether a person is a normal person, viral pneumonia, bacterial pneumonia, or COVID-19. We could understand those kind of information. And the model actually depicted an AUC ROC of around 94.7%. But the thing was, initially, while we were developing the model, so there is always a problem. Like when we are in the sales side of artificial intelligence and we are selling some AI product, it becomes very, 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 very difficult for us to actually sell the product, because everywhere, the doctors, the physicians, they would say, hey, how can you trust this result? I don't trust this. How can I believe this? So that's always the question. So initially, when we launched our version 1, it only said that whether the person has COVID or non-COVID. But those data did not have the markings or did not have any kind of segmentations, like which part were affected. Was there any kind of fibrolysis? Was there any kind of plasmas, or what was there? We didn't have any kind of abnormalities shown in the chest X-rays, like after the processing. So what we did, we got contact with the Chexpert data repository, the owners of the Chexpert data repository by Stanford, and we asked for their help so that we can get the segmentations of around 100,000 chest X-rays. So Chexpert is a database where you have 100,000 or 150,000 chest X-rays, and those chest X-rays were being marked with the anomalies. So what we did, there was one Chexpert data, and also we had the open source IEEE 8023 data, then data from Italy, then Korean government hospitals, then NHS UK. We had all the data. And what we did, we created a primary model which could detect 14 chest abnormalities in any patient. And after that, what we did, we used a transfer learning method to actually create another model which was trained with COVID-19 x-rays, only COVID-19 and normal x-rays. And we were trying to understand which parts in the chest x-ray were affected, like which part in your chest x-ray was affected, what was the problem, and those things. At that point of the time, the doctors were happy with the results, which was in version 2 or version 3. I don't remember exactly. So the doctors were happy at that time because they could see that, okay, the system predicted a chest x-ray as COVID positive. And now the doctors could also see the reasons, also see the abnormalities that were in the chest x-ray. So doctors were very happy with it. Now, presently, this system right now is being clinically validated because the results or the results which we get in our company or in a lab is not enough for actually productionizing a particular software system, which is based on AI. And moreover, that is based on healthcare. It's not possible to just say that, okay, I got this many, this is my accuracy, this is my recall, precision, specificity, sensitivity. It's not enough. What we need to do is we need to do some kind of clinical validations. So our clinical validation also had like 3 stages. So like in the first clinical validation, we found that, okay, the detection was COVID-19 was good, but there were around 30% error in the prediction of, like, there were 30% chest x-rays from the clinical validation data, which was predicted as coronavirus, like COVID-19, but were actually from bacterial pneumonia. So we were like concerned, like, why is this happening? Why this thing is happening? Like our model was performing good, but why there are so many false positives that we are getting? So now we took more data, we changed our architecture a bit, we added some more auxiliary outputs to our architecture. And at the end, we got around 84% accuracy for predicting whether, like, to remove the false positives. Like coronavirus was detected properly, but there were some issues with other classes like bacterial pneumonia or viral pneumonia or the normal stuff. So we tried to reduce the false positives in the next versions. And right now the clinical validations are going in like 3 hospitals in Korea, 2 hospitals in Singapore, Malaysia, and like 1 hospital in Indonesia, and 2 hospitals in Italy right now. So they are doing the clinical validation, and we got the feedback from the doctors that it was very fast. It was very fast, and the results were very much explainable. And so that is one thing that our company did for supporting the government or for supporting the citizens for finding out coronavirus. This is one of the projects that we did. And the second project was a Health Pass app for the personalized risk assessment of the citizens of Kuwait. So this was a project where a few companies came together, few universities came together, and few individuals came together to form a team which could lead, which could make some kind of application or some kind of system or some kind of protocol that can be useful for the eradication of coronavirus from the Kuwait. So it was kind of an initiative by the Kuwait government. So CV19 team was formed. So the team members in this team was the Kuwait government, the Gulf Medical Technologies, Imperial College London, which is like a very awesome university, honestly, the National Health Service London, Chai Analytics, and we, Terence. And the collaborative development of this complete health passport was initiated. And Terence and Chai Analytics were the people, we were the guys who were actually responsible for only the development of the epidemiology model and the personalized risk assessment model. So Health Pass app, so I think so like many, like everyone in India are using Arogya Setu or something. I guess so, that's the name of the app, Arogya Setu or something, where you need to use that app everywhere you want to go, something like that. So Health Pass app is a similar kind of app. So it is an app that you install in your phone, like Android or iPhone. And then what happened, wherever you go, you are being tracked. You are being tracked, not being tracked of like in a like a non like we are intruding into your privacy or something. It's not in that way. Like you are tracked of exposure of coronavirus. And there were like 4 color labels, like red, yellow, green, and blue. Blue are the people. So blue is a kind. In the first version, blue was there, but at the later point, we removed the blue version because the first study, which came out from the University of Cambridge, suggested that if a person had coronavirus, he can never get coronavirus again. That he has gained the immunity or something, but which was later like kind of people rejected that. The researchers from Imperial College, Stanford, and Harvard, they rejected this concept of that immunity thing. So later on, we removed this blue thing, and only red, yellow, and green were there in the app. Now, anywhere you go in Kuwait, movie halls, restaurants, you walk on the streets, someone might come to you and ask you like, hey, can I check your app? Like someone from the government or like maybe the police can ask you like, hey, can I check your app? So it was recommended to people that if you're having red, you should not go out. You should be in the hospital. If you're yellow, you should be going either to the testing center or should be home quarantining. And if you're green, you're okay. Now the colors were very dynamic, and they were, and we were able to change those colors twice, like 2 times in a day. We could change the colors. Like we were changing the risk assessment. Like we were doing the risk assessment twice a day for all the 80 million people of Kuwait. So now how we did this, that's the important part. So now the Kuwait is not a big country. It's a small country. It has like 6 governorates, yeah. And all those, and the whole country is divided into 138 different areas. So now what happened, every time, like in real time, we were getting information from the Ministry of Health's COVID database about which patient is getting affected. Like it was completely real time because their IT infrastructure is too good. So that's why like we were getting real time inputs from the government side. And also from the mobile application, we were getting the geolocation of each and every individual. Plus, we also included a Bluetooth tagging thing. I think so. Like honestly, this is kind of out of the box. Like previously, in like 2 years back or something, there was some kind of a dating app known as Happen, which used some same kind of feature. Like if you pass across some person, it will just ping that, hey, that person has happened. You have happened, so you can just go on a date. So that kind of technology was incorporated into that, which was known as Bluetooth tagging, so that we can understand if you came across a person who was having coronavirus and was later tested to be confirmed. Like let's say you go out, you don't know whether you have coronavirus or not. And let's say a person comes near you or talk to you, or you buy something from the shop and you spend like 2 to 3 minutes with that person. And after that, me, who was having coronavirus but didn't know, went to the doctor and said that, and got myself checked and was found out that I had coronavirus. Then the person who was with me and spent like 2 to 3 minutes with me, his color would change to yellow because he was under my exposure, which he didn't know about, and I also didn't know about. So in this way, we were doing such kind of tagging and understanding how each and every individual was exposed to coronavirus, and later each and every individual was able to keep himself secure and make his family or everyone secure, like kind of making them understand that, okay, your color is yellow, you should go there. Okay, your color is green, you can go out, or it's red, so you need to go to the hospital, and all those things. So this dynamic coloring thing and the use of this geolocation of each and every individual, followed with real-time database from the Ministry of Health, and the Bluetooth tagging technology helped the Kuwait government solve the problem. And now I suppose they are in double digits, right now in the coronavirus count. And so that's all what I wanted to discuss. And lastly, my final thought that which I include in each and every of my presentation by Ray Kurzweil is that our technology, our machines is a part of our humanity. We created them to extend ourselves, and that is what's unique about human beings. We created the technology, and now we should use the technology to save ourselves. That's the thing. Thanks a lot. Yeah, I'm done.
Here some questions are there from your juniors.
Yep.
I would like to take up those questions for you. Right?
Mm-hmm.
So one question is there from Tushar from 3rd year computer science. His question is, we have seen that sometimes different people have different symptoms, right?
Correct.
For COVID, right? So different people have different symptoms. So during COVID-19, so that would lead to misleading data survey.
What kind of data survey, if he can?
Means, would this affect the study that you are conducting?
For the chest X-rays or like for the mobile application? For the chest X-rays, there are some kind of like some people have the fibrolysis, some people don't have the fibrolysis, but some people have some other issues. So that's why our data. So the data we took, so that's a very interesting thing. The data that we considered was from South Korea, from Italy, from UK, and from the South Asian countries such as Malaysia, Singapore, and Indonesia, so that we can have a varied information. But obviously there could be some kind of false positives. And that's where clinical validation comes into the picture. So that we validate our software with a lot of individuals, and so that we get the best results, or we change our software a bit. Also, I didn't add it into my presentation, but right now we are also working with one of the very famous hospital in South Korea known as Suncheonjang Hospital, where we would be implementing wearable patches and radar technologies to understand about the people. So sometimes it happens that, okay, so I actually got to know about some individuals in India who were actually said that they didn't have coronavirus, but it was later found that they had coronavirus. So right at this point of time, we cannot be like 100% sure like what's going on, what's happening, but we can make some effort. So obviously, like to the person who asked me the question, to my junior, I would just say that it is not that we can be 100% sure that our study is perfect or what we are doing is 100% accurate. But what we can do, we can understand the quality of the data. We can understand the demographics of the data, from where we are collecting, what kind of data we are collecting, and then we can make a better product. So also there just a little thing I just want to add, that there again was a study that people from different race, like Asian race, European, like the European people, they get different kind of stuff happens in their chest when they get coronavirus. So it's not saying that if I take all the data of individuals from Europe and make it AI model, it can work with some people living in Korea or Japan. So that was also a kind of study that was found. So yeah, so that's why we need varied amount of data. Yep. Ma'am, next question.
Thank you, Sabyasachi. One more question is there.
Yeah.
Coming to that. Another one is from Indrayut Talukdar from 3rd year computer science only.
Okay.
He is asking, how would you modify your app if it has to be working for large population? Suppose our country like India, then where you getting the data will be a big challenge for you. So how
okay, ma'am. Yeah, I understand.
This
I understand his question.
Yes, one more is there, Rohan Sharma. He's also asking the same question.
Same question. So that's why in the beginning of my presentation, I said that it cannot be implemented in India because our SOP, so we actually tried, honestly, ma'am, we from Terence, like as I'm an Indian person sitting out there in the company, I actually tried to help the country I belong from. But the SOP in India, which is known as Standard Operational Procedure, is really different than other countries. So we are not real time. We have a huge mammoth population. We have 60 or 70%, I don't remember, penetration of digital services. So it is not something that's possible in India, but for tiny countries, it can be done. And where there is like around 90% penetration of digital services to individuals, it can be done. Yep. So for India, it's not possible.
Okay.
Yeah.
Okay, suppose for the whole country, it is not possible, but at a lower level, suppose district-wise, like that?
District-wise, madam,
low
we
volume
need,
of data.
yeah. So now we need to understand the cities right now. So the cities, like let's say we talk about Bhubaneswar, or we talk about Bangalore, or we talk about Hyderabad to be specific, then we can do it. But let's say we talk about some other places or district, which is like where the digital media has not penetrated enough, or the digital services has not penetrated enough, we can't implement such things out there. And also the government, and there would be a huge problem for the government, because that real-time thing is very difficult for the present IT infrastructure. It's very difficult. So that's why it's sometimes difficult. But for big cities and the cities where there is 90% penetration of digital services, I think so it can be implemented.
Okay, thank you. And some of your juniors are telling, yes, hello?
No, okay, ma'am, you continue.
They are telling, yes, sir. They are telling that yours one is the best one, and they would like to connect to you for future prospects. So how can you do that?
Okay, so, ma'am, I want to interrupt.
To hear from you.
I want to interrupt here. Means I am not able to control myself. Means we are feeling so honor. We are feeling so proud today that our students are the way they are giving the talk. That there was a day when we were working with them, we were teaching them. Means I am not able to stop myself, so I interrupted. Sorry to Bindu ma'am, but really it's a proud moment for us to listen to our students the way they are today giving the presentation. Means it's awesome. Means I have no words. Sabyasachi, great, you are great working.
2018
doing a great work. Yes, all the students who have given the presentations today.
All of them.
It's really. And Sabyasachi, our director sir, Samresh Mishra sir is there. I want you to just have an introduce him. Samresh sir.
Samresh sir.
Samresh sir is there.
Yes, sir is there. Sir is mute, sir, actually. So that's sir. Unmute.
It is unmuted. Sabyasachi Chakravarti. Hello. Really, it was a very nice talk. What we found, what Dr. Siddharth sir has said, that we are very happy. We feel very, very proud because the way you have presented, the way you have done the work, it is really wonderful. Wonderful. And many times I told to my students, see, there is always a scope to learn from the students. Fine. Correct. Because learning is not confined to books or only through experiments. So we learn from the peers groups. We learn from the students, which students are putting good questions. So there is a scope for the teacher to learn. So learning is not confined to anywhere, but it is open. Fine. So really, I congratulations to you, the way you did the work and the way you have presented. And I'm very happy that my students of our school must be motivated through your talk. And obviously, our alumni will help them because that is a strong bondage that we have. Fine. Always you feel, okay, this is the KIT. And what you said also rightly pointed out, it is not possible to some extent, I can say, to implement in India. It is not India. It does not mean that only the cities like Bhubaneswar, Delhi, Calcutta, okay, all the metropolitan cities. Major the people are staying in villages. Okay, and villages, there is a big challenge that the people don't have an internet connectivity. People don't have the smartphone. Are getting the point? So these are the problems. So it is a challenge, it is a problem given to we all that how to implement such type of technology in India. Clear? So Indian context is different. If you are preparing a Google car may work well in Europe, but again you have to find, can I run a Google car on an Indian road? Clear? that is a challenge. So that's also everywhere the problem definition there. So we have to think, we have to analyze. So That is the beauty that we all are getting the what good type of questions. Okay. Okay. Best wishes to you. I'm very happy.
Thank you, sir. Thanks a lot. Yeah.
Sir, I'm sorry to interrupt, but I'd like to inform Samresh sir, that he is one of the founding members of Data Science Group. And it was he who came to me and said, ma'am, we want to do something so that the mass of our school, which is going towards KSAC, should come again towards Campus 15. Something so that the KSEC run which is there could be avoided. And he was like in tears. I said, what happened? He said, ma'am, I want something intellectual to be happening in our campus. I said, okay, you tell me what's your plan. And this is what he has planned. And I'm really happy that he has come again and giving talk in this platform, in this data science conclave, which is hosted by the group he initiated.
Oh, that's I'm telling you, Dr. Manjusa. We are very fortunate because we have wonderful students. Fine.
Yes, sir.
Wonderful
Yes, sir. That's
people. Fine. That is the. I mean, we all are what I can say blessed by the God because we are getting so good people around us. That is the beauty. And another Sabyasachi, I today was planning also. I prepared one PPT which I would like to share with my authority. So what I am saying, the data analytics lab, like we have also planned another 8 different labs also in our school. So suppose data analytics lab, you write down the people. People means the faculty who are engaged in data science, the PhD students, the MTech students, the BTech students, fine, don't like to use the lab, plus the alumni, the list alumni. Dr. Manjusa, you can keep, the students who have contributed to the data science lab, our alumni working in different part of the globe.
Definitely, sir. I am
let them be members.
They are there, sir. So the
so
group
that list, yes, that list should be displayed in the laboratory, fine, so that it will also attract our students to do more work, and all will have to contribute. Clear?
Yes.
Thank you,
sir. So this group is because of all of them only, sir.
Yes, obviously.
They're the past students, the current students. It's because of them.
Okay, thank you.
Thank you, sir. Thank you, ma'am.
So thank you so much, Sabyasachi, for
thank you,
sharing with us this wonderful way of diagnosing your COVID-19 through your chest X-rays, where especially see your success rate is 85%. That is a big rate, right? So we are very happy to see this. Thank you.
Yeah, thank you, ma'am. Thanks a lot.
Thank you. For the participants, see, Google form will be given. Please fill up this Google form for your attendance for this session, Sabyasachi Chakrabarty's session. Please fill up the Google form for your attendance.
Thank you.
So now moving ahead, we'll be starting with our next session. So our next keynote speaker is Professor Manoj Kumar Das. So I would like to welcome Dr. Manoj Kumar Das, who is currently working as a professor at the IIIT Gwalior and Kalikote University, Berhampur. He is also a visiting faculty in IIM Indore, exam faculty in Lancaster University, UK. Professor Das has written more than 60 research papers in various journals of international and national repute. Apart from this, he has authored 5 research books in international repute. He was involved as chair member in International Conference of Arts and Science held at Harvard University, Boston, USA. So today he will guide us to understand the impact of COVID-19, COVID through Tableau. So now the stage is all yours, sir. Professor Manoj Kumar Das.
Is it visible?
Yes, sir.
Okay. First of all, thanks, Professor Siddharth sir, for giving opportunity. Since you are given a concept of Tableau, the Tableau is one data visual software. So what I am interested to explain about one of our research recently done the research about Ganjam district. Okay, so I will explain how through topic is called analyzing the prioritization of strategy, implementation of public health and social measure to prevent the transmission of COVID-19 disease in Ganjam district through AHP. AHP means analytical hierarchy process. It is one of the analytical tools we are applying to understand the prioritization of the strategy and through Tableau. So, so this research is based upon the two different tools. One is called visualization tool or Tableau to understand the nature, significance, and the concept of the data, of COVID data of global level, Indian level, and Odisha level, and Ganjam level. Since I am at present in Ganjam, and Ganjam is appraised by the WHO to properly monitorize, properly maintain the COVID situation within 3 months. So it ignites me to understand what exactly they've done. Okay, what priority strategy they've applied so that the COVID situation is minimized. So I will explain that is through two concepts. One is through AHP. AHP is a multi-criteria decision-making tool. We call it MCDM tool. MCDM means whenever we do analytics, there are two generally we are using, three techniques using. One is called multivariate, multi-criteria, and optimization. So the HP tools is based upon multi-criteria decision-making tools. In multi-criteria, there are two topics. One is called MADM, it is called multi-attribute decision-making tools. Another is called MODM, multi-object optimization decision-making tools. So here, HP is a MADM tools. I'm applying the HP tools to understand the strategy the Ganjam district administration applied to manage the COVID. And I will explain the data visualization tool, the Tableau. Tableau is only visualization tool. So I have not given more theoretical background because I've seen that from morning to evening, everybody know about when it arises, how it started. So I'll not give more focus on that. I will explain about my analytical approaches and the research approaches, what I did for Ganjam districts. This is the global situation as of now. Okay. Now see, in Ganjam district, in global level, it starts from this particular point of time, it increases. Now the situation is under control. But you take the average of this, you take another, this is quartile 1, this is, let be median. Okay, this is, let be Q3. Still, we have the COVID situation is already there. And the death rate also, it is increasing in last 10 days. This is data up to September 30. So the problem arises, and if this is our Indian case, so I collected the data through Tableau. So what I've seen that Maharashtra again still the pressure in the COVID, whereas Odisha in the situation is now in control situation, but Maharashtra is very difficult situation in the month of September. Okay, and regarding Odisha, it will be now, it is somehow it is a normal situation, but Maharashtra is again still in the danger situation. I hope most of the researchers already explained about this. So what I did, I have gone through the research literature available on this COVID technique. So I use the one technical tool, it's called bibliometric mapping through voice viewer. So there is a concept called bibliometric analysis. So first of all, when do any research, first thing you should understand what are the existing research already gone through this COVID analysis. For interesting, I have to explain. This is the called bibliometric mapping, where I've seen that most of the researchers are from USA, and India is now only the listed number. And most of the people are talking about COVID. Only small areas there where talk about pandemics and children. It means most of the people are talking about human intervention and COVID-19 disease. So I will explain this concept through bibliometric mapping through a voice web to understand what are the research areas going on. And most important country where the number of research work is coming out, China, then followed by USA. India is less in number, so India is not in the prominent country where they did the COVID research. And most of the research I talk about was the human intervention. But there is a social campaigning research are less in number, and the bureaucratic approach in the managing strategy are very less in number. So that ignites me to understand how the Ganjam district administration or the district administration of all the district of Odisha will apply the strategy to manage the COVID situations. And if you see, this is a bibliometric mapping. We have seen that most of research are talking about the coronavirus, non-human virus, human virus, infinite, but the management approach and bureaucratic approach are less work in number. So that ignites me to undergo the research that yes, what are the strategy that district administration of Odisha applied to manage the COVID through HP. So this is our Ganjam district at present. Okay. This is the population. number of literates and female. But the question is, this is not our objective. My objective is totally different. When I seen that there is a news that Ganjam Jilla ko Marila Corona, it means the Corona started in Ganjam district. That is the ignites me to that day I know the in the media and today with the media. So within 4 months, the total situation of Ganjam district totally changed. Now I will explain how it changed. Now this is when it started in COVID in Ganjam district. Now see, this is the data. I will analyze the Tableau, the dashboard. What is the common? There is 232,713 people are confirmed case in Odisha, whereas 33,000, and it means 3.56 of percentage of Indian cases. It means 3.56 COVID cases of Odisha are from India, whereas this is also this case is called. Is it visible? Is it visible now? Hello.
Yes, sir, it is visible.
Okay. This is confirmed case. This is recovered case, and this is active case. Still, we are having 9,41,000 active cases are there. Now, if you see the data, it started from August to 4th October. We have seen that it is increasing. It means confirmed case is also increasing, and recovered case is also increasing, and active case is under control. Under control. Now the question arises: what strategy the management, the district administration applied to the control? Now see the situation. In 16 April 2020, the first case started in Odisha, that is in Khorda district. Now after 1 month, what I've seen, 18th April, within 1 month, 62 cases are generated, whereas Khorda is leading one, then Bhadra, still Ganjam is not here. Now after 1 month, 18th May 2020, now it increased from 62 to 978. It means 900 cases increasing within 1 month, where Ganjam is the leading. The question arises, what thing happened? What has happened that directly it is increasing 900 cases, and so that Ganjam, which is not in this situation, is highest in number. If then after 1 month, again what I've seen, it in 18th June, again the 970 is the 5 times increasing. That is 4,775, where Ganjam again the leading one from 27 cases. Whereas Khorda is the second one, Kato is the third one, Jaspur is the fourth one. Still, so it means from 18th to May, this 307 to 827 is triple now, 3 times. Now again, when I see 1 month again, August, now it will be 15,000. It is 15,000, followed by Khorda, then Kato. After 17th September, now Ganjam is second place, and Khorda is now changes. Now question arises, what happened when it is 13th September, Ganjam the third places. It means 20,000 active cases, and now only active is 1,471. Out of 20,000 cases, only 1,471 are the active cases. So now the question arises, what are the factor, what are the strategy the district administration applied so that it is controllable? That ignites me to understand. And if you see the total coronavirus effect, more affected of a male than the female. And if you see the number of cases also, I have seen that. Now see, these are the negative results, which is increasing divide, and these are the positive results. It is declining. Now from last 2 days, it is increasing. Now the question is, most of the people who are coming from Ganjam are from Gujarat. Means the COVID arises in the Ganjam district because of Gujarat, followed by Telangana, then Tamil Nadu. These are the majority of the Ganjam residents are working in this state: Ganjam, Telangana, Tamil Nadu, Karnataka, Kerala, and most of the people are from Gujarat. So when the people are coming from Surat, that time the Ganjam COVID increases from 307. It means in the month of 1st May, the first there are 2,000 Ganjam residents coming from the Surat, by which when they tested the COVID, then we got 307. Now, what is the important thing is that if you see the Ganjam district, for example, let's see about this. If you see the Baleswar district, the most are from Maharashtra, then coming from the West Bengal. Bhadrak, most of people are coming from Tamil Nadu. In Cuttack, most people are from the West Bengal, and Ganjam, most people are from the most people are from the Gujarat. So Tamil Nadu and Gujarat. So that ignites me whether the people, if the COVID is increases within the district because of the migrants or migrant laborers, or it is because of the SMD. So that ignites me. So let me explain about, I use that topic called HP. The HP topic developed by Professor Sethi for analytic purposes, Sethi approaches. He developed 9-point scale. It means, first of all, let me explain about this. This is also applied for decision-making system. So why I am applying HP? Let me explain. I want to know what strategy the district administration applied so that it is controllable, and what is the first strategy they applied. Within the strategy, what sub-strategy they have applied. That is my area of research to understand the decision-making tool of the district administration by which the Ganjam district has been fully controllable. So this concept developed by Thomas Sethi, and it is also solved to complex making problem. This concept is developed by from last 20 countries, and most of the, if you see in the recent work, HP, most of the researchers working on HP, fuzzy HP, demetal and fuzzy demetal to understand the prioritization of the strategy and the cause and effect strategy. And we have a software called Expert Choice where you have to calculate, implemented or estimated the HP tools, the strategy. So there is in HP tool we are using 9-point scale. So what happened? We have find out the factor first. Hello.
Yes, sir.
Okay. First we find out factor first, and we are using the 9-point Sethi scale where 1 is equally important, 3 is moderately important, 5 is strongly important, 7 is very strongly important, and 9 is extremely more important. So this is the estimate procedure I have taken. First, what I did, the first step of HP is to select expert. So I selected 20 experts for my research. Experts are doctors. 4 doctors I have selected. Then experts have selected the district administrator, 4. Then experts have selected the researcher who are working on this area. Then 4 teachers who are directly the COVID areas, and 4 the police persons, and 4 the COVID patients. So it means I have in my expert group, I have selected 20 experts. So the first step is select your expert. So I have explained who is my stakeholder: doctor, then district administrator, COVID warriors, COVID patients, police force, and the researcher who are working in this area. The second thing, once I got the information, what I did, then what based on the information, I have to go for the weight comparison matrix by 1.9 scale. Then I have checked the consistency. Consistency means when I compare between A, B, and C variable, if B is greater than A, and if C is greater than B, it means what happened? The C is greater than B, greater than A. That should be maintained throughout the data. So I have checked the consistency by applying certain methods, and that consistency score is called less than 0.1. The CR value, the consistency ratio is less than 0.1. Then I can use for data for further analysis. So this is my methodology I'm applying for HP. These are the decision maker data. Then I calculate the weighted matrix. Then on the weighted matrix, then when you multiply weighted matrix with the synthesis matrix, I got the priority vector. These are the weights for the different strategy. Once I got the weight, then I have to check whether the weights are consistent or not. I calculate the CR value. CR means consistency ratio, which is equal to conditional index upon random index. If this value is less than 0.01, less than 0.01, then I can check that the weightage what we collected are consistent and going to be applicable and for decision making. So these are the different factors I have selected from different research paper. So how I selected this factor? I've used 3 methodology. One is called expert opinion, another is called through review literature, and third is called focus group. Based upon the discussion, these are the different parameters I have selected: role of public governance, role of street level bureaucrats, complexity of policy, resource availability, lack of medical investment, healthcare, lack of plan in healthcare programs. These are the different factors and sub-factors I've identified for my research work. So when I applied the HP tools, I'm not explaining about the estimation procedure because I have only limited time, but my focus is to analyze what strategy they applied. So there are only 8 strategies generally the Ganjam district applied for the management of the COVID. What are they? They are behavioral approach of the citizen, how to manage the behavior, how to motivate the citizen. Second, healthcare infrastructure. bureaucratic approach, mobilization of resources, public governance, healthcare delivery system, feedback mechanism, and policy perspective. So when I compare between all these 8 parameters among the decision makers, what I found that most of says that this is the number 1. Means first thing is that they have a clear-cut policy how to manage the COVID. They have 5 clear-cut policy, that is called social distancing, creating awareness, then monitoring, testing, and another is called the creating the different ICH, healthcare centers. So they have 5-point agenda where they can control the whole COVID situation in Ganjam district. So the 36.8% of the weightage is given to police perspective based upon 20 experts. Okay. What the second strategy they have applied? The second strategy, what we found, is called bureaucratic approach. It means all the bureaucratic, for example, our district administrator, collector, they have a good team in his district administration where all the team members are highly motivated. They worked under the plan. And this is the second priority. What we found that the first is there should be clear-cut policy. Second, that there is involvement of the bureaucratic approach by which the COVID situation is very controlled. And third parameter, what I found is called infrastructure. Whenever they required, whether it is the ICH or healthcare center or it is ambulance or the medicines or testing, they're totally available to all citizens of the Ganjam district. So the third priority strategy they have applied is called healthcare infrastructure. It means according to the requirement, they have provided all those facilities to the citizens of the country. Then fourth one is your resource mobilization, and the least important is called the behavior approach. But what is the first 3 strategies they have applied to manage the COVID? What I concluded from the research? Yes, it is policy perspective. Second, bureaucratic approach. Third, infrastructure. These 3 are the primary strategy that Ganjam district applied to manage the COVID. The second level is they go for resource mobilization, they go for public governance issue, and they have having good feedback mechanism. It means every citizen have right to give the health center whether they have, if there is anything happened. For example, Ganjam district is given the order to all the medicine shop. Is there any patient is coming who says that there is a fever, there is a vomiting, then kindly inform to that district administration. So due to the very good feedback mechanism, the situation is totally controlled. So the first priority, there is a clear-cut policy. Second, the involvement of bureaucracy is totally positive. Third, the healthcare infrastructure. Fourth, resources. These are the 4 primary steps. Second step is they go for the public governance system, healthcare delivery, and the feedback mechanism. The least important is called that they don't have control over the behavior, because we know there are many YouTube videos or many videos you have seen that where the people are creating the fun within the center. So what they did, they have to motivate these people. They have to give the motivation talk also. Now they arrange in such a beautifully so that the behavior of the citizen totally change from negative to positive. The second thing, what I want to know, then the first is behavioral approach. Within behavioral approach, what I found, the most important part is called the behavior doctor. Second priority is that is 51.1% of weightage is given to the doctor. It means it is because of doctor in Ganjam district by which that totally situation is under control. Then we found that the COVID warriors. Third, we found that the behavior relative to our COVID patient. Fourth, we found that society behavior towards the patient. And fifth is called behavior of the COVID patient towards the government. So what we found that since the fifth parameter is the COVID patient, so what is saying that it is also a positive phenomenon. But most important thing, what I found, yes, is a 3 important beautiful point, which is called doctor behavior is highly positive. Second, COVID warriors also behavior is totally positive. And third, the relatives behavior of the patient is positive, by which the situation is totally controlled. Second, when I go for the infrastructure, what I found through HP, to find that the self-healthcare center is totally 45.8%. Is highly given the more priorities by the decision maker that yes, because of self-healthcare center provided by Ganjam district administration, situation is under control, followed by PP kit, then medicine and drugs, and least important is called number of COVID. So number of COVID centers does not play more significant role. It is only the self-healthcare center, PP kit providing, and the medicine and drug provided as per the requirement by which that situation is controllable. Then when I go for mobilization resources, what I found that it is the create awareness. The Ganjam district, last 5 months, totally devoted to create their own Facebook page. They have Twitter page. They have helpline center. They are having the different teachers who are directly interacted the public. So it means they create good awareness among the citizens of the Ganjam district, by which within this resource mobilization, the situation is controlled, followed by dissemination of information. Any information they are having, they directly disseminate to the public through the district, the collector. Every day, every 3 to 4 days, he given the interview through YouTube. It means whether it's media or social media, he always try to active, so by which the situation is under control. Third one is called managing superiority and fear. And fourth is very important, that is called standing operating procedure and involvement and participation are the fourth equal important applied by the Ganjam district, where the situation is under control. Dear participant, this result, this information is based upon the Ganjam district. I am not asking about Odisha. Because I'm interested to know why Ganjam district administration, what are the steps they have applied, and so based upon 20 decision maker informations, I applying the HB, I got this beautiful result. Then while I approach research approaches, what I found, the most important part is called investment for COVID patient. It means Ganjam district judicially utilized the fund. There is no message, there is no news about mismanagement of the fund. So whatever the fund they got, they purely invested for COVID patient, by which situation is under control. Second parameter is called, there is a healthcare budget. There is a planned healthcare budget of the Ganjam district administration, by which they have control. Third one is called sufficient testing equipment is given to the center. Fourth is called sufficient transportation. Then the least important is called investment for rehabilitation center. So the main focus was, they have a good healthcare, but there is a planned healthcare budget, and there is a proper investment of COVID patient, by which situation is under control. While analyzing the management approach, governance approach, what I found that it is efficient healthcare delivery system. We are having ICT, the district administration applied the ICT application. That is means the first important priority is 13.3% is called efficient healthcare delivery system. Due to this, the situation of Ganjam district is highly controllable, followed by the governance in the system, because nobody is complain to their superior. Nobody is taken. Nobody is taken. I have also discussed with some of the district administrator. Is there any governance issue? I found that 99% of the they said no. But that is my hypothesis. Till now, I'm not accepted. I'm again going to analyze the demetal analysis and fuzzy demetal analysis to understand the cause and effect about this result. But yes, what interesting I found, the healthcare delivery system is the one. Second is governance within the system, and third is called e-governance and EM governance. Now, if the district administrator collector is applied the E and in mobile governance and internet governance, then every participant, everybody has a full freedom to give the opinion to the directly to the collector, or every citizen also give the information, their information to the directly to the collector. So, for example, there is one my friend, he's going to he's interested, plan to visit to the Gwalior, then what happened, directly approach the collector, and he given the permission. That direct approaches, the governance issue is already available in Ganjam district, by which situation is under control. So there is no fear in the minds of the citizens. When I talk about healthcare delivery, what I found, again I found that medical investment is totally proper. Second, the contract testing is done perfectly, where 22.3% of the weightage is given by the expert for contract tracing, and the least important is called number of hospitals. So it means number of hospitals does not give any important role. What is the most important role? What I've seen? Investment. They have full investment on the patients. Second, when you talk about the feedback system, it's very interesting parameter I have to explain. There is called post-discharge monitoring. Whenever any person is discharged, they have a feedback mechanism, and I have seen that feedback mechanism, 95% of the patients are satisfied and happy with the district administration and their facilities. I mean, 43.7% of the priority is given to the discharge. Second one, they give the feedback from COVID patient, and fifth one is called actionable feedback. Since it is already in the question mark, what are the feedbacks given by the patients? Still, all are not actionable. Some are actionable, So I'm interested to know do the content analysis for that. What are the positive feedback what they have already actionable, and what are the negative feedback given by the patient, which can be controllable or can be do further. When I go for delivery system, what I found that these are the 7 strategies that the Ganjam district or everybody is operated. That is called lockdown, shutdown, conditional lockdown, circle, sub-safety, 6 feet distance, sanitization, SOP. What I found that this is the only one thing everybody says that it is called 6 feet distance. Social distance play very important role to manage the COVID. Second was called lockdown, is also impacted. Third is called sanitization. Sanitization is not the most important parameter, rather than it is the third priority factor. Fourth one is called shutdown, and the least important is called the conditional. But conditional means some village panchayat they did the shutdown when there is a patient level COVID patient increases from more than 50. So they have targeted if it is increased 50, they go for the shutdown approaches with that particular local area. So what is my interesting found? It is 6 feet distance, which give more priorities by which the COVID-19 is controllable in Ganjam district. So in concluding remark, what I said that still the lot of work to be do. We have to create awareness about social cause. We have to develop a trust among the people. We have to utilize the research properly. We should give this more speedy promotion of our initiatives. There should be social initiatives should be clearly effectively carried out, and more important is that there should be coverage of the dissemination information. The last one is called word of mouth communication. This is the strategy I am suggesting to the district administration, and still the 5 guiding principles we have to suggest: listen, acknowledge, keep posting, be empathetic, provide organic value, and ask for help. Thank you very much.
Thank you, sir.
So this is totally based upon the last 10 days I did research. So I'm explaining the output. Still my paper is working, or this is working paper now. I'm going to submit on the journal. So just I have to explain how the Ganjam district controlled their pandemics, COVID pandemics within last 1 month. That situation I have to explain through HP. Okay. Any question from your side?
Yes, sir.
Regarding methodology or tools, technique, Tableau, you can ask any questions related to analytics.
Sir, there is one question from student Indrayut Talukdar. He wants to know, sir, the graduation values always, whether it will be always constant or they can be adjusted with the problems hierarchy.
Repeat the question, please.
The gradation values.
Okay.
The gradation values will be whether they will be always constant or they can be adjusted with the problems hierarchy.
Listen, it is adjusted within the problem because it cannot be increased. It is adjusted based on the situation, based on the problem.
Yes,
okay.
Sir.
So basically, the Siddharth sir given me topic on Tableau. So since 13 minutes, if you go for the Tableau analysis, it is very difficult to understand the situation demonstration. So what I did, I applied the ASP Tableau both in my data set and explained the real research so that the students can understand, yes, they can also carry out such type of research, analytical research. This is the preliminary level I'm explaining because it is an under preparation. So I'm not explaining all the result to the general public.
Yes, sir. Thank you. Sir, one more question is there from Kosani Sakar.
Okay.
How far can we rely on ASP for analyzing the spread of COVID-19 in India?
Okay.
And what are the major limitations of ASP?
Okay. Now see, there are different
limitations of ASP.
Okay, I understood. There are different types of AHP. AHP depends upon the pair-wise matrix or comparison matrix, or it is work of validation. So if a data is CRIS means if the decision maker know whether it is strongly agree, or if you know 1, 2, 3, 4, 5, exactly can carry it out, directly apply HP. But sometimes what happens, the management is a very complex in nature, they're fuzzy in nature. They don't know whether it's strongly agree or agree. They cannot distinguish between the two parameters. So for that case, we are applying the fuzzy HP. So fuzzy HP is the more appropriate than the HP. We are also having that is two value fuzzy, and then another is called the two-digit fuzzy also. and also called BWM for G. BWM means best worst method for G. It means for every strategy, we calculate the best value and worst value based on centroid. We use that scale for periodization. So HP is the preliminary one. Then you go for fuzzy HP. Then you go for two value 2D HP. Then you go for BWM AHP. So it means the decision maker is clear and concept. If he can distinguish between the agree or disagreement or strong, then only can go for AHP. But sometimes all the management problems are not crisp; they are in complex. They are in fuzzy. So we go for fuzzy HP. So fuzzy HP will be more private. So I'm working on fuzzy HP also to check what are the prioritization I'm getting from HP, which is same in fuzzy HP. If it is same, then I can say that the decision maker are consistent, and we can this strategy you can give to the other state also. But if the fuzzy HP, you see that there is difference of the prioritization, then I will think about what best strategy can be applied. But yes, you are right. Fuzzy HP is the more valuable than the HP.
Thank you, sir. Sir, one more is.
Yeah.
Sir, one more question is there. Suppose here we are applying this methodology for Ganjam district.
Yeah.
If we apply the same technique for a big city with huge population, then will affect the model, or
First of all, when this is called expert opinion method. So when you go for expert opinion method, it does not depend upon the number of customer on our huge database. It required your expert. Ideally, the maximum size you should take 50, and that 50 divided into different cluster. It means you take some professor, you take some doctor, you take some warriors, so who are directly involved in the problem. So identify two or three of each stakeholder. Then you prepare a HP questionnaire and ask them. Then once you got 50 matrices, then you calculate the average matrix of that. And that average matrix is for the input for your HP. So it means here will not, like your multivariate, will not require to collect information from COVID patient. Better you collect the information from expert. So this is also called expert opinion methods. So you can apply, you can take my variable, you can apply, you can select your expert, and you can go the HP. 95% you see that there is similarities. Because if this strategy, they can control the situation in Ganjam, I hope this, if the other state, if you compare the best district also, you find a similar result.
Thank you, sir. So thank you so much, sir, for all the insights that you have given, especially the way the situation is controlled in the Ganjam district. Thank you, sir.
Thank you.
Thanks a lot, Manoj, sir. Thanks a lot for coming.
Thank you.
Thanks.
So next, we are going to have a 10 minutes break. Then next, again, we'll start at 5:35 again. Thank you. Thank you.
Before going to the break, just Lipika ma'am, please tell about the speaker and the topic he will be giving, because it is a very interesting topic. So let students know what the topic will be there, and we'll be going for the break.
Sir, one more announcement for the students, for the participants. Please fill up the Google form for your attendance. Thank you. Next to Lipika ma'am. Over to you, ma'am.
Yes. Thank you so much, Bindu ma'am. Thank you, Siddharth sir. So I would like to request all the audience, all my friends, dear colleagues, and dear students to join back after 10 minutes. It's around 5:35. We are going to restart our last slot, and it's a very good eminent speaker is going to deliver the talk. So I request you all to join, because the talk delivered by him, Dr. Kunal Mankudia, his topic will be an escalating journey to fill COVID-19 needs in the Northeast US. So it will be very exciting one. It will be very enrichful information, and that will help you. So kindly join after 10 minutes break. Thank you all.
Thank you, ma'am.
Abhishek, be ready. Yeah.
Yeah, so Lipika madam, Professor Kunal is there, so we can start, I think, the session. Hi Harsh, how are you?
Yes, sir.
Yeah, hello, sir. Actually, I was unable to unmute it. Really happy to be here, sir. Thank you. Thank you.
Good. Professor Kunal, I have given the sharing option to you, so you can share your slides. Yeah.
Excellent. Can you see my slides?
Yes.
Yes.
Perfect.
Sir, before that.
Yeah, Lipika ma'am, you can start.
Yes, sir.
You can introduce.
Okay, sir. Can you make me, sir, host? All right, sir. So welcome back once again to the Digital Data Science Conclave 2020, organized by a wonderful team, DSG Data Science Group of our School of Computer Engineering, KIT University. So all we know that today is 4th October, right? So by the world calendar, today is nothing but the World Smile Day. So let us bear smile and keep smiling to the last lot of entire session today. I am Lipika Devangan, an assistant professor of School of Computer Engineering, KIT deemed to be University. I'm feeling honored and privileged to be a part of this successful workshop and the data science group team. So ladies and gentlemen, friends and colleagues, boys and girls, my dear friends, students, audience, it will be very thrilling to announce that we are going to listen a talk by a very eminent speaker who is the outstanding, multi-talented, versatile, and resource person who is none other than Dr. Kunal Mankodia. So let me tell something about him. He is right now an associate professor at Department of Electrical, Computer, and Biomedical Engineering, Kingston, Rhode, USA. He is also the director of Wearable Biosensing Lab, University of Rhode, USA. He pursued his postdoctoral research at Intel Science and Technology Center, that is ISTC, affiliated with Kenneth Mellon University, Pittsburgh, USA. He has received his PhD degree from the University of Lübeck, Germany. And I'm very excited to announce that he is also a recipient of NSF 2016 CRII and NSF 2017 Career Awards. He has also received his PhD degree from the University of Lübeck, Germany. Already I have told. It's very enlightening news that to hear that he has also received Take Connect Defense Innovation Award in 2018. So, Sir Kunal, sir, your list of reward and appreciation is really many more. And due to shortage of time, I'm just quickly reducing it. His research interests are wearable sensors, medical Internet of Things, smart textiles, body sensor network, medical cyber physical system, and last but not the least, neural engineering. Dr. Mankodia was also selected among 40 under 40, 40 under 40 by Providence Business News in 2017. His embedded computing design of a smart textile ECG system earned him in 2006 SysTex Award. My dear audience, it's SysTex Award sir has received from the University of Ghent, Belgium. So thank you so much, sir. He is going to deliver a title of the talk is Rapid Solvers, an escalating journey to fill COVID-19 needs in the Northeast US. Sir, I hope you will enjoy our interactive session. So now the stage is completely yours. It's the virtual stage. So let us listen to you, sir. Thank you so much.
Wonderful. Can you hear me all right?
Yes, sir, you are completely audible.
Excellent, excellent. Thank you. Thank you, Dr. Lipika. I really appreciate a generous introduction. As well as I would like to thank KIIT for inviting me for such an amazing platform, and we all need to touch base together in this pandemic time. So I'm excited to be here in one sense, and also would like to share some of my learnings in recent time. This talk is going to be a little bit different than what probably you have seen this entire day, because I'm not going to talk majorly about the computer science or data science side of that, but I will be talking about some different journey. And I hope that like it is a end of the day for you, and you might be tired. So take this presentation as a little bit of entertaining on one side, as well as the lesson learned, and I would like to talk about that. So, like Dr. Lipika said, my journey is kind of going from Asia to Europe to Northeast, Northern America. And unfortunately, the COVID has hit all these continents heavily. And because of my connections in all these three continents, I kind of have experience looking through that details with direct and indirect context over there. A little bit about myself. I direct the wearable biosensing lab. At the same time, I am wearing different hats at the University of Rhode Island. But majority of my work goes into the research with the wearable biosensing lab. And just one slide only about my research. I majorly do research in wearable systems and brain monitoring systems, creating technologies for smart textiles, brain monitoring systems. We also use off-the-shelf wearables for getting data from that and making symptomatic inferences. Also, we design our own wearables using 3D printing and as well as smart textiles. We design prosthetics out of 3D printing technologies. So, a lot of research ongoing right now in the lab. Let's come to the important topic. It's a COVID, right? It's a COVID-19. The world has changed. We are currently going through this extremely challenging time all across the world. And I'm just going to show you a little bit of data from September. And by the way, these are not the recent data. I wish I could find this data from yesterday, but I think, data is not better than this. It is actually worse than this. Number of, infection rate is higher than what this picture is showing us. And US and India and Brazil, these three countries are kind of on a top pandemic affected countries. Now let me tell you a bit about taking back all of us to the if you look at the date, it is March 1st, and if you look at this pandemic in Italy at that time, it was an alarming rate. And we all were kind of, noticing it very carefully that what's happening in Italy. So you can see that actually after first week of Italy, in the pandemic in Italy, it's just rapidly started. And you can see that the death rate was high as well as the infection rate over there. And this was kind of, and the beginning of the spread of virus outside of China at that time. And so let me tell you a bit about the what was happening in Italy at that time. So, you can see that at the time, if you look at the news and if we were following those news, we were seeing that they had a ventilator crisis. They were having they were using 3D printing technology for supplies that they would need for the ventilators. They also, this is the wide spreader, they need to use it for if you have more than one patient to be served with one ventilator, then they need this kind of supplies. And they were and any country would be this kind of supplies because nobody was prepared for this. And the face masks, right? So of course, we never thought that we would be needing N95 kind of face mask, and for a amount of this mask we require is really high. And of course, this masks, we can't use it sustainably. You have to keep changing those masks every few days. So that's another thing, that these supplies are not sustainable supplies. You have to keep replacing them. So, and then in US at the time, we were closely observing us as well, because the thing is that from the middle of March, and you can see that by end of March, US started to pick up the spread. And if you look at the end of March to beginning of April, the rate was exponentially increasing. And at that time, like, if we were looking at the number of people infected, we are just looking at in thousands, but now we know that we are already looking them in millions. So that's a huge rate of infection. So what we were doing in at that time when we were looking at Italy, and we were anticipating that this is going to happen here in US as well. So number of faculty, including myself, we sat together on a Zoom kind of platform, and we were talking to one another that as academic people, what we should be doing at this time. One side you have taken everything online, virtual, your research and everything, including teaching. But now at the same time, because we have resources, we have exciting, energetic students, can we do something together, right? So idea was that can we start working on something which would be important at this time, right? So what we did at that time is that I felt a need of all of us to be on the same platform. So it's not only us, because we also were in touch with a number of people that they were thinking the same thing, that they wanted to do something that can be helpful in the local community, and particularly healthcare community to start with, because more and more infection rate, that means more admissions into the ICU and healthcare workers and the hospitals would be kind of treating those patients, and of course we don't want those people who are serving them, like healthcare workers, to be infected, because if they do infect, then we all know that what happens. The problem is then you are actually choking the system. So it is not a sustainable way to survive. So we thought that we all need to work together. So we created this we call it the rapid solvers. Main reason is that we wanted to solve certain problems in a rapid rate. So we kind of call it in that way at that time. So in March 26, I still remember vividly that we started this. I don't know, we still call it initiative, but it turned out to be something very close to a small startup or a non-profit organization. So we actually within a few days, we actually turned out to be an 80+ members organization out of that few people's meeting. And we had a number of companies, non-profits, hospitals, universities. We used to come together on online platform. We used to meet like twice a week. We brainstorm designs and clinical validity of and viability of the kind of these PPEs which we need to develop. And also we needed to identify needs and plan to fabricate them, right? Because at that time, no company would be ready to start fabricating, and we needed to create that, to supply that to the healthcare workers and essential workers. And we were meeting almost to not just check the progress, but also how we can also work out the logistics and production challenges. So this went on for like our active period was from April to June. Of course, we are still kind of communicating at some point, but not as much as we used to do at that time. So for those 3 months, we were very, very active. And so we had a lot of options that what we can actually do. So we at that time identify that we only wanted to focus on two kind of productions and designs, which is a face shields and face masks. And there was a reason, because those were the thing which is short in supply, and also they can infect. If you don't wear them, it can infect healthcare workers. So we thought that and we had a lot of conversation with the hospitals around, and then we were talking about whether what should be our first priority, because face masks are difficult to do, difficult to print with 3D printers. because it would be really uncomfortable, and also we need to have still certain materials for having the N95 kind of filters embedded within those masks. So we kind of thought that we will start with face shields first. So here are the some photographs of the initial face shields we created, and again I'm talking about the really early April, when COVID kind of really hit us over here. And I know that this kind of face shields now everywhere, these files are available, and you can kind of go to 3D printers and print it easily. And there are a lot of instructables out there that you can develop such kind of thing. And by the way, a number of people who had no idea of the 3D printers, they started to develop through the 3D printers. And from the data point of view, a lot of files were around, online. People were sharing, which was an amazing community work that the entire world was doing, that they were sharing with one another the what files they have. And then we kind of, cherry pick the files or designs that we felt that it was the most comfortable for long-term use, and you can wear for hours and you still feel more comfortable with that. So we kind of did a lot of, I would say, user studies at that time, and we also asked the users whom we were delivering these items, and then we got feedback from them, and we kind of we had the designs we felt that those were the most comfortable ones. 3D printer, I think nothing new in today's world now what 3D printing technology is, but it definitely has an edge when it comes to the rapid prototyping, and it does require a lot of management of the files and everything, and design. So you need to create a kind of infrastructure to share the files and make changes on that. So that's where I think computer science and computer engineering can be extremely useful, and we did feel that it was a very important aspect. By the way, these are our face shields that we were delivering. This is the the receiver part, the South Kingstown Emergency Medical Services, they received it, and not only that, this is just an example, but and if you ask them that what did you feel, they said that we had nothing in our hand. And at this time that our group came up with the free face shields to them, and they were feeling so blessed. I'm going to play a short video, and this video actually talks about the how the face shields were created. I'm going to skip few items in that.
Always be to make the best out of the situation. And I think that I can provide some value and some protection for the people that actually protect us from the virus. I don't have the skills to actually help the people, but I maybe can produce something that protects the people who can help. So I thought that's a good thing, and that's worth committing to.
I believe we had 150 the first batch, and I'm back for another 100 today. The nursing homes have over 50 cases, so that's considered a hot zone. So we have to make sure that everybody is in a hazmat suit and fully covered whenever they go into the hot zone. A lot of places that are having a very difficult time getting supplies right now. Tremendous help.
First layer is a critical layer, and we have to make sure that this is running smoothly, and then we only have to monitor it. But you have to be here a long time to make sure that the printers are running, because otherwise we have a lot of waste of production time and waste of filament, which is quite expensive. Try to stay here until 7 p.m. in the evening, have my dinner, and then come back at 9 to stay here until 11 to watch for the printers, and restart them again at 11 so that they run 24/7. Try to be here 12 or 13 hours a day. We will produce about 200 a day now. We produce about 1,500. We are getting more and more demand for it. I had an administrator who came to pick up 600 face shields for nursing homes, and she was so thankful, and I think she said thank you 15 times in 10 seconds, so that was amazing. She's so thankful because we produce something that can protect their staff.
One second. trying to exit over here.
So press escape, sir. Yes.
Okay. Yeah. So what we have is that I'm just going to tell you pretty quickly that we had almost like orders coming in, and then we were delivering those things. It looks odd for the academic institutions to do something like this, but we felt that there was a need of doing it at that time, and we had resources. We had created actually a 3D printing farms. Essentially, we call it farms because we gathered all the 3D printers from the different labs into one large room. So a limited number of people can go inside and they can maintain the production of these 3D printed face shields. And that worked out really well with the 3D printing farm concept, what we thought would be useful. And at that time, it was not just 3D printing, right? We had to create an entire ecosystem, kind of, going from organizational inquiry to order. For example, the student mentioned that they delivered 600 face shields to a nursing home. Now that order need to come through somewhere. We need to know where the needs are. So, and then 3D printing, then assembly and delivery, and everything had a different kind of people. And again, we needed to do a social distancing. At that time, when we were new to social distancing, we never heard of something like that. And still we were kind of, trying that. And how to kind of scale up the production. So those things were happening with the different kind of 3D printers. And we also were given a 3D printers. We created our website where we kind of send this, people can request their PPEs over there. And then we immediately take that into production. We also had our funding site and, frontline responders, kind of, we were supporting them. So we wanted that fund to coming in. Then we kind of also had in a parallel development on the face mask. And the face mask was, and I would say it is still today, is in a difficult area to kind of develop with the 3D printing technology. We actually investigated number of face masks out there with their designs. You can see this is Rowan mask. We felt that there was one of the closest one which we can do. And there were a number of people we were working with for doing something different kind of test with that, right? So it is not just 3D printing technology, but you also have that the material that goes into the breathing window. And for that, you need to do the Bitrex test, quantitative test, whether you can do qualitative testing, if you can do it, N95 equivalent materials, can you find it, all this kind of thing. So Dr. Manbir Sodi from industrial engineering and his student actually create a face mask from the biodegradable indigenous material. Essentially, you can, after using it, you can just throw it and it would be sustainable because they are made of the kind of, cellulose materials. And Dr. Sodi is actually very, very motivated to send this kind of mask in India, and he is currently working in some groups in New Delhi right now, and he is almost converting his current development into a small startup kind of the initiative. And this is what I would call it, a byproduct of what we have done together, and that worked out really well. Also, there was a very interesting experiments were done. Academia, you'd like to do experiments, and it was the right time to do certain experiments. For example, we created a system that was designed out of the smoke detector. So you have two chambers. One is a smoke chamber where you have an incense smoke, and then you have another chamber, and you have a kind of a mask filter that passes through the certain particles, and then you have the smoke detector which would detect the smoke particles, and you have a pump, air pump inflator over here. Then you have one-way valve. So as you pump the this pump, essentially you expect that the smoke particles would enter into this smoke chamber, the smoke detector chamber, and then you like to see how many puffs it takes for the material to kind of sustain. So if you see N95 had sustained 300 puffs. So when you do 300 puffs, you would see the smoke particles coming in, and smoke particles are, I would say, a little bit larger than the N95, than the COVID-19. Then you have other kind of, paper towel, surgical mask only survived 8 puffs, cloth mask only 7 puffs. Then HEPA filter was really good at that time. Those experiment like 350 puffs, and that's why I think HEPA filter is very much useful in the air conditioning today. Yeah, beside that, the Y splitters were designed to, like I mentioned, that the where you need one ventilator with the more patients you need to provide service to, then you can use Y splitters over there. And we had a kind of faculty from Brown and also URI were working together on this. And then we had one of my colleagues, Dr. Oli. He designed and his own emergency ventilator out of his garage parts, and he found certain compressors and some electrical components, and he combined them to create an emergency ventilator built up in his garage, literally. And so that was an interesting learning. Now, all of this research, what we did, and then there were students also were very excited, and they created a smart mask out of certain concepts. And this was actually coming out of my lab. So here I'll show you that what masks look like. Of course, it is still prototype. Yeah, so it is like a smart mask with the sensors embedded into it. And what they are interested is looking at the respiration rate. And so I'm going to play this video. You can see. So you are seeing in the back side is a respiration rate. And as you can see, it is going from a slow sinusoidal to the fast, high frequency sinusoidal signals. So your respiration rate goes faster. It was detected. It was a team of different kind of majors, electrical, computer, mechanical, and biomedical engineering all work together to design this mask, and they are still working on this. And they recently were one of the runners-ups in the International Student Design Competition in a IEEE conference recently. So there was a kind of, and I would say another byproduct of the kind of the COVID-related technologies or COVID-related developments we did. So, this is almost, I'm at the end of my presentation. What's next? So what's happening? So out of whatever the activities we did, there is a social enterprises that are being developed. There is one startup which I mentioned. There could be some more startups coming out of our activities. You just saw an example of a student project like that. There are some other student projects are going on in their academic year. And a lot of grant proposals have been written, particularly to really response in response to the COVID-19 pandemic. And the whole thing is that together we have a lot to offer. We just need to build a common mission, essentially, at the end, right? So we can bring people together, but we need to kind of identify that common mission, what we have. And lastly, other than my work life, I also have my own life. So I would like to thank you for listening to my talk, and I'm here to answer your questions.
Thank you so much, Dr. Kunal, sir. Sir, we have a total 13 speakers today. And just believe me, trust me, out of those 13 speakers, yours was really completely different and realistic one. Yours have been given the last slot of the session. So we thought of that the students will hardly come and nobody will put any questions. But believe me, sir, yours is the interesting one. And I'm getting so many questions in my WhatsApp. It's getting overloaded. So I have just picked up the best 3 or 4 one. Sir, kindly, yes, sir, reply them back. One of the student, Abhishek Anand, he's asking, sir, will the radiation from the masks affect humans, as there may be some kind of radiation? So did you...
Okay, so I didn't get the question very correctly. Is it a radiation from the mask?
Yes, sir. No, radiation from outside, sir.
Okay.
What I use, yes.
Okay.
Means sunlight or outer temperature, environmental factors, what I suppose.
Okay, okay, I got it. So there is an interesting research coming out recently from various groups. So one of the groups has identified that I don't know about the external environmental factors, how they impact the mask, but in fact the carbon dioxide in your system, in your lung system, increases when you wear the mask for a long time, and particularly N95 mask kind of thing, which you wear for long term. There are some studies done on the nurses that if they wear those masks, and that's the reason actually you feel more fatigue when you wear mask for long hours. So I think it is important, and this is actually for all of us, it is a learning that we should be actually identifying some short moments that we can go out alone and maybe take some really good deep breath and come back again, because it would be greatly helpful.
Sorry for interruption, sir. Sorry, sir. He's asking about the sensor radiation. Excuse me kindly. He's asking about sensor radiation.
Yeah, I don't know. So if I believe that the student is asking about whether if you have a smart mask, then how in the sensor in that smart mask, how does it impact? We are using in that we are not using any sensor that are anything kind of harmful. Those are all non-invasive sensors. They are not connecting to body. That is one. Second thing, there is of course a wireless part, which is a Bluetooth and Wi-Fi, and I doubt that we are all surrounded by those radio frequencies around us. So I don't think, but whatever the sensors what we have used in the mask are all non-invasive, non-contact sensor with the body.
Yes, sir. Thank you, sir. Another question, sir. How can you assure that 3D printed shield and masks will not pollute the environment, as it will be a new problem which will arise?
I am very sympathetic with this particular comment, and I do agree that there needs to be a sustainable solution. It is plastic. Can it be reusable? I think that is something which we need to start thinking about it. That's the reason I really applaud the work done by our Dr. Manbir Suri, that he came up with this innovative, sustainable mask solution, which is an indigenous material, and then you can actually, essentially you can put it anywhere, and it would degrade by itself in the environment. So that's a fantastic. So that is an example, and I do agree that we do need to find a sustainable solution.
Yes, sir. That's why you have said we should set a common mission, right?
Yeah, exactly. And I do not have answer to it, unfortunately. We do need to find that solution. That I don't know. There are out there. There are there are 3D printing materials out there. They made out of these sustainable materials, but the problem is that they are very expensive, and they cannot be used in a conventional 3D printers. So that's a kind of challenge we are facing. So as the engineering and backgrounds and computer science backgrounds, the students particularly, if you can come up with the affordable 3D printers, they can use this kind of indigenous materials or sustainable materials. That would be fantastic.
Yes, sir. Once again, thank you so much, sir. Sir, let me quickly summarize it, what you have told. Sir, what you have studied till now is the SDLC, right? Software Development Lifecycle. And we used to study it, listen it theoretically. This stage, feasibility, then planning, then design, these all things. But sir, you have elaborately defined what I will call this term as CDLC, Corona Bit or COVID Bitting Lifecycle. And you have explain in that, giving ecosystem you have structurally explained, sir, how to make, how to design, how to make, deliver, And also you have organized inquiry how to order them, then after that ordering the 3D printing sales, then assembly them, then delivery. And not only the delivery, how to compete in the market. Like while we are wearing the normal masks, we feel suffocated because something sweatening inside. But you what you compare very well how to make smart masks or smart sale, how to feel better. So thank you so much, sir, once again. And you have cited so many things like pandemic in Italy, mid-March 2020, ventilator crisis, 3D printed balls, what is voice splitter you have explained, face masks you have given on that really amazing videos, sir. And your talk was really very heart-touching, the realistic one. What we really seek that. Personal protective equipment you have explained very well, and you have set a common mission citing that WebEx meeting you generally do twice a week, brainstorm in design and clinical viability. You have said how to identify needs and that make plan. And so many things you have told, sir. For time constraints, I am not able to summarize all. Thank you so much again. And the students are really feeling excited and have posted so many questions. So dear students, just post the questions in that link. And before that, you have been sent a link for your attendance. Kindly fill up that.
Excellent. Thank you, Dr. Lipika, and thank you so much for inviting me and as well as hosting my talk. I really appreciate also the summarizing what I actually mentioned in my presentation.
Yes, sir. And kindly provide us the opportunity for our student projects regarding this.
Yeah, it will be an honor and my pleasure to interact with KIIT.
So Professor Kunal, I will interrupt here. So I would like to thank our Ravindra Barik sir. Because of him only we can able to reach you. So Barik sir is there here, Ravindra Barik sir. Thank you, Barik sir, because of you only today. So good talk we are able to hear. Thank you. Thank you, Kunal sir. So in hope future also we'll be having further collaborations.
Absolutely. Thank you everyone. Thank you, Dr. Barik, as well for making this connection. And I would like to wish everyone a good evening and safe your life from now onwards, because we are in a post-COVID culture. So I'm hoping that everybody is kind of feeling safe and keeping yourself safe as well.
Excellent, sir. Outstanding ones.
Thank you.
So here we are ending the first slot of the last session. So I would like to invite our second speaker of the slot, Mr. Harsh Mishra. Sir, are you here?
Yes, ma'am, I'm here. Thank you,
Thank
ma'am,
you.
for
Yes,
this.
sir.
And
So,
before I start,
yes, sir.
Yeah, please.
So Harsh Mishra is a wonderful problem solver, and currently he is working as a full stack software developer with high radius technologies. He is having over 2 years of experience. Harsh Mishra, I'm really feeling proud, and we are really proud of announcing that Harsh Mishra is our alumni of the KIT University. So big hand to them on the virtual mode. Harsh's interest is his area of technical interest includes cloud SaaS products, algorithm design, Android development, Java EE, data sciences, and many more. He is experienced in JavaScript and J2EE, cloud SaaS application, B2B payments, Forex payments, order to cash applications, and very well applications he is handling. So we would be enjoying your session, Harsh Mishra. Kindly, now your stage is completely yours. Please.
Thank you, ma'am. Thank you, Lipika, ma'am. I'm overwhelmed with that introduction. And before I begin with, I would really like to appreciate everyone present over here, because this is such a long day, back-to-back sessions, and this being the last of all of them. So thank you for being here. Before I start with, now since we are dealing with a time constraint over here, so I'll quickly start with the presentation or the topic of the discussion for this hour, that is IoT or Internet of Things, Internet of Health Things. So please allow me to share my screen.
Yes, yes, yes.
Yeah, I hope I'm audible to all.
Yes, Harsh, it is audible and it is visible. Your PPT is visible.
Okay, thank you for confirmation, sir. Okay, so I've been told that I've been given close to 25 minutes for this talk. So this discussion will be spanned out in 5 major sections. The first would be introduction to IoT or Internet of Things, Internet of Health things as such. So to give us a background of what we are trying to talk about. Then we will talk about the COVID developments which are already in place or happening around. And then we'll talk about the learning curve which goes upon us because of COVID-19 and discuss some security aspects related to COVID, the IoT development and IoT development in particular. And we'll talk about the project. This fifth section is actually, it was introduced during the presentation only because today only because seeing the nature of the audience, since most of them are students and most of them are my juniors, so I would like to talk about the projects which can be developed using IoT and IoT. So not to begin with, when we talk about introduction to Internet of Things and Internet of Health things, so how we we already have a background, but to Internet and how we came up to Internet of Things from Internet of Human Beings or Internet of Computers. So in 1983, I'll tell you the gradual developments which were going across all over the globe. So in 83, we were introduced to ARPANET. 97, we got introduced to Wi-Fi. 98, we got introduced to Bluetooth. And in 1999, it is called that we have an introduction to IoT as such for the very first time. So what happened from 83 to 99 that led to humans thinking that we can rig Internet to things as such, and instead of human beings, we can have a network of things as well. So that was that we tried to make the devices more and more mobile and robust. We tried to compress things from computers occupying a huge room to personal computers. Then in 97, we had a wireless network, Wi-Fi as such. Then 98, we had Bluetooth. So these developments led to devices which can communicate with each other without being rigged to a wire or something, a very big equipment. So while wireless communication is which enabled IoT for very first time in 1999. There was another very significant development that was done for 99. I'll talk about it in the next slide. So yeah, and IoT. So IoT, we can talk about this right now, that IoT is something that if two devices are communicating to each other without any other human interaction or are self-sufficient to transfer the information, we'll call them as Internet of Things or Internet of devices. And when those devices deals particularly with related to healthcare, we'll relate to them as Internet of Health Things. So which supports the healthcare, so we'll call them as IoT devices. Okay, so 1999, another very major contribution to IoT was MQTT development by some of the IBM engineers. So what they did was they noticed that if we have to communicate from device to devices, then HTTP headers or HTTP protocols are not very much needed because they were majorly developed for human to computer interaction, humans interacting with computers, then in turn computer interacting with other computers, and they were designed to transfer a lot of information. But for MQTT, for IoT use cases, we noticed that we needed something which could operate with low energy resources. We didn't need that much of a bulky header. We had very little information to pass on devices. So it should be swift and robust, and it should not be dependent on something called as client server architecture, which is traditionally followed by HTTP. So they came up with this MQTT protocol, message queue transfer telemetry protocol. It was developed around a publisher subscription model. So what that publisher subscription model was that we had a centralized server analogous thing which we can call as a broker. So a broker would be having a topic or multiple topics, and there would be multiple devices that could publish the data to that broker. So these devices would be the IoT or edge devices as such. So they would be publishing the data to a centralized broker for a particular topic, and there can be multiple consumers which will be consuming this data. So what this architecture did differently from HTTP client server architecture was that it decoupled the devices. So we can have multiple devices, even if few of them went down, it won't have an impact to the other devices unless until the broker is up. So as long as our broker is up, we are good to go with that. So this MQTT was a great leverage as compared to the HTTP, which throttled the IoT development in a really, really great way. And when we talk about the numbers, we got we were informed that it, if we consider the 3G standards, so it performs.
Sir, you are not audible. I think some network issues.
We can wait 2 minutes. We can wait.
Yes, sir.
Harsh, you are there?
Mr. Hers, can you hear us?
Maybe some network issue. We can wait for some time, ma'am.
Yes.
I'm just calling him. I'm calling him.
From our end, we could share the slides, sir, if you want them.
He's connecting. He's connecting.
Yeah, kindly excuse me for that disruption. There was some network issue at my end. So I think we discussed MQTT and it was audible to everyone before I disconnect. Yeah, okay.
Yes.
Okay, so now we'll talk about some pre-COVID developments in IoHT domain as such specific. So as I said, that MQTT was being developed and people were developing new protocols, new devices for IoT, and even for healthcare, people were coming up with solutions. So what particular domain that engineering or devices that can aid the healthcare workers or healthcare in particular, that was pretty much the monitoring and reporting cycle of that. So any action which the healthcare workers, the physician or the doctors, they take, it depends on the data that is provided to them, the information that is led to them. So it is dependent on the state of the particular body that is infected from any disease, not just COVID-19, but any disease. Whatever information we have about the disease, whatever information we have about the patient, that aids a lot to the physicians or the doctors which are going to take the decision to cure them. So in that particular domain, in the specific to monitoring and reporting cycle, IoHT devices were proved to be of great help. We are going to talk about two such really revolutionary developments, I would say, and we'll discuss them in detail. So one of them was cyber infrastructure for comparative effective research. So this was a research carried out in Anderson Cancer Center in Houston, Texas, and this research was direction to they divided the cancer affected patient into two pools. For one pool, they decided that they'll be undergoing the traditional treatment and the orthodox way of reporting our physical visits. And to the other pool, they provided them with devices. There were blood pressure cuffs, weighing scales. Those were Bluetooth enabled IoHT devices. They were in turn talking to their cell phones, the cell phones of the patient. So they were sharing the data frequently to their cell phones. That cell phone was having an application which was in turn transferring this information to a repository to the hospital. So so what happened was there was a frequent flow of information from that end body or the patient's body to the person who is going to take the decision. So compare it with a scenario where a person is going to go for a physical visit, where he is bound to go for a physical visit. So the frequency of information or actionable information which is going to flow from that particular infected body to the doctor who is going to take decision, this frequency is more than that compared to that of a physical visit. So this was proved to be of great help, and they came to the conclusion that this type of architecture, this not only helped the patient that they got rid of, because cancer is a terminal disease, and the particular pool of patients which they were in experimenting on, they were having neck and head cancer in particular. So such kind of disease, the patient is really pained to travel. So that traveling was reduced to a great extent when we compare with that to the orthodox methodology. So these devices, they have a streamlined flow of information to the doctor. So that doctor or the healthcare workers, those who are dealing with those patients, they had much more information to deal with. They had much more actionable information to come up with conclusion and take actions accordingly. And the reaction was also swift. Let's say there was some particular variation which was not normal. So the corresponding reaction was it took lesser time than that it would have taken on a normal physical visit. So this was one. We can read about this psycho research in detail. I've added references. I'll share it after the talk as well. And then there was another development. This was a remarkable development as DIY pancreas system. So it was introduced or created by Dana Lewis along with her husband. So she was a diabetic patient. So what diabetic patients like have a problem with their glucose levels. So they need to constantly monitor their glucose level. And in order to like regulate it, they get induced with insulin. So there has to be insulin administered into their body based on their glucose level. So there can be glucose level more than the normal. There can be glucose level lesser than the normal amount. So there are devices. Yeah, and okay, so before I can talk about DIY pancreas system, there are already some devices which are called as GCM devices, which do the automated monitoring of your glucose level. So Dana Lewis was having one of such devices. What that device did was it monitored the glucose level of that individual, of the particular person who is taking care of it, and then it shared the data over a cell phone or over a mobile application. So that was already there. What she did was she, along with her husband, they developed a software which, along with that like analytics to that particular mobile application shared from that GCM device, that software created the entire loop. It controlled an insulin pen and administered the amount of insulin that needs to be administered to that particular patient body. So it regulated the amount of insulin there. So if you're following me, then see. So first, what that device did was it took the amount, it took the like value of blood glucose level from that particular body. That device then shared that information to the cell phone application. That application then again triggered another software, which in turn regulated an insulin pen and instructed that pen to like regulate the amount of insulin to be administered into the patient body. So it was a closed loop structure. It was like automating the entire process. So it was of great help. And in a very particular situation I would talk about, that is, we like in healthcare terminology, we can call it as nighttime hypoglycemia. So what happens in this case is that patient's blood sugar level can dip suddenly during the nighttime. So there has to be a caretaker, or the patient has to be alert, and they need to continuously or frequently monitor their blood glucose level. So with the use of this end-to-end closed system, that was really this process was really simple, and patient can have a nice peaceful sleep. So it was a revolutionary step taken by her, and she they called it as the DIY pancreas system. So these developments were already being done in IoHT domain even before COVID-19, and people were experimenting with BLE beacons. So BLE is Bluetooth Low Energy. It is how it is different from normal Bluetooth is that normal Bluetooth, we have an end-to-end communication between two devices to share like information. There is a pairing. We can, if you relate to mobile Bluetooth, you can see that there is something called as pairing. We need to pair the other device to share information and all such things. BLE or Bluetooth Low Energy devices, what they do is that they share a low energy radiation, or they emit a low energy radiation, and devices coming in contact with it, they can transfer the information. So these are like beacons, we can call it as beacons only. And then we have RFID tags as well. So RFID tags was disrupting the supply chain management business. And okay, now COVID-19. So since morning we are learning about what all changes COVID-19 brought to us, and it was practically a doomsday scenario. But apart from all the negatives, the only positive thing COVID-19 did was it induced a steep learning curve across all the domains, I would say, not just healthcare, not just industry, not just technology. The whole working scenario got revolutionized, or people were thriving, people were trying to work out the alternatives even when they were not at work. So for example, any such change, which on a normal situation would have taken a few years to implement, it was implemented in days or weeks. So that was a kind of impact COVID-19 had on in the entire society. Let's say, yeah, so for an example, we can take the thing of remote working. We are connected on a digital conclave from a remote environment, and we are working, everyone is working remotely. So this thing on a normal situation would have taken more than a year to implement, but for COVID-19 situation, it took few days to implement. So same goes up for the IoT and IoHT learning curve as well. There were challenges being faced in the healthcare industry, and people all around the globe were trying to come up with solutions. As the eminent speaker before me, he was duly pointing out the developments being done in garages and all the solution he implemented. So similarly, all the researchers are across the globe, they were trying to come up with solution in the best possible way they could. The solutions they ranged from contact tracing, remote monitoring, incident reporting, And one particular word or one particular phrase that was very common across the media, that was flattening the curve. People were very obsessed with flattening the curve as such. All the electronic media or social media, you'll come across that flattening the curve. That itself signified that how this pandemic was different with what history has like witnessed, because not just this curve or this flattening the curve phrase, it was not just related to data scientists or not just related to statistical analysts all over the world, but all the like common people who are not very much like related to technology. Even they were like really concerned about the daily numbers, and they were observing the curve. So they were really into statistics. They were trusting the mathematics and statistics this time. So this pandemic, the data science had a great impact over this pandemic and the learning curve, subsequent learning curve. So next particular thing, the very important step was contact tracing. This was a great challenge because till now we never faced a situation where we like thought of using technology to do the contact tracing. Previously also when we had epidemics or we did the contact tracing manually. This time, since I was like, why I was telling all the gradual development which was taking place in IoT is that we already had BLE devices, we had Bluetooth devices, we have device-to-device communication, we had MQTT and all that architecture taking place. We had data streams which can like handle tons of data. So that architecture was already in place. So researchers all over the world, they try to come up with solutions that why don't we take leverage of these devices and to ensure contact tracing. So we had one such application in India as well, and it was similar kind of devices, be it a device or a mobile application. So that application was in turn using mobile Bluetooth service only. So that's what I was telling, that Bluetooth devices or BLE devices, their invention or their discovery proved to be of great help for this contact tracing in particular. And still people are researching, and how important this particular topic was, we can decide or we can like figure it out that tech giants like Google and Apple, they combinedly like came up with a solutions methodology to devise a contact tracing application or contact tracing architecture. They have made it public. It's available as a PDF. We can download and go through it. They are using encryption keys so that the patients, the particular subjects or the application using individuals' privacy can be contained there as well. So contact tracing was a new thing which got really like phased out in COVID-19 times. And yeah, another part was ventilators. As the speaker before me, he was he pointed out that people were facing shortage of ventilators all across the globe, and it was not just in India. And India, the problem was very much severe because of the population we are dealing with. Various other speakers have also pointed out that India's case was different because the population density India is dealing with. So we were facing shortage of ventilators, and people were trying to come up with solution like the Y splitter. He pointed out to procuring new ventilators. So some of the people, what they did was they tried to rig up like a small scale ventilators, or we can say as cost effective ventilators. One of those industries was AGVA based out of New Delhi, and there were other research institutes also which were trying to explore like the feasibility of a portable ventilators. So they came up with IoT enabled ventilators. So what like the special part about this ventilator was that the very basic problem with COVID-19 was that we cannot we need to ensure the distance. Even the healthcare workers, even the doctors who are treating the patient, they need to maintain a distance. This can be contracted just by compromising the distance with the infected body. So there was shortage of PPE kits as well. So these ventilators, the speciality of these ventilators, apart from cost.
Sorry for interruption.
Yeah,
please pardon me. Sir, as we are running late, sir, so kindly squeeze the slides, sir.
Okay, fine. I'll try to wrap up as quickly as
we have
possible.
only 5 minutes, sir. We have.
Sure. I'll try to.
For inconvenience, sir.
Yeah, no issues. Okay, so these ventilators, I'll quickly wrap it up that they were IoT capable, and they were capable of having remotely monitored systems. So healthcare workers could administer these ventilators sitting in a remote position and need not to be present along with it. So it was much more convenient. And we have a long way to implement them in coming time, and we can use them in coming time for other use cases also. So this learning curve was really helpful for which was induced because of COVID-19. Another was GIS. So geographic information system is that when we relate information with the geographic or geospatial data. So with this, what we could achieve was that we could impart better administration. So this particular solution was really helping the administration or administration bodies to take valid decisions. So what GIS, since we are short of time, I'll quickly navigate to what. So one of such companies which were experimenting with GIS and like coming up with solutions for administrating bodies was hexagonal geospatial, and I came across one of their products as such. So they had this incident reporting solution, GIS enabled solution, so which had a contribution of devices, even people with their cell phone. So it was a wide network of people sharing data, devices sharing data, and those data combined with the geospatial data, and they come up with this dashboard so that the authorities can be well informed about what is happening, where are the shortage of supplies, what action do we need to take, what is the analytics, and as such that. So GIS was also its full phase during this COVID-19 times. And security. Okay, so since I'm going to slide my presentation, I'll discuss about the security aspect and end it here. So security aspect, why? Okay, so anything which we are going to develop in in information technology, any software, anything related to IT you develop, you will have to ensure security. That is fine. But why security is special for IOHT in particular? Because you are going to affect lives directly over here. So you cannot have a false safe condition over here. You cannot have a failure condition over here. So it has to be right 100% of the time. We cannot have a 99.99% success rate. So one of such situation, which is a learning event for us, is that St. Jude Medicals, formerly St. Jude Medicals, now it is known as Abbott, they had this really nice pacemakers which were implanted into patient's body, and they had RF communication capabilities. So that those pacemakers, which were supposed to aid the heartbeat of the particular patient, they can communicate to a transmitting device which is present in that patient's home, and that transmitting device is communicated to a network, which is a hospital network, or we can call it as PCN, patient care network, so that like doctors or the healthcare workers, they can take a look of all the patient's data, and they can control the pacemaker, let's say like change the pace rate, and call the patient for any checkup in case of any abnormalities. So this was a revolutionary step. They had a great IoT device in place. It was a great IoT implementation. What happened was after a few times or after a few months, we were it was identified that their architecture. Okay, so we can look at this architecture. So these were the pacemakers which was implanted into patient's body. They in turn were in contact with this home transmitter. This was like a Merlin home network. So they were contacting over RF frequency, and this network or this transmitter was again transferring this information to Merlin.net PCN, patient care network. So this PCN network was being accessed by physicians or clinic healthcare workers. So what happened was we later on it was figured out that this home transmitter, this was not very safe, and this was not very built across very safe architecture or safe software. So there were intruders could easily penetrate this particular transmitter, and they can get the control of this pacemaker, which was it could have been catastrophic. They can change the rate at which this pacemaker is affecting the heartbeat. They can change the power consumption of the battery consumption of this pacemaker. So all the pacemakers, they were called back in introduced with more secure softwares, and firmware upgrades were provided. So this is an example why we need much more secure network for IoHT in particular than compared to other software products. So yeah, okay, so I can conclude with my presentation over here. And before concluding, I would like to talk about some projects and what we can do. So I would like to thank Siddharth sir and Manjusha ma'am in particular for during my college days, they gave me an opportunity to work for a project in ICDC IT conference, and what was supposed to be just a rough project for that conference, it ended up giving me a patent for that. So similarly, we can have IoHT devices developed for this particular situation. It's like a really bad scenario for all of us across the globe. But again, it's a great opportunity to come up with revolutionary solutions. We can have remote, we can come up with ideas such as remote test kits or social network based on contact tracing or something like that. So with this, I would like to give over the stage to Lipika ma'am again. Thank you for having me here.
Thank you so much, Mr. Hers. Yes, Mr. Hers, you have explained so lucidly and flawlessly all the technical terms which the real challenge we are facing now. We were aware of simple Internet of Things, IoT, but you have given the very specific domain of IoT, that is IOST, Internet of Healthcare Things. So you have also highlighted the life cycle of Merlin patient care network, and it was really needed for the time of this pandemic situation. You have given three important major factors in today's talk, that is introduction and comparison of IoT and IOST. Apart from that, two protocols, MQTT over HTTP. Then you have explained very well things and internet relevance. You have also elaborately told that what are the pre-COVID developments. Your slides were really amazing. It was full of resource for the technical students, for the resource PhD scholars, for the faculties like us. Thank you, Mr. Hers, for due to time constraints, I had to interrupt you. Sorry for again that.
That's fine,
Yes.
ma'am. Thank you for having me here, and thanks Siddharth sir and entire DSG group.
And before quitting the session, students were really enjoyed your session, so they have put certain questions. So
sure, ma'am.
I'm just asking the few one of them. Someone is asking how IoT devices can be made secure, which you have explained in the last slide.
Yes, so actually because of time constraint, we couldn't get into details of those security methodologies. But
Yes.
So the current development process or the current architecture which is being followed after such events. So what people did was they ensured device-to-device authentication, like we had SSL and all those encryption and all those secure transformation, like information transfer for human interaction. We had similar action in place for devices as well, device-to-device encryption and encrypted authentication for even device-to-device. We need to implement those.
Yes, very nice. And last questions. Can common people suffering from cancer afford this kind of architecture?
Well, that is a very broad question, I would say, because cancer can be of multiple types. It can be of, we need a healthcare expert to comment on that. But yes, if we, what particularly IOHT can help them with is that the reporting cycle, which is what I was explaining there, that if they are having something which can be physically monitored, let's say their weighing scale, their weight needs to be monitored, their blood pressure needs to be constantly monitored. There, for sure, IOHT can aid them in a great way.
Yes. Thank you, Mr. Hers. You have handled the questions so well. And
thank you.
Yes, for the time unavailability, have to close the session. Thank you so much. You have given so much of researchful information to us. And if such opportunity, we'll call you upon.
Sure, ma'am. Thank you. Thanks a lot. Thanks a lot.
And congratulations, and thank you again for that patent second runner-up for that domestic IoT project.
Actually, like a lot of people have to be credited for that, ma'am. Thank you, Siddharth sir, and all the ICDCIT people, Samresh and sir. Thank you.
So last but not the least, I would like to extend my special gratitude, my special thanks to all the speakers, especially Dr. Kunal Mankudia and Mr. Hers Misra for delivering such an amazing talk. I would fail in my job if I wouldn't express my thanks to my heartful thanks, especially to Dr. Siddharth sir and Manjusha ma'am. Although I have experience in other organizations, but I'm just like a toddler for this KIT University. But still, they have kept faith, trust, and confidence in me. And since the last workshop, they have supported me a lot. So thank you so much for providing me such an opportunity to be part of this team. I'm learning, and I hope in future I will be learning in that. I will enhance this teaching learning ability with this research skills as well. And many thanks at the end, my students, my mentors who have please maintain discipline. Yes. And I really want to heartful thanks from my core of heart to all the audience, my students, mentors. At the end, I requested them to join, and they immediately followed my instruction and joined here. And also they enjoyed the session and also put questions as well. Thank you so much once again, and we had really a successful workshop and event today updated by the data science group team. Thank you so much.
Thank you, Lipika ma'am. Samresh sir is there. I think sir will be just, we would request Samresh sir to give his last words for this conclave. I think we all enjoyed a lot this whole day. Means we are not feeling tired after going from morning 9. But when we see our students, the way they are giving the talks, we are getting more energetic. I think that is the strength what we are getting from this conclave. Means it has been now 7 from morning 8 o'clock. Our faculty members and our student coordinators all are sitting and listening. But by seeing the students, the way they are performing, and the resource persons who are there, it's really enjoyable day for all of us. What I feel, and I'm grateful to especially to Samresh sir, because he has always given us a free hand that whatever we are able to perform. we are able to do. So we are always thankful to our director, sir, because he has always given us this free hand to conduct whatever the workshops, conferences. Whenever I have approached him, he has just directly said, okay, you go, you do whatever you want for the benefit of the school. So thanks a lot, Samresh sir. I just request you to give some ending words to this conclave, and hope we'll continue this in future also, and we'll be involving more student alumni on these events. Sir, please.
So thank you, Dr. Siddharth. So in fact, I joined late this second part. Okay, I had some work that I left.
Sir,
But the
Harsh is there.
last 5 minutes, I was listening from Horse Mr. So I am very happy.
Okay.
So after a long time, I saw Horse. How are you, Horse? Are you fine?
Yeah, perfectly fine, sir.
Good, very good. So just remembering those days when Horse was a student, fine. And not only he was very good academically, but he was involved in so many extracurricular activities. So that is the beauty. I mean, so I can say it is a complete complete student was their Horse at that time. And today also, I hope that he's doing well and he will do much better also in future.
Sir, you remember his paintings? Paintings, you remember?
Painting, I remember, right? Painting, okay.
Thank you, sir.
So I remember that welcome session. I mean, first year welcome also he did. Fine, that
Yes,
painting
yes.
also. And once also in our open air theater, I think.
Yes,
Another painting also done. So it is a nice that our alumni, they contributed, they supported in a big way. And that is the credibility. We feel we are we are very fortunate because our alumni, they have come forward to contribute. The way Horse, I was just sharing, 2 hours before in another the interaction, that I want that the data science laboratory. I mean, we'll set up a new separate data science laboratory where not only the name of the faculty who are involved will be written, the faculty name, the PhD scholars, the MTech scholars, the BTech students who are also involved, because during your time also there are 9 prototypes developed by the data science group. Okay. And those names along with the alumni who are going to contribute or who are going to be attached to the lab. Getting the point? The institute is yours, remember. The department is yours, institute is yours, it is your school, your university. So how you are going to contribute academically, that is very, very important, because our next generation, because every student, they are the future of the country. Okay, so every child is important for us. Every student is precious for all of us. So how we can provide the support collectively as a teacher, as a parent, as a alumni, as a you can say academic administrator. So everybody's response is that fine. So let us collectively also increase this one. So we have planned many more things to do in future, particularly the laboratory and the high-end laboratory would like to set up for the development of students. Because right now the companies, they are coming, they want, I need the people on data science. So we have to project, okay, we have 100 students are there who are very good in data science. People are coming, they want, we need people on cognitive computing. Let's say AI, your deep learning, your machine learning. We can say, okay, we have 50 students who are very good in those areas. So now that is the trend. Now it is not a trend only to join in mass recruitment companies. Rather, let us prepare ourselves to be acceptable by the very, very specialized company, as well as student can go for higher studies. So many thanks to all the alumni, first of all, because they joined as a resource person, and some of they joined as a to support this data science conclave, which has been conducted for the first time in the KIT by our school. And my thanks to Dr. Siddharth, Dr. Manjusha, and all my faculty colleagues like your Lipika, our Krishna Madam, our Bindu Agrawal, our Butwani Madam, our the Java expert, Mahindra sir. Okay, Mahindra sir, Gorisriya. And remember, the success always depends on the participants. Fine. So that's why all credit goes to all the students, because they are because they have shown their interest. They wanted to participate. That's why we were able to organize or conduct it successfully. So this will continue. I request Dr. Manchusa as well as Siddharth to continue this one, and let them expand horizontally as well as vertically the size of the data science laboratory. Fine, whatever support the KIT will provide, all support, and always feel it is our family and we are working together. for the benefit of our future. Fine. It is not my future. So future of our young generation. Clear? Okay. Thank you all for your support, for your contribution. So it was a wonderful interactive session. Many what? I forgot Amya Das also is there. Amya Das also from the beginning. And Anushka Mishra, na?
Anushka Mishra, student coordinator.
Mishra, yes, student coordinator. Good. Anushka Mishra, all the student coordinator that did very well. I mean, that is, I mean, the data science group is handled, monitored by the students. That is the beauty. Fine.
Yes.
So now you find out who is the data science group. You identify different or give different type response to different student groups. Some of can do the product development. Some of can lead the your that is called research part. Some of can train, because some many training activities also you can run from the data science group. Fine. It is not only the students of KIT. Not only our schools, students from different schools, students from outside KIT, outside Bhubaneswar, let them come and join. Even if the students from foreign institutes also, they can come during summer and winter, spend some time. We can prepare some capsule course like 15 days or 1 month. Okay, for them. Okay, now thanks to all. It was a wonderful interactive session. We will remember forever and your contribution. So we say hip hip hooray your part, your data science lab and data science group. Thank you.
Thank you, sir. Thank you so much. Thank you all the participants for joining this event. Thank you, my student coordinators, esteemed faculty members, for all your support. We'll continue this in future also. So by this, we come to an end and we thank everyone. So we'll be closing the sessions. Sir, with your permission, we are now closing the meeting.
Okay, thank you.
Thank you, sir.
Thank you.
Thanks.
Thank you, Abhishek Anand, for coordinating and keeping me updated throughout the session. Sorry, I forgot to mention you. Amya Anand,
Amya sir, sir, आपको पचार चले.
हाँ, Amya sir पर मुकाइली.
Sir. Okay, sir. Okay. Thank you.